So today we'll be discussing the basics of optimization. That is mainly, roughly you can call it maxima minima. So we'll be talking about optimization. Okay, so optimization में mainly आप you talk about unconstrained optimization, unconstrained and constrained optimization. तो डिफरेंस इज कि अनकंस्ट्रेंड में देर इज़ नो कंस्ट्रेंट, देर इज़ नो कंडीशन, एंड कंस्ट्रेंट में जो भी आपका ऑब्जेक्टिव फंक्शन है उसको मैक्सिमाइज या मिनिमाइज करते हुए यू हैव सर्टेन कंडीशन जो आपको साथ में अलग से सेटिस्फाई करनी पड़ेगी बिफोर रीचिंग अ सॉल्यूशन. ओके, सो दैट्स व्हाई इट्स कॉल्ड अ कंस्ट्रेंड ऑप्टिमाइजेशन. ठीक है. सो at first we'll be looking unconstrained optimization problems. Unconstrained optimization problems. Okay, तो optimization में mainly we do two things. One is maximization. Suppose we have a function fx and उसका जो मैक्सिमा है, जहाँ पर वो जो मैक्सिमम वैल्यू एग्जिस्ट करती है, मैक्सिमा इज अटेन्ड एट एक्स पर सम पर्टिकुलर एक्स कॉल्ड, लेट्स कॉल इट एक्स स्टार. तो मान लो एक्स स्टार पर हमारा मैक्सिमा है. ओके, एंड सिमिलरली ऑन द अदर साइड लेट्स टॉक अबाउट अ मिनिमाइजेशन प्रॉब्लम. कि वी हैव अ मिनिमाइजेशन प्रॉब्लम जहाँ पर हम मिनिमाइज कर रहे हैं एक फंक्शन कॉल्ड जी एक्स को. ओके, सो वी आर मिनिमाइजिंग जी एक्स and let's say minima is attained at again x equal to some x star. Now how the two problems will look like, how the whole situation will look like, we need to talk about that. Okay, तो उसकी बात करते हैं. Okay, so for the maximization problem, the situation might look like this. कि एक्स स्टार पर फंक्शन अपनी मैक्सिमम वैल्यू अटेन कर रहा है. ओके, एंड द मिनिमाइजेशन प्रॉब्लम might look like this. This function is gy. Here we have x, here we have y. Okay, तो we know about increasing decreasing, right? सबको पता है increasing decreasing के बारे में. तो see here we have all x which are less than x star, right? And to the right of x we have all x which are greater than x star. तो ऊपर जो हमने यहाँ फर्स्ट पैनल में हमारे पास जो सिचुएशन है दैट्स अबाउट द फंक्शन. हम वहाँ दिखा रहे हैं कि फंक्शन कैसा दिख रहा होगा. उसका मैक्सिमा कहाँ पर है, उसकी मैक्सिमम वैल्यू ये है. ओके, सो दीज थिंग्स. बट ऑन द लोअर पैनल आई एम गोना शो dy by dx. Okay, roughly how dy by dx will look like, जहाँ पर dy by dx is the slope. Okay, तो वी नो कि जहाँ पर मैक्सिमा या मिनिमा होता है वहाँ पर स्लोप ज़ीरो होती है. तो कोरस्पॉन्डिंग टू एक्स स्टार पर जो स्लोप आएगी वो ऑब्वियसली ज़ीरो आएगी. ठीक है, तो dy by dx इज ऑन द वाई एक्सिस. वी नो कि एक्स एक्सिस पर जो भी वाई एक्सिस पर जो भी वेरिएबल है उसकी वैल्यू ज़ीरो होती है. ओके, तो दिस टाइम वी हैव स्लोप ऑन द वाई एक्सिस. तो एक्स एक्सिस पर यानी कि इस पॉइंट पर जो स्लोप होगी वो ज़ीरो होगी. राइट, इसके अलावा नोटिस दिस, we have positively sloped tangents to the left of x star. करेक्ट, तो इसका मतलब टू द लेफ्ट ऑफ x star जो डेरिवेटिव आएगा वो पॉजिटिव आएगा, है ना. व्हाट आई एम सेइंग इज कि यहाँ पर जो स्लोप है फंक्शन की वो पॉजिटिव है, और उसके बाद यहाँ पर जो स्लोप है फंक्शन की वो नेगेटिव हो रही है. तो यूजिंग दैट वी कैन प्लॉट द होल थिंग लाइक दिस कि एक्स स्टार से पहले स्लोप इज पॉजिटिव, फिर ज़ीरो पर पहुंची एक्स स्टार पर, एंड देन एक्स स्टार के बाद स्लोप बिकम्स नेगेटिव. बिलो एक्स एक्सिस नेगेटिव है, अबव एक्स एक्सिस स्लोप की वैल्यू पॉजिटिव होगी, एंड ऑन एक्स एक्सिस स्लोप की वैल्यू ज़ीरो होगी. ओके, सो व्हाट दिस इज शोइंग यू इज कि यहाँ पर dy by dx, here dy by dx is positive. On this point x star, dy by dx is 0, that is at x star, and to the right of x star, for x more than x star, dy by dx is actually negative, below x axis. Okay, and for x less than x star it is positive. क्या ये पूरी सिचुएशन समझ में आ रही? Is the situation clear? Yeah, great. Now what about the second order condition? तो जो अभी हम यहाँ पे निकाला है हमने, दैट्स कॉल्ड FOC, फर्स्ट ऑर्डर कंडीशन, यानी कि फर्स्ट डेरिवेटिव, उसे फर्स्ट ऑर्डर कंडीशन भी कहते हैं. तो लेट्स एनालाइज दैट एज वेल. तो लेट्स टॉक अबाउट सेकेंड ऑर्डर, यानी कि d2y by dx, SOC, सेकेंड ऑर्डर कंडीशन की बात करते हैं. सो नोटिस यहाँ पर हो क्या रहा है कि फर्स्ट डेरिवेटिव जो है दैट्स डिक्रीजिंग. सी दिस, पहली बात तो आपको यहीं से पता चल जाएगा. पहले ग्राफ को देखो, ग्राफ की शेप कैसी है, दैट्स कॉनकेव. ओके, ये कॉनकेव है, दिख रहा है हमें साफ साफ. तो ऑब्वियसली यहाँ से सीधी सी बात ये निकल कर आती है कि जो सेकेंड ऑर्डर है डेरिवेटिव दैट्स नेगेटिव, तभी कॉनकेव बना है. ये हमें पता है कि सेकेंड ऑर्डर डेरिवेटिव अगर पॉजिटिव हो तो कॉन्वेक्स, नेगेटिव हो तो कॉनकेव. राइट, यहाँ पर क्लियरली कॉनकेव शेप है, सेकेंड ऑर्डर जो आपकी डेरिवेटिव आएगा दैट्स गोइंग टू बी नेगेटिव. बट लेट्स अंडरस्टैंड कि क्यों. ओके, सेकेंड ऑर्डर डेरिवेटिव क्या होता है? सेकेंड ऑर्डर डेरिवेटिव इज फर्स्ट ऑर्डर डेरिवेटिव का डेरिवेटिव. करेक्ट, जैसे एफ डैश क्या है, एफ डैश इज डेरिवेटिव ऑफ द फंक्शन. सिमिलरली सेकेंड ऑर्डर डेरिवेटिव क्या है? डेरिवेटिव ऑफ द फर्स्ट ऑर्डर डेरिवेटिव. ओके। जब आप बोलते हो एफ डैश नेगेटिव है, ओके, व्हाट डज दैट मीन कि एफ डिक्रीजिंग है। जब आप बोलते हो कि एफ डैश पॉजिटिव है, उसका मतलब क्या निकालते हो आप कि जो फंक्शन है वो इंक्रीजिंग है, ओके, तभी उसका डेरिवेटिव पॉजिटिव आया। सो नाउ व्हाट वी कैन क्लियरली सी इज जो फर्स्ट डेरिवेटिव है दैट्स अ डिक्रीजिंग फंक्शन, ओके। अगर फंक्शन जब डिक्रीजिंग होता है, अगर फंक्शन जब डिक्रीजिंग होता है तो उसका डेरिवेटिव नेगेटिव आता है, ओके। सिमिलरली अगर एफ डैश डिक्रीजिंग है तो उसका डेरिवेटिव डिक्रीजिंग आएगा। तो दैट मीन्स इसीलिए आपको जो सेकंड डेरिवेटिव है वो आपको नेगेटिव मिलता है। क्या ये बात क्लियर है? आर यू एबल टू रिलेट द सेकंड ऑर्डर कंडीशन विद द फर्स्ट ऑर्डर कंडीशन? सेकंड ऑर्डर कंडीशन, सेकंड ऑर्डर के लिए फर्स्ट ऑर्डर फंक्शन है, ओके, जो कि डिक्रीजिंग है, तो इसीलिए फर्स्ट ऑर्डर का डेरिवेटिव नेगेटिव आ रहा है। क्या ये बात क्लियर है? इज इट फाइन? और शैल आई रिपीट? ओके, तो लेट मी रिपीट दिस। पूरी बात ना अलग से समझते हैं। देखो, एक फंक्शन है, अगर वो ऐसा होता है तो दिख ही रहा है कि डिक्रीजिंग है, तो हम बोलते हैं कि उसका जो डेरिवेटिव है वो नेगेटिव आ रहा है, और इसका मीनिंग क्या है? एफ इज डिक्रीजिंग, ओके। ये सबको क्लियर होगा? आगे बढ़ते हैं। तो अगर ये मान लो जो डी वाई बाई डी एक्स है, जो कि हमारा एफ डैश है, मैं इसका नाम रख देता हूँ, लेट मी कॉल इट जी फंक्शन, ओके। तो अब जो हमारा जी फंक्शन है वो ऐसा है ना, ऊपर जाके दोबारा दिखाता हूँ मैं आपको। जो हमारा ये जो जी फंक्शन है वो दिख रहा है डिक्रीजिंग है, ओके। तो हम क्या बोलेंगे? जी डैश इज, क्योंकि दिख रहा है फंक्शन का डिक्रीजिंग है तो उसका जो डेरिवेटिव है वो नेगेटिव होगा। अब जी डैश में जी क्या है? जी डैश इज नथिंग बट एफ डैश, ऊपर डैश लगा हुआ है तो एफ डैश का डैश, तो दिस विल नथिंग बट एफ डबल डैश। तो इसका सिंपली मीनिंग क्या निकला कि एफ डबल डैश नेगेटिव होगा, ओके। तो एफ डबल डैश इज नथिंग बट स्लोप का स्लोप, ओके। तो अगर डेरिवेटिव डिक्रीजिंग है तो सेकेंड डेरिवेटिव नेगेटिव आएगा। दैट्स व्हाट वी आर सेइंग। क्या आप बात क्लियर है? ग्रेट, तो अब क्लियर है, ओके। मूविंग ऑन। सेम काम जल्दी से हम मिनिमाइजेशन वाले के लिए कर लेते हैं। देखो, ठीक है, मिनिमाइजेशन वाला देखो। तो यहाँ पर अच्छा, पहले तो डेरिवेटिव देख लो। देखो क्लियरली यहाँ पर डेरिवेटिव कैसा है? इट इज नेगेटिव, ओके। यहाँ पर डेरिवेटिव नेगेटिव है, यहाँ डेरिवेटिव ज़ीरो आएगा, क्योंकि यहाँ जब आप टेंजेंट बनाओगे तो वो फ्लैट टेंजेंट बनेगी, उसकी स्लोप ज़ीरो होगी। उसके बाद जो इस पार्ट ऑफ एक्स मोर देन एक्स स्टार के लिए डेरिवेटिव पॉजिटिव है, एक्स लेस देन एक्स स्टार के लिए डेरिवेटिव नेगेटिव है। उसके बाद पॉजिटिव है, एक्स स्टार पर ज़ीरो है। दिख रहा है साफ साफ? चलो फिर आगे। तो दैट मीन्स इस बार चीज़ें जो हैं दे विल स्टार्ट फ्रॉम नेगेटिव एंड मूव टूवर्ड्स ज़ीरो एंड देन पॉजिटिव लाइक दिस। बिल्कुल सही बन गया। ओके, ये देखो यहाँ हम क्या प्लॉट कर रहे हैं, यहाँ पर हम dy बाई डी एक्स यानी कि g डैश की बात कर रहे हैं, इस फंक्शन के डेरिवेटिव की बात कर रहे हैं। ये जो फंक्शन है x लेस देन x स्टार के लिए उसकी स्लोप नेगेटिव है, तो ये जो स्लोप है वो x एक्सिस के नीचे यानी कि नेगेटिव है। यहाँ ज़ीरो होता है ना, इधर चीज़ें बिलो दैट dy बाई डी एक्स इज below that dy by dx is negative. At x star dy by dx is 0. Then for x more than x star, इन वाले x के लिए for these x, here the dy by dx, ये देखो फंक्शन वहाँ पे इंक्रीजिंग है तो dy by dx पॉजिटिव आ रहा है, तो इसलिए ये नेगेटिव स्लोप से शुरू हुआ, नेगेटिव स्लोप से शुरू हुआ, then slope is 0 at x star, slope is 0 at x star, and then slope is positive after x star, and then slope is above x axis यानी कि positive for x more than x star. Okay, so that's how it is. So is the graph for first derivative clear? ओके, एंड देन नाउ इट इज़ क्वाइट ऑब्वियस, हमने बहुत डिटेल में डिस्कस कर लिया। अब ये जो नया फंक्शन है, मतलब ये भी एक फंक्शन ही है ना, चाहे ये इनिशियल फंक्शन था g, उसको डिफ्रेंशिएट करके एक नया फंक्शन मिला g डैश, तो ये भी एक फंक्शन ही है, और ये वाला जो फंक्शन है वो इंक्रीजिंग है, तो इसका जो डेरिवेटिव आएगा वो पॉजिटिव आएगा, तो बात खत्म, g डबल डैश इज पॉजिटिव। ओके, इंक्रीजिंग है तो इसका जो डेरिवेटिव आएगा वो पॉजिटिव आएगा, बात खत्म। और यू कैन ऑल्सो सी कि इसकी जो शेप है वो कॉन्वेक्स है, कॉन्वेक्स का सेकंड डेरिवेटिव पॉजिटिव ही होता है। इज इट फाइन? इज द होल थिंग क्लियर नाउ? इज द होल थिंग क्लियर नाउ? ओके, सो नाउ अब एक चीज़ नोटिस करो आप, दोनों ग्राफ्स में जो चीज़ कॉमन है वो है कि फर्स्ट डेरिवेटिव दोनों में ही ज़ीरो आ रहा है एक्स स्टार पर, जहाँ पर मैक्सिमा है। नोटिस इन बोथ द ग्राफ्स दैट एक्स स्टार इज दैट डेरिवेटिव एट एक्स स्टार इज ज़ीरो, और उसी को हम कहते हैं, इसीलिए उसे हम कहते हैं नेसेसरी कंडीशन। आपने पढ़ा होगा ऑप्टिमाइजेशन में, मैक्सिमा मिनिमा में, कि जो फर्स्ट ऑर्डर कंडीशन होती है, दैट इज कि दैट dy बाई डी एक्स dy by dx यानी कि f dash x is equal to 0 and this is what we call necessary condition. Why necessary condition? Because this is bound to happen. If we have a maxima or a minima at a point, then at that point there has to be a change of slope. Okay, तभी you get a upward peak like this or a downward peak like this. तभी आपको मिल सकता है. Okay, because suddenly slope will go from positive to negative or from negative to positive. Okay, and then at that point you get this flat tangent. Okay, so dy by dx is bound to happen at a point where we potentially have a maxima or minima. Okay, so that's why this is what we call a necessary condition. Okay, so that's why it is called a necessary condition. There is a doubt that can we graph second order condition as well? We can, but for that we need the exact function. Okay, so from the given information we basically will need third order derivative. Okay, so for third order derivative we need some more information, and that's basically the function itself. Like maybe we need to know that whether the function is x cube or maybe x की power 4 plus 6x type thing. So we need to know the exact function, only then we'll be able to plot second order condition. Okay, and after that if we have a function like this, so which is a concave function, we know that second order derivative at our x star will be negative. And if we have a function like this, then second order derivative at x star will be positive, right? So concave, convex, I am assuming most of you know this, that the graph remains above the line. If you take 2 points on the graph, okay, and then consider the graph between those 2 points, then graph will be above the line. Okay, and similarly if you take 2 points here, join them, consider the graph between those 2 points, then that graph will always be below the line. Okay, so that's a convex function. Okay, so now we call first order condition a necessary condition, because irrespective of whether a point is maxima or minima, this is bound to happen. This is necessary. Okay, without this you cannot have a maxima or minima, okay, for a continuous graph. And now the other condition, which is SOC, second order condition. Second order condition. Second order condition basically means कि अगर मैक्सिमा है तो डेरिवेटिव, सेकंड ऑर्डर डेरिवेटिव नेगेटिव होना चाहिए. अगर आप वो मिनिमा है तो सेकंड ऑर्डर कंडीशन शुड गिव यू दैट एट दैट पॉइंट सेकंड डेरिवेटिव इज पॉजिटिव. तो इसे हम कहते हैं, दीज आर कॉल्ड सफिशिएंट कंडीशंस. ओके, दीज आर नॉट नेसेसरी बट दीज आर सफिशिएंट. Okay, necessary is necessary because without that we'll not get any peak, upward peak or downward peak, but that is not enough. Okay, अगर आपके पास कोई पॉइंट है और वहाँ पर मैक्सिमा या मिनिमा है बट सिर्फ डेरिवेटिव ज़ीरो आ जाए, दैट्स नॉट एनफ टू से कि वो मैक्सिमा है, या फिर दैट्स नॉट एनफ टू से कि वो मिनिमा है, क्योंकि डेरिवेटिव जो ज़ीरो है वो मैक्सिमा पर भी आ सकता है, मिनिमा पर भी आ सकता है. सो दैट इज़ नॉट एनफ. सो फॉर दैट वी हैव दिस फर्दर कंडीशन विच इज़ द सेकेंड ऑर्डर कंडीशन, एंड वी कॉल इट sufficient condition, and that together using them we are able to prove whether a point is a maxima or a minima. Okay, so that's the reason first order condition is called necessary condition and the second order condition is called sufficient condition. Okay, and now the point is ki why are we talking so much about this? Earlier in IGIDR exam, IGIDR used to take its own exam, and after that they also used to take the interview. Okay, so in their interview they used to ask this question. Okay, to a few candidates that why necessary condition is called necessary and why sufficient condition is called sufficient, and most of the students couldn't answer this because they just learned in their from their NCERTs that it is necessary, this is sufficient. Nobody ever questioned themselves that why is it necessary and why is it sufficient. So from that I thought that I should provide you this knowledge that you should know that why it is called necessary and why it is called sufficient. Anyways, is the whole point clear? Yeah, okay. Moving on. But this criteria requires the function to be differentiable. Okay. Why so? Because suppose we have a function like this. And for a function like this, it is clearly visible that at this point we have a minima, right? ये minima है. Because at this point we have the lowest value of the function. If this is fx, then fx has a minimum at x star. And the minimum value is f at x star, and the minima, this will be the minima. Minima is x star, and this is what we call minimum value. This is the minimum value of the function, and the domain point at which that is we are getting the minimum value, that point is called minima. Anyways, now the thing is, we know that at corner points function is not differentiable. Why so? Because in general, for finding out the derivative, or basically the derivative is associated with the slope, and for finding out the slope what you do is you take out the slope of these tangent lines. Curve जब होते हैं आपके पास तो उसकी slope निकालने के लिए क्या करना होता है, आप suppose इस point पर निकालना है तो you create a tangent, you see this angle, you find out the value of tan theta and you do all those stuff. तो basically tangent से पता चलता है that what is the slope of a point on that curve. Okay, so like for this point slope is 0. For this point slope is something positive, and so on and so forth. So लेकिन one thing to notice is कि all these tangents are unique. But issue with a point like this, a corner point like this, is that here we can have a positively sloped tangent, we can have a negatively sloped tangent, we can have a horizontal tangent. Okay, so which means that at a corner point tangent is not unique. Okay, so for finding out the slope we need a unique tangent. So that's why this first derivative and second derivative criteria fails for a function which is not differentiable. Okay, so at some places we need to maybe draw the graph or move towards some advanced techniques rather than just derivatives and second derivatives. Okay, so ये minima है लेकिन ये differentiable ही नहीं है. Okay, so we can say that this is, यहाँ पर minima है, yes, but is the function differentiable? No. Okay, this function is not differentiable. Okay, so this necessary condition, sufficient condition, this criteria fails for a function which is not differentiable. Okay, तो इन चीज़ों के ऊपर क्या होगा? You get an MCQ and it will give you 4 options. Okay, so putting in things like differentiable होगा तो आप ये criteria लगा सकते हो या नहीं लगा सकते, kind of those things. Okay, and we can also have a situation like this. In this case, can you tell me where the maxima is? For this function, can you tell me where is the maxima? Just say yes or no. No, right? Because you don't know where exactly the maximum value is. You don't know where the exact maximum value is. So this would have been the maxima, but the function is discontinuous here. Okay, and we know that if a function is not continuous, it cannot be differentiable at that point. जब वहाँ पर वैल्यू एग्जिस्ट ही नहीं करती तब आप वहाँ पर डेरिवेटिव निकालोगे कैसे? there is the value of that function at that point doesn't even exist, so you cannot find the derivative. Okay, and then you might think that maxima is just to the left of x star, but the issue is you don't know what that point is. For example, suppose this point is 2. Now if I ask you what is the maxima, well, you in general you can say that it is the point which is just to the left of 2. But what is to the left of 2? You might say 1.9. I would say why not 1.99? You will say yeah, but then I'll say why not 1.99? Why not 1.99999 and so on? So no matter what number you give me which is close to 2 from the left hand side, I can always give you a greater number which is closer. Okay, and you might say that the maxima is maybe 2.1, then I would say why not 2.01? You might say yeah, then I would say why not 2.000001? Okay, so no matter how close a number you give me to the right of 2, at which you might think there is the maxima, but I can always give you a closer number. Okay, so we will never be able to reach that particular number which is just to the left of 2 or just to the right of 2. So that's why in these cases we would say that maxima or minima doesn't exist. क्या ये बात clear है? Yes, let's go for it. Okay, so moving on. Let C be a number. Let C be a number in the domain D of the function f. Okay, let C be a domain, let C be a number in the domain of the function f. So we are considering a function f, and the domain, in the domain we have some number C. Then fc is the, we can call it global maximum. fc is the global maximum value of f on D if fc is more than equal to fx. If fc is more than equal to fx for all x in the domain. Okay, let's understand this definition. पहले आप नोट कर लो and then let's understand this definition. यहाँ पर here we have C, which is the global maxima. Global maxima कह सकते हो, you can call it global maximizer. Okay, and the corresponding value of the function at that point, which is C, it is fc, that's global maximum value. Okay, so when will we call C a global maxima? Well, so clearly the peak, the global peak is here. Here we have two peaks, एक यहाँ पर है, एक यहाँ पर है, but globally for the whole domain the maximum is here. So here this C is called the global maximizer. Okay, and fc is the global maximum value. Okay, so simply C is the global maximizer if fc is more than or equal to any other value of the function. So we have some fx here, we have some fx here, we have some fx here, but if you compare all of them with fc, then fc has the highest, has the maximum value. Okay, so fc is more than equal to fx for all x in the domain. For any x in the domain, this fc has the highest, has the maximum value. Okay, and in this case, here the global maxima that we have is unique, because here C is a unique value. It is the only value where we have this maximum value. Okay, but we can often have a situation where we have multiple global maxima. It's global maxima, but still we can have multiple values in the domain where that maximum value exists. Okay, so let's see that as well. Okay, let's discuss that as well. So we can have a situation like this. Okay, so now what happens in this case is the value of this function at A, the value of this function at B, and the value of this function at any point in between A and B, like C. Okay, for all these points in the domain between A and B, we have the same value, and that is the highest as well, which is FA, FB, FC, all are same in this case. So in this case, FA is equal to FB is equal to FC. तो यहाँ पर आपके पास you have multiple global maxima. In this case, global maxima is not unique. Okay. Here, global maxima is not unique, and in fact, in this case, the global maximizer belongs to this set. Any point in this set AB, any number between A and B, including both A and B, all of them are global maximizers. Is that fine? Yeah. Okay. Then we can also have a situation like this. So what's with this situation? Well, oh, wait. Don't draw this now. We'll get back to it again. तो पहले मिनिमाइजर की डेफिनेशन ले लेते हैं. Okay, so let's talk about global minimum. So global minimum, now that we know about global maximum, so global minimum is going to be very simple. Global minimum value of F on domain D, हम continue कर रहे हैं इसे. So FC is the global, यहाँ maximum था, then we have minimum. So FC is the global minimum value of F on D if FC is less than equal to Fx for all x in the domain. Okay, domain में आप कोई भी x लो, उन पर जो भी वैल्यू आएगी फंक्शन की, सब पर FC से ज़्यादा होगी, तभी obviously C is the minima and FC is the global minimum value. Okay. And the situation might look like this. Here we have x, here we have that particular C where we have the minima, that's FC. Okay. In this case, global minima is equal to 0, and in this case it is unique as well, right? In this case it is unique as well. And then we can have the other case like this. Okay. This is better. Okay. So in this case, we have multiple global minimum and multiple global minima. ठीक है. So in this case, global minima belongs to the set AB, including A and B. Is it fine? तो ये बात हो गई global minima की, where you talk about the whole domain. Then we have something called local maxima, local minima. Okay, let's talk about that quickly. So FC is the local maximum in bracket minimum value of F at C if FC is more than equal to in bracket less than equal to FC for all x near C. Okay, and what do we mean by near C? Well, near C means in near C, that is in some open interval containing C. Okay, let's understand this definition. So FC is the local maximum if FC is more than equal to, ये fx होगा, more than equal to fx for all x. Okay, and similarly this minimum for FC is the local minimum. For that we have this, when FC is less than equal to fx for all x. Okay, so that's a way of writing two definitions into one. Okay, so you read bracket for bracket. This part, for that we have this condition, and for the minimum we have this condition. Okay, so that's how we combine two definitions into one, which have some synergy. Okay, and then the other part is in some open interval containing C. Basically near C का क्या मतलब है वो हमें बात करनी है. Let's, once you write this definition, then I'll show you graphically what do we mean by near C. Okay. So in this case, clearly this is the global maxima, right? But what is local maxima? So anywhere where we have a peak like this, here first derivative is 0, here also first derivative is 0, here also first derivative is 0. Let's call this C1, C2, C3. So all these are local maxima. What do we mean by local maxima? Well, that means if you consider a domain which is near C1, if you take an open interval such that this maxima, this point C1, it is in between that open interval, and within that interval जब आप उस function की value consider करते हो, in that, for that particular part of the domain, when you look at the function, C1 gives the highest value in that local area, not the global area, just the local area. So in this local domain that is near C1, C1 is giving the highest value. In this local domain near C2, in this local domain near C2, C2 is giving the highest value. Okay, and then if you create this local domain near C3, then within that domain C3 is giving the highest value. So that's why. So when we are talking about this local domain, a domain, part of the domain which is near that maximizer, okay? So then such a point is called local minima, and the corresponding value is called local minimum value. So FC1 is a local minimum value. F at C2 is the local minimum value. FC3 is the local minimum value. Okay, so in this case, C1, C2, C3, all these are local minima, and C3 is the global minima as well. Okay, so a local minima can be a global minima as well, and a global minima is always a local minima अगर function continuous और differentiable है तो. If a function is continuous, it is differentiable, and a point is global minima. Sorry, ये maxima लिखना है मुझे यहाँ पर. I have by mistake I have written minima. It should be maxima. But the point I was trying to make is that a global maxima, if the function is continuous, differentiable, then a global maxima is always a local maxima too. Because if a point is satisfying the definition of global maxima, which is that means it has the highest, the function is taking the highest value at that point in the whole domain, then obviously it will take the maximum value in the local domain as well. If it is taking the highest value in the whole domain, then obviously it will also take the highest value in the local domain as well. So that's why a global maxima is always a local maxima as well. Is this point clear? A global maxima is always a local maxima as well. But a local maxima may not be a global maxima. For example, C1 and C2. But local maxima may not be a global maxima. And from that हम इसके set subset भी देख सकते हैं, like it will be like this कि global maxima का जो set होगा, set of, let G be the set of all global maxima, and L be the set of all local maxima, and obviously we are assuming that function is continuous, it is differentiable. Okay, उस केस में हम देख रहे हैं ये सब, ठीक है. So function continuous है, differentiable है, G is the set of all global maxima, L is the set of all local maxima. Then in that case G will be a subset of L, right? G will always be a smaller set, and it will be, since G is always a local maxima as well, and so the situation is like this. G is going to be a subset of L, okay? And it might be equal if we have a situation like this where we have just one local and one global maxima, okay? In that case G will be equal to L, okay? Otherwise G will be a strict subset of L, okay? So overall we can say that it is a improper subset of L, okay? Is that fine? Okay, moving on. Next thing is extreme value theorem. So it is a very important concept, extreme value theorem. Let's talk about this. So let's say if a function is continuous, on a closed interval AB, okay, then F attains global maximum value FC, and global minimum value FD at some point C and D in the closed interval AB. Okay, so it seems like a trivial thing, but very important to know that the first point is that it's not necessary that you will always get to find global maximum or global minimum. For example, what if we have a situation like this? Okay, the function keeps on growing. It increases exponentially, or maybe just it keeps on increasing, not just exponentially. Maybe a straight line like this. You can have a linear upward sloping line. It keeps on increasing. Then can you tell me that where is the maximum? You cannot tell that because ये infinitely grow कर रहा है. Okay. Similarly, if a function is maybe like this, it keeps on going down, then you'll not be able to find global minimum. Okay. So here global. In fact, let me just use a single example. We have let's consider this identity function. So here neither global maximum nor global minimum exist, right? You'll not be able to find that because it keeps on growing on both the ends. Okay, increase bhi ho raha hai infinitely and it is also decreasing infinitely. So you'll never be able to find the global maximum or global minimum. But what extreme value theorem does is if a function is continuous on a closed interval, if I take a closed interval and consider that function only in that interval, okay, so now notice we have the local minimum at A and global minimum at A and global maximum at B. So that's what this interval is doing. Okay. The other thing is, why do we need the function to be continuous or closed? Okay, we can talk about that as well. So point number one is कि ज़रूरी नहीं है कि global maximum या global minimum in general exist करे. Okay, so उसके लिए हमने ये एग्जाम्पल देखा y इक्वल टू एक्स वाला हमें नहीं मिलेगा यहाँ पर अगर कोई रेस्ट्रिक्शन नहीं है तो दैट्स पॉइंट नंबर वन. देन मूविंग ऑन, कॉन्टिन्यूटी की रिक्वायरमेंट क्यों है इस क्लोज्ड इंटरवल में? ओके, सपोज वी हैव a here, we have b here, and we have a function like this. Okay, we have a function like this. Okay, before this, let me tell you why are we considering closed interval. पहले उसकी बात कर लेते हैं. Then why are we considering closed interval and not open interval? Okay. So we have this function. It keeps on growing, and we are considering the open interval. Now tell me what is the global maxima in this case? What is the global maxima in this case? Can you tell me the global maxima in this case? You need to respond. Only then I'll be able to understand what your mindset is for now, and I'll be able to clear your doubts. What is the global maxima in this case? Okay. Yeah, there is, the answer is there is no global maxima in this case. If we consider this interval, okay, the issue is it seems like that in this interval the global maxima is supposed to be B, but the point is B is not part of the interval. When you have this open interval AB, clearly A and B are not part of this interval, right? So if it is not part of this interval, then how can we say that in this interval B has the maxima? So we cannot include B. And if we cannot include B, then what's the maxima? Well, in that case, it is something to the left of B. But again, जो हमने पहले भी discuss किया था, suppose B is 2, then the number to the left of 2 can be 1.9. Why not 1.99? Why not 1.999 and so on? Okay, so that's why when we talk about the interval in extreme value theorem is saying that a global maximum and a global minimum will definitely exist in this interval. And उन्होंने इसीलिए उन्होंने closed interval रखा है, क्योंकि open interval में we get this exception. In the open interval we have this exception where we might get a case where the function is continuous in this open interval, but still we don't have a maxima and we don't have a minima. So इसीलिए the point is कि हमें closed interval चाहिए, इसलिए ये इस definition इस theorem का part है. Then the second thing is continuity क्यों चाहिए हमें? Continuity से क्या मिल जाएगा? तो continuity से क्या मिल जाएगा वो देखने के लिए what we'll do is we need to find a counter example कि जहाँ पर discontinuous function है और हम इस theorem में loop hole ढूंढ लें. Okay, so this time let's include both a and b. Okay, and we have a function like this. Okay, ऐसे ले लो. ये देखो, तो a और b दोनों इंक्लूडेड है, मैं कह रहा हूँ इंक्लूडेड है. ओके, इंक्लूडेड है. वी हैव दिस क्लोज्ड इंटरवल ए बी, बट द फंक्शन इज डिसकॉन्टिन्यूस. अब प्रॉब्लम क्या है, जहाँ पर लग रहा था मैक्सिमम होगा वो पॉइंट वहाँ पर है ही नहीं, और तो जो मैक्सिमम अब दिख रहा है वो दिख रहा है यहाँ पर, ये रहा, ये इधर. ओके, बट अगेन हमें पता नहीं चलेगा वो कौन सी वैल्यू है. अगेन मान लो ये अगर 2 है तो दैट नंबर इज सपोज टू बी 1.9. अब फिर 1.99 1.999 कौन सा है वो एग्जैक्ट नंबर जहाँ पर मैक्सिमम वैल्यू मिलेगी. ओके, तो विल नॉट बी एबल टू फाइंड दैट. तो ये प्रॉब्लम है डिसकॉन्टिन्यूटी की, कि अगर हम डिसकॉन्टिन्यूटी लेकर आ जाएं देन एक्सट्रीम वैल्यू थ्योरम फेल हो जाएगी. तो इसीलिए कॉन्टिन्यूटी or closed interval, they both are the prerequisite for extreme value theorem. क्या ये बात क्लियर है? This is very important. Is it clear? सबको clear है? सबको लूप होल दिख गए हैं? Okay, चलो moving on. There is a question that what if discontinuity happened at a point below the maximum point, that is the discontinuous point had no chance of being the maxima. हाँ, तो उससे हमें कोई प्रॉब्लम नहीं है और हम वो देख भी नहीं रहे. वट वी आर डूइंग इज वी आर ट्राइंग टू फाइंड अ लूप होल. पूरी बात को समझो. थ्योरम क्या होती है? थ्योरम इज समथिंग विच इज ऑलवेज ट्रू. ओके, थ्योरम इज समथिंग विच इज ऑलवेज ट्रू. नाउ द इशू इज इफ आई अलाउ द फंक्शन टू बी एनीथिंग, इट इज नॉट रिक्वायर्ड टू बी कॉन्टिन्यूस. देन अब उससे प्रॉब्लम क्या होगी? ड्यू टू दैट वी विल बी एबल टू फाइंड अ केस जहाँ पर वो थ्योरम होल्ड नहीं करेगी और थ्योरम फेल हो जाएगी. और अगर वो थ्योरम फेल हो गई तो वो थ्योरम ही नहीं है. ओके, अगर हमने एक भी केस ऐसा निकाल लिया जहाँ पर थ्योरम फेल हो रही है तो देन इट इज़ नो लॉन्गर अ थ्योरम. ओके, सो इट्स नॉट अबाउट कि इट्स नॉट अबाउट कि कहाँ पर चल जाएगा, इट्स अबाउट कि कहाँ नहीं चलेगा. हमें वो ढूंढना था. ओके, तो डिसकॉन्टिन्यूटी से ये प्रॉब्लम है. तो हम इसीलिए कह रहे हैं कि ये थ्योरम इसीलिए थ्योरम है क्योंकि इसमें कॉन्टिन्यूटी है. ओके, अगर हम इस कॉन्टिन्यूटी को हटा दें तो एक लूप होल निकल आएगा जिसकी वजह से ये थ्योरम हमेशा ट्रू नहीं रहेगी. ओके, तो एक भी लूप होल आ गया, एक भी अगर एक जगह भी होल्ड नहीं कर रहा तो देन इट विल नो लॉन्गर बी अ थ्योरम. क्या ये बात क्लियर है? या ओके. हाँ, सो हमने लूप होल देख लिया. नाउ द थिंग इज अब ये थ्योरम with its condition, this will always be true, something like this. कि suppose we have any kind of thing, it is continuous and we are including the intervals. Okay, so you will be easily able to find, you will be able to recognize कि कहाँ maximum है कहाँ minimum है. Okay, anything of that sort can be done. Okay, and what about a thing like this? Can you tell me what is the maxima of this function? What is the maxima of this function? B, no. B is not maxima. The issue is that it is not even a function. Function में क्या होता है? In case of function, for each value of x there should be a unique value of y, but for B we have two values. Okay, so it is not even a function. It is not a function. तो अगर फंक्शन ही नहीं है then the whole point that function should be continuous in the closed interval ab, it is not even a function. So it was just I was just trying to show you a case, an exceptional case. Okay, so in this case there is no point of finding a maxima or minima because it is not a function at all. Okay, moving on. What this theorem tries to say is that if you want to maximize a function and that x belongs to closed interval AB, or if you want to minimize a function fx where x belongs to a closed interval AB and f is continuous as well, then a solution to this problem always exists. इसके लिए भी solution हमेशा exist करेगा. And for this minimization problem also solution will definitely exist. Why? Because for a continuous function within a closed interval, defined on a closed interval, the maxima and minima always exist, and we know that by extreme value theorem. Okay. Okay. Let's just look at a few problems. What about maximum of mode of x minus 2 when x lies between closed interval 0 and 4? Just try this out and tell me the answer. And for this obviously you will not be able to find the derivative, right? Derivative नहीं निकालना है यहाँ पर क्योंकि this function is not differentiable directly. So just plot this function. We know how to plot this. We have studied this under curve sketching, and then tell me the maxima of this function. इतना मुश्किल है क्या? One answer I have got is 4. Is that the only global maxima? Zero and 4. Perfect. Let's do it. So let's start with finding the zero of this function. By zero I mean where will this function take value 0? That's obviously at 2. Okay. And then we know that we'll get a V-shaped curve at 2 of slope 1 on the right hand side and minus 1 on the left hand side. Okay. 3, 4, 1, 0. Clearly the value at 0 is this, which is 2, and at 4 also it is 2 only. Okay, so clearly x star is, what we are looking for is this 0 and 4. That's the maxima. Is that fine? Let's do another problem. Maxima is x square minus 4x plus 2 in the closed interval 0 to 1. Okay. Okay, so I'll solve this for you and I'll tell you the algorithm now. Like how to go about these problems. In general, अगर सिर्फ इतना क्वेश्चन होता, this, तब आप सिंपली डिफ्रेंशिएट करते हैं एंड दैट्स इट. बट व्हाट अबाउट दिस, हाउ टू डील विद दिस इंटरवल, तो उसके बारे में बात करते हैं. Okay, let's quickly talk about this. The thing is, what you do is, suppose the function looks like this and आपको मैक्सिमा निकालना है and the interval is this. So what you do is, आप डेरिवेटिव करोगे इस फंक्शन का, you will get critical point here, you will get a critical point here. तो whatever critical point is in this interval, तो हमें वही कंसिडर करना है बिकॉज हमें जो मैक्सिमा देना है दैट शुड बी इन दिस इंटरवल ओनली. ओके, सो what you do is you differentiate this function, you find out the critical points, whatever critical points are in this interval we'll consider that, and whatever critical points are outside this interval we'll simply ignore them. Okay, and then finally we'll consider the critical point within this interval, plus we'll also consider the endpoints. Okay, only one of these these points will be worth considering because critic या तो आपका maxima या minima critical point पर होता है, and when the interval is when the domain is restricted like this, in that case corner points पर आपको maxima या minima मिल सकता है. तो इसलिए बाद आपको end points देखने और critical points देखने. That's it. So that's how you go about this. So let's start with derivative. 2x minus 4, you equate it to 0, x will be equal to 2, and this time this is outside this interval, so we'll be ignoring x equal to 2. We don't need to see what is the value of the function at 2. Then we need to evaluate the function at 0, we need to evaluate the function at 1, which is the end points. आप end points consider करोगे. Critical point is outside this interval, तो उसे हम ignore करेंगे. f0 is 0 minus 0 plus 2, which is 2, and f1 is 1 का square minus 4 into 1 plus 2, which is equal to 1 minus 4 minus 3 plus 2, that's minus 1. Okay, so x equal to 0 is maxima and 2 is the maximum value. Is that fine? There is a question of there is a doubt regarding the previous question that the function is not differentiable. So differentiability was never a condition of extreme value theorem. We just need the function to be continuous for finding out the global maximum and minimum if it is continuous on a closed interval, which it was. वो जो ये mode वाला function था, it was a continuous function in this closed interval 0 to 4. In this closed interval 0 to 4. Okay, so we could find that. So differentiability was never the issue. But when the function is differentiable and you don't know how to plot it directly, the first step is you differentiate it and find out the critical points. क्योंकि जब आपको मैक्सिमम मिनिमम निकालना होता है आप क्या करते हो, आप डिफरेंशिएट करके फर्स्ट ऑर्डर डेरिवेटिव निकालते हो, उसे इक्वेट करते हो 0 के, वो आपको बताएगा कि यू गेट द क्रिटिकल पॉइंट. फिर आप सेकंड डेरिवेटिव की तरफ जाते हो कि फिर वो मैक्सिमा है या मिनिमा, आप वो सब चीज़ें करते हो. लेकिन हमें देखना है इस इंटरवल में, तो अगर आपका क्रिटिकल पॉइंट इज आउटसाइड दिस इंटरवल देन देर इज नो पॉइंट ऑफ चेकिंग द वैल्यू ऑफ दैट फंक्शन ऑफ द फंक्शन एट दैट पॉइंट, क्योंकि हमें वो पॉइंट चाहिए ही नहीं, हमें इसी इंटरवल का पॉइंट चाहिए था, तो इसलिए हमने इसे इग्नोर कर दिया एंड देन यू चेक आउट द एंड पॉइंट्स. ओके, बट maybe I can reframe this question: x square minus 4x plus 2, x square minus 4x plus 2. Maybe what we can do is, this time the question is 0 to 4. okay, तो एक तो critical point हमें मिला था 2. so now what you do is, see this, आप 2 चेक करोगे और एंड पॉइंट्स चेक करोगे, आप फंक्शन की वैल्यू निकालोगे. ओके, तो 2 पर एफ एक्स क्या आएगा, 2 पर आ जाएगा 2 का स्क्वायर माइनस 4 इंटू 2 प्लस 2, तो यू विल गेट 4 माइनस 8 प्लस 2, तो यू विल गेट 6 माइनस 8 विच इज माइनस 2. 0 पर जब आप चेक करोगे यू विल गेट 2. 4 यू विल गेट 16 माइनस 16 प्लस 2 विच इज इक्वल टू 2. तो इन दिस केस 0 is a global max, 4 is a global max, and 2 is a global minima. Okay, and minus 2 is the global minimum value. 2 is the global maximum value. Is the whole point clear now? And here is your homework problem. I've already taught you curve sketching, so based on that you should be able to plot this function and then check the function in this interval, closed interval 0 to 1. Okay, you need to find global maxima and minima. I'm sure you'll be able to do it. Okay. So that's it for today. So today we'll be discussing a very important topic called partial derivatives. I'm assuming आप लोगों को differentiation आता है, derivatives आता है. So we can move to partial derivatives. So under derivatives you must be aware about things like derivative of x की power n is equal to n x to the power n minus 1. Things like d by dx of log x is 1 by x, d by dx of 1 by x is minus 1 upon x square, or d by dx of root x is equal to 1 upon 2 root x. Derivative of e to the power x is e की power x only. Derivative of a to the power x is a की power x log a. Right? ये सबको पता है. Just tell me this once. Are you aware about all these things? पता है? Okay. So if you are aware about these things, then we can discuss partial derivatives. Okay. चलो फिर शुरू करते हैं. So under partial derivatives, let's say we have a function fx, let's call it z. अभी अगर कोई सिंगल वेरिएबल पर डिपेंड करता, then what we do is we can simply find out dz by dx. So that's normal derivative differentiation. But let's say there is a function which depends upon at least two variables, okay? In this case only two variables x and y. Then यहाँ पर क्योंकि function depend करता है on more than one variable, so we cannot simply find out कि what will be the impact on f. ये आपको क्या बता रहा है? This tells you that by how much will z change if x changes, right? But here I cannot do that. I cannot just directly find out impact on z due to x because y is also involved, okay? So doing that directly is not possible anymore. So what we find here is partial derivatives, and the symbol for that is del z by del x and del z by del y, okay? And what this means is that this time again I am finding the impact of change in x on change in y, but keeping y as a constant, okay? Similarly here it means that we are finding out change in z due to change in y but keeping x constant. यहाँ पर कुछ भी हमें we don't need to keep anything constant in this case because there is only one variable. But here since we have two variables involved, I cannot find the impact on z directly due to x because y is also involved, and same thing goes for y, okay? So this is telling you change in z due to change in x keeping y as a constant. Keeping y constant. Okay, this time it is change in z due to change in y keeping x constant. Is the meaning clear? Okay, so now let's simply move on. Let's do some problems. So we have z is equal to x square plus xy plus y square. And we are doing this mainly for microeconomics क्योंकि वहाँ पर हमें we need to find out marginal utilities where we do all these things where partial derivatives are involved. So you might have studied this in your college, but we just need to cover it quickly and build upon this. So here we can find out del z by del x and del z by del y. So when we are talking about del z by del x, in that case y will be treated as a constant. So this is a constant, this is a constant. So x square derivative will be 2x and x into some constant that's going to be constant as it is, and then for x it will be 1, and then derivative of a constant is 0. So this will be equal to 2x plus y. And similarly, when we need to differentiate this partially with respect to y, in that case x is a constant, so 0 for that, plus constant x is constant, so x as it is, and for y will get 1, and for y square will get 2y. So this will be equal to x plus 2y. Is it fine? Yeah, okay. So moving on, ये वाला क्वेश्चन आप करोगे. We have z is equal to ln is natural log of x square minus y square. You need to find out del z by del x and del z by del y. Find out del z by del x and del z by del y. जैसे ही हो जाए गिव मी अ थम्स अप. Yeah, done. Okay. Let's do it. So chain rule यहाँ पर भी apply होता है. So at first we need to differentiate log. For log x we have 1 by x. So similarly for log this whole thing will have 1 upon this whole thing. And then we'll partially differentiate this part. So x square minus y square. X square का हो जाएगा 2x and for y square will get 0. So this will be equal to 2x upon x square minus y square. And similarly here also applying chain rule, at first we'll need to differentiate with respect to we need to differentiate for log, so we'll get 1 upon x square minus y square. Now for x square, now x is a constant because we are differentiating with respect to y. So x square will be a constant, वो हो जाएगा 0. And for y square we'll have 2y, so ultimately we get minus 2y upon x square minus y square. Okay, let's do one more. How about z is equal to e to the power x square plus y square? Again, let's find out del z by del x. E का होता है e back, so we'll get e to the power x square plus y square. Again using chain rule, we get this whole thing back, and then x square plus y square. So x square 2x, y square 0 because y is constant for now. Similarly, del z by del y will be equal to chain rule, using chain rule, e to the power x square plus y square back. Then this time we are differentiating with respect to y partially, so x will be treated as a constant. So for x square we'll get 0 and for y square we'll get 2y. So we will get 2y into e ki power x square plus y square. And this was 2x into e to the power x square plus y square. Is it fine? Okay, how about z is equal to x to the power y plus y to the power x? Do this one. Find out del z by del x and del z by del y. जैसे ही हो जाए गिव मी a yes or a thumbs up. Yeah, okay, let's do it. So currently we are differentiating partially with respect to x, so y will be treated as a constant. So when we have x to the power y, it's like x to the power 6 where y is a constant. So I'm just taking an example. So we'll be doing y x to the 6 x to the power 6 minus 1. So similarly here it will be y x to the power y minus 1. And now it is like this, y ki power x, here y is a constant, okay. So it's like a to the power x, जिसका derivative होता है a की power x log a, okay. So here it will be y to the power x log y. Is it fine? And then when we are doing this with respect to y, then x is a constant, so for this we will get x y to the power x minus 1, and for this we will get x to the power y log x. Is it fine? So before I move to the next topic, I need to know सबको question number 1, 2, 3, 4 completely clear है? Do you want me to repeat anything? Do you have any confusion? You can tell me right now. Okay. Moving on. Okay, we should know the interpretation of this. So let's do just one more thing here. z equal to fxy is equal to x square e to the power y square. Okay, your job is to find the first order partial derivative with respect to x at the point 1, 0 and interpret it. So we need to find out del z by del x, which will be equal to what? So this whole thing is a constant, so we will get two x e to the power y square. Okay, and we need to calculate this at 1, 0. So we will get 2 into 1 e to the power 0 square, which will be equal to 2 into e to the power 0, that's 1. So 2 into 1, that's 2. So, and now we need to interpret this. So if x increases by 1 unit, if x increases by 1 unit, then change in z kitna hoga? It will be 2 units. Then change in z is 2 units, but main thing is keeping y as a constant. We didn't change y, हमने y को as it is रखा हुआ है, we just changed x. Okay, so at 1, 0, if we do that, then z will change by 2 units when we change x by 1 unit, keeping y as a constant. Is the interpretation clear? Okay, moving on. So this was all about first order derivative, right? Now we can talk about second order partial derivatives. So we have this function depending upon two variables x and y. From this we can find out del z by del x विच इज इक्वल टू एफ एक्स. इसे आप एफ एक्स भी लिख सकते हो. यू कैन राइट इट लाइक दिस, एफ एंड देन एक्स हेयर. और similarly del z by del y can be written like this, f subscript y. Okay, now if I differentiate this again with respect to x, so we already have del z by del x, and if I differentiate this again with respect to x, then this is del 2z by del x square, just like d2z by dx square. This is del 2z by del x square. And same thing goes here. If we have partial derivatives with respect to y, and if I again differentiate it partially with respect to y, then we'll get del 2z by del y square. Okay. The other thing that we can do is, if we have del z by del x, we can now differentiate it with respect to y. So this will be del 2z del y del x, or this can be written as f. पहले आप at first we partially differentiated with respect to x and then with respect to y. In this case we did it twice with respect to x. This is f y y. And if we have del z by del y and we differentiate it with respect to x, this will be del 2z by del x del y. This will be, at first we differentiated partially with respect to y, then we did it with respect to x, so f yx. So here this fxy and fyx, these are called mixed order partial derivatives, because we are differentiating with respect to x and y, so we are mixing these. These are called mixed order partial derivatives. Is it fine? Okay, and the other point is Young's theorem, and actually it should be pronounced Jung's theorem. Okay, Jung's theorem. Which says that if z is equal to fxy is continuous with continuous partial derivatives. With continuous partial derivatives, then order of the derivative is immaterial. It doesn't matter. That is, fxy will come out to be equal to fyx. आप पहले x के रिस्पेक्ट में डिफरेंशिएट करो, उसके बाद y के रिस्पेक्ट में पार्शली, और यू डू इट फर्स्ट with respect to y and then x. they both will be equal. X then y or y then x, it doesn't matter. That's Young's theorem. Okay. So let's do one thing. Let's just try to verify Young's theorem. So for that we can take a function, maybe x square e to the power minus y. So let's first do it with respect to x. So here y will be treated as a constant, so for x square we'll get 2x e to the power minus y as it is. And then let's do it with respect to y, which will give us fxy. So for 2x we'll get 2 this time, for x we'll have 1, 2 e to the power minus y. Okay? Oh sorry, y के respect में किया है हमने, sorry about that. So now we have to do this with respect to y. So 2x as it is, for e to the power minus y we'll get e to the power minus y, and for minus y we'll get minus 1. So this. Now let's do it the other way around. At first we'll differentiate it partially with respect to y and then with respect to x. So order change करके देखते हैं. So we'll do del z by del y. This will give us x square as it is, e to the power minus y का हो जाएगा e to the power minus y, for minus y we'll get minus 1. And then del z del y, now let's differentiate it partially with respect to x. This will give us fyx. This will be equal to, so now e to the power minus y will be treated as a constant. For x square we'll get 2x and that minus as it is. And we can clearly see that both are same. Okay, so hence our Young's theorem is verified. So it's only about this. Order doesn't matter. It doesn't mean that fxx will be equal to fyy. That we won't get. We might get that result by chance, but in general that's not true. So for now, Young's theorem is verified. Also, in general, fxx is not equal to fyy. Is it fine? Okay, now we're going to talk about implicit functions. So we have z is equal to fxy is equal to some constant. Okay, we have z fxy, we have the function fxy equal to some constant. Like 2x minus 5y is equal to 20. Okay, this kind of function is called implicit function. Basically, x and y are interlinked. Everything is on, all the variables are on one side and there is a constant on the other side. So this is an implicit function. And if I maybe do it 2x minus 20 upon 5 is equal to y. Now, this is an explicit function. This kind of function is called explicit function. So basically y as a function of x, that's explicit. But if we don't properly know that whether x is a function of y or a y is a function of x, okay, everything is, all the variables are on one side, then it's just mainly about format right now. So such a function is called implicit function. Okay, so the situation is that there is a function of x and y, and y is equal to y is some function of x. Okay, so notice at first z depends upon two variables x and y, and then further we get to know that y also depends upon x. Maybe something like z is equal to, एग्जाम्पल दे देता हूँ पहले मैं ताकि आप समझ जाओ यहाँ क्या चल रहा है. For example, that z is equal to 5x square e to the power y, and then y is equal to maybe x cube. Okay, so z is ultimately equal to 5x square e to the power x cube. The situation is like this. Okay, so such a function is, so here what we say is that z is a composite function of x. Ultimately it depends upon x. At first we get to see that it depends upon two variables, and then the other variable depends upon one of these variables, which is x. So ultimately, so z is equal to fx, y की जगह हम रख सकते हैं gx. Okay, so here we say that z is a composite function of x. It ultimately depends upon x. So now if I want to find out, so since ultimately depends upon one variable only, so we can do this dz by dx. Okay, so dz by dx will be equal to what? So this will be equal to del f, you partially differentiate the function with respect to x, okay, into change in x, plus partial derivative of f with respect to y into change in y due to change in x. Okay, let me explain you this part. At first you note it down, then I'll explain you that how did we get this. Okay, let's now understand this. So if I want to find out change in z, okay, so change in z can come from, so since z depends upon x and y, let me do that here. We have z which is a function of x and y, it depends upon two variables. So इसमें जो भी change होगा, that the source of change can be x or y because it depends upon two variables. So now what we need to know is, if I keep y constant, then due to 1 unit change in x, how much will the z change? So that this is change in z due to 1 unit change in x into what's the actual change in x. Okay, so ये आ गया total change due to x. plus change in z due to 1 unit change in y, that this is for 1 unit change in y, into what's the actual change in y. Okay, it's like pencil is of rupees 5, okay, and you are buying 10 pencils, then what will be the total amount you have to pay? That's 5 into 10. So that's how you do it. This is for 1 unit. This is change in z due to 1 unit change in x. Okay, and then into actual आपने पेंसिल खरीदी कितनी है. This is एक पेंसिल का प्राइस and this is number of pencils. Similarly, this is price of one eraser and this is number of erasers. And then what you are doing is you are finding out it with respect to x. So just you need to do this. Okay, because जो change drive कर रहा है, that driving force is x. Okay, so x में चेंज होने से z में कितना चेंज आएगा 1 यूनिट की वजह से, इनटू x में चेंज आया कितना है x की वजह से. सिमिलरली here it is change in z due to 1 unit change in y into by how much y will actually change due to x. Okay, so that's how we get this. Is the formula clear? Is it clear? Yes? Okay. And since in this case z is a constant, so change in z due to x will be 0. This will be equal to 0 because z is a constant. Because z is a constant c, z is equal to a constant, so change in z will be equal to 0. Okay, तो इसका फायदा क्या हुआ है? 0 will be equal to del z by del x into dx by dx plus del z by del y into dy by dx. Okay, so this will be equal to, you can write it fx, this is 1, this is fy, dy by dx. Ultimately dy by dx is equal to minus fx upon fy. This is what we call implicit function theorem. Okay, so this is a very useful formula. So if we have an implicit function and we need to find out dy by dx, then we can use this formula directly, and I'll show you how. Okay, see, let's take a question like x square plus xy plus y square is equal to 2, and we need to find dy by dx. Okay, so let's apply method 1, the normal one. What we'll do is, if I just try to differentiate this whole thing with respect to x, dy by dx of this whole thing, x square plus xy plus y square is equal to dy by dx of 2. So differentiating both sides with respect to x, what we'll get? X square का हो जाएगा 2x plus here we need to apply chain rule. X square का हो जाएगा 2x plus x as it is. For y we'll get dy by dx, plus y as it is, for x we'll get 1 dx by dx. For y square we'll get 0 because differentiation of, for y square we'll get 2y, and then for y we'll get dy by dx. Okay, we are not doing partial derivative, we are doing the complete differentiation with respect to x. So I'm gonna repeat this part. For x square, we know derivative will be 2x. For y square, it's like chain rule. So for y square, we'll get at first 2y, and then we need to differentiate y with respect to x. Okay, and for here we need to use chain rule because both of these are variables, and we are not differentiating partially. Nothing here is a constant. Okay, so x as it is, using product rule, x as it is, for y we'll get dy by dx. That's here. Then y as it is, for x we'll have dx by dx, which is 1. Okay, so like this. And for 2, derivative will be 0. Okay, and now since we need dy by dx, let's take dy by dx common. I'll get x plus 2y here, and we can take these on the other side. So minus 2x plus y, and then ultimately dy by dx will be equal to minus 2x plus y upon x plus 2y. Okay, so that's the longer method. Again, if you need any clarification, the point is this time there is nothing constant. Nothing is being treated as a constant. This is not partial derivative. This is complete derivative. Now let's apply method 2. Method 2, which says that dy by dx using implicit function theorem, this will be equal to fx upon fy. Okay, let's do it. fx क्या होगा? Partial derivative with respect to x. That will be 2x plus y plus 0. 2x plus y plus 0, let's ignore 0, divided by partial derivative with respect to y. x square का हो जाएगा 0, x 2y, तो x plus 2y. And you can clearly see that what we got in method 1, which with a longer calculations, and what we got using implicit function theorem, both are same. Okay, fine. All right. What you can do is just try out this one after the class. X to the power y plus y to the power x is equal to 2. Okay, and you need to find out dy by dx. Find dy by dx using both the methods. Okay, try it by both the methods. You need to be clear with both. And then we'll move to the next topic, which is homogeneous functions. Okay, let's talk about homogeneous functions. A function z is equal to fxy is homogeneous of degree n if f lambda x lambda y, basically if I replace x with lambda x and if I replace y with lambda y, then we get this lambda comes out with power n fxy, and here this lambda has to be something positive. Okay, so then such a function is called homogeneous of degree n. This symbol is called lambda, and n here is called degree of homogeneity. This is the degree of this homogeneous function. Okay, so how about x square plus xy plus y square? What you need to do is you need to check f lambda x lambda y. Basically, wherever we have x, replace that with lambda x, and wherever we have y, replace that with lambda y. Okay, so we will get lambda square x square, lambda square xy, lambda square y square. I can take lambda square common. We'll get x square plus xy plus y square, which is nothing but the original function. This part. This is the original function. So we have lambda square fxy. Okay, so since lambda has come out with this power 2, so this is a homogeneous function and the degree of homogeneity is 2. This implies that z is a homogeneous function of degree 2. Okay. Okay. How about z equal to x minus y upon x cube plus y cube? Solve this and tell me if it is homogeneous. And if it is homogeneous, then what is the degree? If it is not homogeneous, then there is no point about talking. There is no point of talking about the degree. Okay. So you need to check whether it is homogeneous or not. If it is homogeneous, then tell me the degree. If it is not homogeneous, then that's it. Not homogeneous. The function is x minus y upon x cube plus y cube. क्या आ रहा है? Yes, correct है. Yeah, it is homogeneous and the degree is -2. It is homogeneous of degree -2. See this. So if I replace x with lambda x and y with lambda y, we will get lambda common, lambda cube common here. So we will get x minus y upon x cube plus y cube, lambda upon lambda cube, that's going to be lambda to the power -2. Okay, so this implies z is homogeneous of degree -2. So degree can be negative as well. Okay. So from this, we get an important point that notice in this case both numerator as well as denominator are homogeneous. दोनों ही homogeneous हैं, right? So if numerator and denominator both are separately homogeneous, then degree of this rational function is also homogeneous of degree equal to degree of numerator minus degree of denominator. So you can see that in this case degree of numerator was 1, degree of denominator was 3. So 1 minus 3, that's gonna give you -2. Is that fine? Moving on, a question for you. That is equal to x to the power a y plus y to the power b upon x minus y. So this function is homogeneous of degree 2. Find a and b. बताओ a और b की वैल्यू क्या आएगी? क्वेश्चन है दैट we have a function x to the power a into y plus y to the power b upon x minus y, and this function is homogeneous of degree 2. Using this information you need to find out the value of a and b. ओके और यहाँ भी एक रैशनल फंक्शन है आपके पास. सो व्हेन वी हैव अ रैशनल फंक्शन सच दैट न्यूमरेटर एंड डेनोमिनेटर बोथ आर होमोजेनस. ओके, so then the whole rational function will also be homogeneous and the degree of homogeneity will be equal to degree of numerator minus the degree of denominator. So we'll be using this fact. In this case, since this is homogeneous of degree 2, this whole function is homogeneous of degree 2. So and degree of denominator is clearly 1. So that clearly means that 2, which is the degree of the function, this will be equal to degree of numerator minus degree of denominator. We know that the degree of denominator is 1. Degree of numerator is unknown. So using this we can see that degree of numerator will be equal to 3. And if degree of numerator is 3, then clearly यहाँ से आया होगा आपके पास जब lambda, when we'll take lambda x and lambda y, we'll get a from here in lambda's power and 1 from here. We'll get a plus 1 equal to 3, and from here b will be equal to 3. So this implies that a will be equal to 2 and b will be equal to 3. Is it fine? Okay, one more. And if you're confused about this a plus 1 and b, how is it equal to 3, then just do the whole process. Take lambda x, lambda y. So that will give you lambda to the power a plus 1. So like that. And here you'll get lambda to the power b when you replace y with lambda y. And since the degree of numerator is 3, so a plus 1 should be 3 and b should also be equal to 3. Only then you can take lambda common in the numerator. Okay, so that's how we got this a plus 1 equal to 3 and b equal to 3. Moving on, fxy is equal to natural log of x square into y cube. You need to tell me the degree of homogeneity. क्या आ रहा है? What is the degree of homogeneity? इतना मुश्किल क्वेश्चन है ये? Okay, let's do it. So we'll do f lambda x lambda y. Then we'll get lambda square x square, lambda cube y cube. This will be equal to ln lambda to the power 5 x square y cube. This is not a linear function, so this lambda to the power 5 cannot come outside. But we can use properties of log, right? So log, this here we can have log a plus log b, right? So we'll get ln lambda to the power 5 plus ln x square y cube. Okay, this can be written as 5 ln lambda plus ln of fxy. Okay, point is this is not homogeneous, so there is no point of finding out the degree. Since lambda to the power n, since lambda is not coming completely outside the function, okay, and they should be in product, that is not happening here. So this implies f is not homogeneous. Is it fine? All right. The next thing that we need to talk about today is homothetic function. So a function is said to be homothetic. It is said to be a homothetic function if fx is equal to fy and we have some positive t. This implies that f tx is equal to f ty. Okay, so basically if I increase x and y by same factors, then the functions should also increase by the same factor. Okay, where x and y are real numbers. Okay, पॉइंट नंबर 1 अभी आगे बात करेंगे कैसे. पॉइंट नंबर 1, होमोजेनस फंक्शन is always homothetic. If you have a homogeneous function, then it will be homothetic too. And point number 2 is any strictly increasing function of homogeneous function is homothetic. आप नोट कर लो, फिर क्वेश्चन के थ्रू समझेंगे. Okay, see this. We have this function a ln x plus b ln y. There is a question regarding homogeneity of functions, that what's so special about homogeneous functions. So homogeneous functions actually satisfy certain properties which are quite desirable, and when we deal with homogeneous functions, we get some good results, okay, which you will see in micro, and I'll also show you some properties that homogeneous and homothetic functions satisfy, okay. So we'll talk about these things. So for this function a ln x plus b ln y, prove f is homothetic. This function is homothetic but not homogeneous. Okay, so let's begin with this, that it is not homogeneous. Doing that is very easy because we can simply take f lambda x lambda y. We will get a ln lambda x, b ln lambda y. So this will be equal to before doing the, I can take this a inside, right, like this, ln lambda x ki power a, using one of the properties of log, that log x to the power n is equal to n log x, using that property, plus ln lambda y to the power b. So this will be equal to log a plus log b, that's log ab. So lambda a x ki power a, lambda b y ki power b. So this will be equal to ln lambda to the power a plus b, x ki power a, y ki power b. Okay, and finally log ab is log a plus log b. Clearly this is not homogeneous, okay. This function is not homogeneous because we are not getting lambda to the power something into the original function. We are not getting that. So this implies that f is not homogeneous. And before I move forward, is it clear that f is not homogeneous? क्या ये बात clear है? Is it clear that f is not homogeneous? Okay. Then now we need to prove that this function is homothetic. Okay. So the function is, see, we can write this function as ln x to the power a plus ln y to the power b, which is equal to ln x to the power a y to the power b, using two properties of log. One is n log x is equal to log x to the power n, and the other is log a plus log b is equal to log ab. Okay, so we have used these two. So I'll be using this function, and I've already shown it here. Okay, so we can write this function as ln x to the power a y to the power b. That's the function we are dealing with. Okay, so what about this? Let x to the power, let gxy equal to x to the power a y to the power b. And if I check this function, if I check whether this function is homogeneous or not, I will get lambda a plus b, the original function, back. You can do that, right? So this implies G is homogeneous. And we also know that log function, we know log is an increasing function, right? Not just increase, it is a log is a strictly increasing function. And the property is that any increasing function of a homogeneous function is homothetic, right? We also know that any strictly increasing function of a homogeneous function is homothetic. So this implies that f is homothetic. Is it fine? What you need to do next is check for homogeneity and homotheticity. That is equal to e to the power ln x square plus xy. Okay. Do that for ln x square plus ln xy as well. Then do it for ln x square plus xy. ln x square upon y square. Okay, and lastly do it for e to the power x square plus y square. Okay, you need to use both the properties. One is, if a function is homogeneous, it will be homothetic for sure, and the other one is any strictly increasing function of a homogeneous function is homothetic. Like this, you can see that x square upon y square, that's homogeneous. Log is a strictly increasing function, so any strictly increasing function of a homogeneous function is homothetic. Done. It is both. So this is a homothetic function. Okay. Can you tell me the degree of homogeneity of this function? What is the degree of homogeneity of this function? Yes, correct. 0. You'll get lambda square in the numerator, lambda square in the denominator, and then lambda to the power 2 minus 2, that's lambda to the power 0. So degree will be 0. Okay. So that's it for today. Do these problems. You need to revise this class as well, and we'll continue from this only. We'll move towards total differentials, and we need to discuss the properties of homogeneous functions. So we were talking about homogeneous functions. Let's have a quick revision of that, and then we'll continue. Okay, so if z is equal to fxy, yes, if chodo, z equal to fxy is homogeneous of degree n if f lambda x lambda y will be equal to lambda to the power n fxy for lambda positive. Okay, so such a function is called homogeneous, and the degree of homogeneity in that case is n. And एक जल्दी से एक एग्जांपल देख लेते हैं. फॉर एग्जांपल, अगर फंक्शन है मे बी x टू द पावर 0.5 y to the power 0.5, then f lambda x lambda y will be equal to lambda x to the power 0.5 lambda y to the power 0.5, which will give you lambda x to the power 0.5 y to the power 0.5, which is equal to lambda fxy. Okay, so this implies that f is homogeneous of degree 1. That is, it is linearly homogeneous. पॉइंट इज कि अगर कोई फंक्शन होमोजेनस है और उसकी डिग्री 1 है, देन सच अ फंक्शन इज कॉल्ड लीनियरली होमोजेनस. ओके, डिग्री 1 होमोजेनिटी के केस में वी कॉल द फंक्शन लीनियरली होमोजेनस. हाँ, तो ये सब हमने लास्ट क्लास में देखा था. सो नाउ द नेक्स्ट थिंग दैट वी नीड टू कवर इज प्रॉपर्टीज ऑफ होमोजेनस फंक्शंस. ओके, we'll be talking about properties of homogeneous functions. All right, so if Z is homogeneous of degree n, then property 1 is that Z को आप लिख सकते हो x to the power n g y by x, और आप उसे y to the power n h एज अ फंक्शन ऑफ रेशियो ऑफ एक्स एंड वाई, इस तरीके से लिख सकते हो. ठीक है, पहले आप नोट कर लो, फिर समझते हैं इस बात को. सो z here z is a function of x and y. Okay, did I write that? If यहाँ कर लेना आप z is equal to fxy. Okay, so z is a function which depends upon two variables x and y, and it is homogeneous of degree n. Okay, so now one thing that is interesting about these functions is that in these homogeneous functions you can rewrite the function as a ratio of the variables on which it depends. So that ratio can be y to x as well as x to y. Okay, so let's quickly check this, like how is it happening. So maybe z is equal to x square plus xy plus y square. This is clearly homogeneous of degree 2. अगर आप यहाँ पर x की जगह lambda x और y की जगह lambda y डालोगे, then lambda square will come out. So this is homogeneous of degree 2. So n is the degree of homogeneity. तो यहाँ पर notice करो, if I take x square common, then I will get 1 plus xy divided by x square will get y by x. Y square divided by x square will get y upon x square. Okay. So now notice that this part of the function fxy, this depends on y upon x. Okay, here this part is a constant. So when we write a function, we just write on what things the function depends, the variables on which it depends, not the constants. Okay, so similarly this part of the function, it depends upon the ratio y is to x. Okay, so this is nothing but x square into, we can call this part another function, let's say g, which is a function of y upon x. Okay, is this point clear? Is this point clear? Yeah, okay. Similarly, if I take y square common, then x square divided by y square, that will be x upon y square. This part will give me xy upon y square, that will give us x by y. And then y square divided by y square, that gives us 1. So again, we can see that this part of the function depends upon x upon y, and we can write it like another function h, which, so where h x upon y, that is this part, x by y square plus x by y plus 1, which is a function depending upon the ratio of x and y. Okay, so that's how this thing is true. Is it fine? And of course, if the degree of homogeneity is 1, then we'll just get x here, not square or any other thing, just x. Okay. If there, in general, you can write here n, but for linear homogeneity, we'll get 1 here. Okay. Moving on to the next property. Property 2. If z is homogeneous of degree n, then del z by del x and del z by del y are homogeneous of degree n minus 1. Okay. So if the initial function z, it is homogeneous of degree n, then its partial derivatives, first order partial derivatives will also be homogeneous, but of degree 1 less than the initial function, which is n minus 1 in this case. Okay. So that's quite obvious. Like whenever we differentiate a function, maybe x square, then we get 2x, then power becomes 1. If we are differentiating maybe x to the power 5, then we get 5x to the power 4. The power becomes 1 less than the initial function after differentiating. So that's the idea here. But the interesting thing is that after the partial derivative, the function still remains homogeneous, and but the degree of homogeneity gets reduced by 1. Okay. We can prove it too, and we can see this via example as well. Let's start with the proof. Well, z is, so for this we can write that z is equal to x to the power n g y by x, right? From property 1. So now if I differentiate partially with respect to x, I'll get n x to the power n minus 1 g y by x as it is, plus x to the power n is, as it is, g dash y by x, and then for y by x we'll get minus y upon x square. Okay. So this will give us this part will give us minus x to the power n minus 1 y by x g dash y by x. Okay. And here we already have n x to the power n minus 1. Yeah, fine. g y by x. Okay, so now I can take x to the power n minus 1 common, and that will give us n gy by x minus y by x g dash y by x. Okay, so you can now clearly see that we have things in the ratio of y by x. So with jab you'll take lambda y and lambda x, so those lambdas will get cancelled out. Okay, and here we'll get lambda to the power n minus 1 outside. So that means that del z by del x is homogeneous of degree n minus 1. Let me repeat what I'm saying. When for checking the homogeneity, it is clearly homogeneous because when we'll replace y with lambda y and x with lambda x, here lambda will get cancelled out, here lambda will get cancelled out, here lambda will get cancelled out, and here lambda will come out and the power will be n minus 1. Okay, so that clearly means that this function del z by del x is homogeneous of degree n minus 1, right? Is this proof clear? Yes? Okay. And we can also take an example. So एक example के through समझ लेते हैं इसे. Suppose z is equal to x square y cube. And we also need to prove regarding del z by del y, so you can do it yourself. Just follow the same process, but you'll use here y to the power n and here x by y. Okay, then you can continue doing this and you'll be able to prove that del z by del y is also homogeneous of degree n minus 1. Okay, so you can do that. So del z by del x, it will be 2x y cube, and del z by del y will be equal to 3x square y square. Okay, now clearly 2 lambda x lambda cube y cube, this will give you lambda to the power 4 2x y cube. Okay, which is the initial del z by del x function. So this will give you lambda to the power 4 del z by del x. So if you in del z by del x, you take lambda x and lambda y in so you can now see that the initial function was homogeneous of degree 3 plus 2 5. Now it is homogeneous of degree 4, this first order partial derivative. And similarly in this case, if I take lambda x lambda y, will get this will give you lambda to the power 4 3x square y square, which is lambda to the power 4 del z by del y. Again, hence prove that this also is homogeneous of degree 4, while the initial function was homogeneous of degree 5. Is it fine? Okay. Then the third and the most important property of homogeneous functions is Euler's theorem. Okay, that's the main thing. And based on that, we get a lot of questions in the exams in CUET, IIT. Okay, so those questions are asked, which are related to the third property called the Euler's theorem. Third is Euler's theorem. So some people call it Euler, but it's the name of the famous mathematician and it's actually pronounced Euler. Okay, so let's stick to Euler. And the theorem is that x del z by del x plus y del z by del y. This gives you back the initial function multiplied by the degree of homogeneity. Okay, here this n is the degree of homogeneity. Okay, and z is the initial function, where z is this fxy. We can prove this, but that would be of no use. So again, let's take an example. So let's take the function to be, or proof is very easy again using those things. So just replace del z by del x with the derivative of these. Okay, if you replace the del z by del x with derivative of this and del z by del y with derivative of this one, then you can continue and easily prove the result of Euler's theorem. Okay, but we don't need to do that. Let's just quickly check that whether it works or not. Okay, so again let's take that function x square y cube, which is in this case this is homogeneous of degree 5. Yes, so now let's just put everything here and see whether we are getting 5 times the initial function or not. Okay, so let's first find out del z by del x. Del z by del x, that will be equal to 2x y cube. Okay, del z by del y निकाल लेते हैं, we'll get 3x square y square. Now let's put everything here. So x del z by del x, y del z by del y. What will we get? We'll get 2x square y cube plus 3x square y cube. That gives us 3 plus 2, 5x square y cube, which is nothing but 5 times the initial function. Okay, so we can clearly see that Euler theorem is working here. Is it fine? And another important point here is, if Z is linearly homogeneous, that is n equal to 1, then x del z by del x plus y del z by del y will be simply equal to the initial function back. You'll get the function back. Okay. And there was one more name of this. Yeah, product exhaustion theorem. Euler's theorem is also called product exhaustion theorem. That's basically in economics terms. So if you treat this z as a production function, so that's the production function. Okay, so your product, your output gets exhausted like this. It gets finished up. Okay, so that's why it is also called product exhaustion theorem. Now we'll be revising integration. You must have studied it in your high school in 11th and 12th, mainly in class 12th. So we just need to revise that. So not needed at this point. We are just doing it from the purpose of being familiar with the topic, so that if we use some of it in microeconomics or very little in macroeconomics, then you must be aware of those things. Okay, so it's just revision. Integration, and I'll be also using some things we have already studied in functions. So suppose we have a function fx, and this function, if it is a function, then the family of all its primitive antiderivative is the indefinite integral of fx. Okay, let's understand this part first. So suppose we have a function phi x plus c, where c is any arbitrary, any random constant, and if I take derivative of this, this is not one function, it is a family of function, because c can be 1, it can be 0, it can be 5, it can be minus 8, it can be any constant. Okay, so it is not a single function, it is a family of functions. So if we differentiate this, we get fx. Okay, so that means fx is the, if you differentiate phi x, then you get fx, and if you integrate fx, then you get phi x plus c. Okay, so both of these are same things. So from this we have a few results. The first one is that integration of fx is phi x, and if I replace x with a linear transformation of it, like ax plus b, where a and b are some constants, and then I integrate this, okay, then it will give us phi ax plus b divided by derivative of this linear function, which is a. So that's one of the results, and or you can call it a property of integration. So if I want to use this, then I can use this in a question like a to the power 3x plus 2. So where this dx, x is the constant of integration, okay, which means that we are integrating with respect to x, like जैसे यहाँ dx होता है in differentiation, so that means we are differentiating with respect to x. So similarly here it is telling us that we are integrating with respect to x. Okay, and how the whole thing is working here, we know that the derivative of a to the power x is a to the power x log a. Okay, so similarly integration of this thing will be a to the power x, this is a constant, upon log a. So that's how you get this. So using this back, a to the power 3x plus 2, इसका इंटीग्रेशन हो जाएगा a to the power 3x plus 2 upon log a, and using this result we need to divide by the derivative of ax plus b, यानी कि 3x plus 2 का derivative, which gives us 3 here. Okay, so and plus any arbitrary constant. So are you all aware about these properties, these results of integration? ये सब पढ़ा है आपने 12th में? Okay, let's take a step back. Maybe I am assuming too much. Let's have a quick discussion. So derivative of x to the power n is n x to the power n minus 1. So when you are differentiating something, this gets reduced to n minus 1 and you multiply by n. At the same time, if you integrate n x to the power n minus, or just integrate x to the power n. Okay, so now what you need to do is, so integration is antiderivative, basically the reverse process of differentiation. So this will give you, so in derivative one power got reduced and it also got multiplied by the initial power. So here we need to reverse both the things. So in this case we'll have to add one power क्योंकि derivative में एक power कम हो गई थी and n multiply हुआ था, तो we need to divide by n. Okay, so that's how it goes. Similarly, derivative of sin x is cos x. Okay, and so integration of cos x will be equal to sin x. And you also add plus c because if you differentiate this part, you will get x to the power n, but if you differentiate c as well, you will get 0. So what we mean to say is that क्योंकि differentiation और integration एक दूसरे का reverse process है, if integrating cos x gives you sin x, then derivative of sin x should give you cos x, but it's not the only function whose derivative will be cos x. Sin x is not the only function whose derivative will give you cos x, because let's quickly check. If I differentiate this, I get cos x, right? If I differentiate sin x plus 2, then also I'll get cos x because derivative of 2 will be 0. If I differentiate sin x minus 8, then also I'll get cos x. Okay, so when we are integrating, we don't just get a single function, we get a family of functions. That's what this definition tells us. So fx is a function, then the family of all its antiderivatives. We have a complete family of antiderivatives. By antiderivative, we mean integration. Okay, so the resulting function on integration is not just a function, it is a family of functions. Is it fine? Oh yeah, and here we'll get n plus 1. This should be n plus 1. And reason being, if you just differentiate this thing, you'll get n plus 1 x to the power n upon n plus 1. This gets cancelled out and you'll get x to the power n back. Okay. Is it fine? एक बार आप मुझे बता दोगे आपको इन चीज़ों का आइडिया है, देन अकॉर्डिंगली वी कैन मूव फॉरवर्ड. लाइक then basically according to that I'll structure the next part, like we'll discuss the basics every time or we'll just do the questions. So you tell me, are you aware about these basics? Okay, so I'm getting a response like basic is clear or just need to revise formula. So we can do that now also. So let's solve some problems and then you can keep on revising stuff. Okay, so let's move to result 2. So if degree of px is less than n, then so we are talking about this. Okay, so we have a polynomial in the numerator and we have a linear function to the power n in the denominator. So if the degree of the polynomial, that means the highest power in the polynomial, is less than n, then in that case we can write this function as a naught upon ax plus b to the power n plus a1 upon ax plus b to the power n minus 1, and so on and so forth till 0 से start हुआ, this will go to n minus 1 upon ax plus b. Okay, where all these ai's are constants. Let's see this. Let's see how this result works. Suppose we need to integrate x cube upon x plus 2 to the power 4. Okay. So you can see that in the denominator we have this linear function to the power 4 and in the numerator we have x cube. It is a polynomial whose degree, which is 3, is less than n, which is 4 in this case. So 3 is less than 4, so we can do this. So we can find out a way of writing this function as this. Okay, let's try to do that. So in the numerator we have x, in the denominator we have x plus 2. So what we can do is we can write it as x plus 2 minus 2. Right? I can add 2 and subtract 2. So now basically it's still x cube only. Okay, but we can take x plus 2 separately and minus 2 separately to deal with the denominator and cancel some things out and do all that stuff. Okay, so that can be done. X plus 2 to the power 4. Now I can use the formula for a minus b. This is a, b, so a minus b whole cube formula. We can use that. So we'll get a cube x plus 2 cube. A is x plus 2 and b is 2. So we'll get a cube minus 3a square b plus 3ab square minus b cube. Divided by x plus 2 to the power 4. Okay? Dx. So in the next step, we'll get, so from here, we'll get 1 upon x plus 2. From here, we'll get minus 6 upon x plus 2 squared plus 3 into 4, 12 upon x plus 2 cube, and finally minus 8 upon x plus 2 to the power 4 dx. Okay? So now you can see that how we are able to apply this. We are getting constants in the numerator and some power of these linear functions in the denominator. So far, is it fine? So far, is it fine? Okay. So moving on, now we need to integrate this. So integration of some functions. So we can apply that integration on each of them individually. So 1 upon x का जैसे integration होता है log x. So similarly, integration of 1 upon x plus 2, that will be log of x plus 2. Okay. Then, and that's part of the formula. This mode is part of the formula because we cannot have anything negative inside the log. Then for 1 upon x plus 2 square, okay, it's like when we have derivative of 1 by x, we get minus 1 upon x square. Okay, so if we have here 1 upon a linear function square, so for that we'll get this 1 by x back. That means we'll have, एक तो ये minus की वजह से will minus minus becomes plus 6 as it is, we'll get x plus 2. Okay, one power will get reduced in the denominator. Similarly, if I differentiate 1 upon x square, what we get is minus 2 upon x cube. अगर आपको ये formula नहीं पता, you can quickly check this. Okay, what you do is, this is x to the power minus 2 d by dx. That will give you minus 2 x to the power minus 2 minus 1. This will give you minus 2 x to the power minus 3. And then this can be written as minus 2 x 1 upon x cube. Okay. So point is, when you have 1 upon some linear functions square, then derivative of that is minus 2 divided by x cube. Okay. So similarly, if I need to integrate this part, okay, so in the denominator 1 power will get reduced. So for 3 we'll get 2. Okay, and here you are multiplying by minus 2, there you need to divide by minus 2. So we'll get minus 1 by 2, 12x plus 2 squared. Okay, I guess now you must be clear what we are doing. So for 4 we'll get 8 as it is. We'll be dividing by 3 and power will get reduced by 1. So from 4 we'll get 3. 4 minus 1, that's 3. And then plus arbitrary constant, because we'll get a family of functions. Is it fine? Is it fine? Yeah, okay. Moving on to another result, result 3. So if you are integrating a function of the type f dash x upon fx, then we'll simply get natural log of mod of fx. Okay, and we are applying mod because we inside the log we cannot have anything negative. Okay, so how will this work? For example, if we need to integrate e to the power x minus e to the power minus x upon e to the power x plus e to the power minus x dx. So now you can clearly see that numerator is the derivative of the denominator, right? Or just observe that d by dx of the denominator, which is e ki power x plus e ki power minus x, it will be equal to exponential function का derivative is exponential function, e to the power minus x के लिए it will be e to the power minus x, and then for minus x we'll get minus 1. So we get the numerator. Okay, so we'll get here natural log of mod of e to the power x minus e to the power minus x. Okay, and plus arbitrary constant. Is it fine? We can take one more example. Integration of sin x minus x cos x divided by x plus sin x dx. Okay. Let's solve this. So notice we have x plus sin x in the denominator, okay, and we have sin x in the numerator, and along with cos x we have a x. Okay, so what I can do is, what if I add x and subtract x here? Okay, उसका फायदा क्या होगा? We'll get this part same. Okay, minus x cos x divided by x plus sin x dx. So now if I divide this, then I will get integration of 1 by x minus 1 upon minus, if I take, wait, so sin x plus x, I can take minus x common here, I will get 1 plus x cos x, yeah, divided by x plus sin x dx. So this will give us integration of 1 by x minus 1 plus x cos x by x plus sin x. Oh, यहाँ x नहीं होगा. Yeah, we have already taken x common. Okay. So we know what the integration of 1 by x is. It's log x. And now we have the format here. Numerator is basically the derivative of denominator. For x, the derivative is 1. For sin x, the derivative is cos x. So numerator is the derivative of the denominator. So ultimately we'll get ln of x here minus ln of the denominator here plus arbitrary constant. Is it fine? Now just honestly tell me, are you comfortable with all these things, what I am doing right now? Or do you require to go one level behind? You are able to follow? Okay. But let me still take some simpler problems for now. And maybe we can have one more class on integration. Okay. So how about evaluating integration of ln x, natural log of x? Okay. So for doing that, we need to use integration by parts. Okay, so here we have a single function, and what we do is we can write it like product of 1 and ln x. So now we have two functions, and now we can simply apply integration by parts, which says that it will be equal to first function as it is, that means ln x, into integration of the second function, okay, minus integration of first function as it is, integration of the second function, minus whole integration of derivative of the first function, integration of the second function. Okay, this will give us ln x. For 1 will get x minus Derivative of ln x is 1 by x. Integration of 1 is x. We'll get x ln x minus, this will give you 1, and integration of 1 is x. So we will get x ln x minus 1 plus c. Is it fine? There is a question regarding trigonometry, that whether you need to do trigonometry. You just need to do the basics, basically related to sine x, cos x, integration of these, derivative of these, their domain and range. Okay, that's just that part, and how their graph looks like. Just that. So we don't need to get too much into trigonometry. That's not required. Okay. Or maybe what we can do is I'll just cover up that in the next class. Whatever trigonometry that we require, we can do that in the next class. Okay. Even the integration which we are doing right now, even that's also just enough. We don't need to get too much into integration as well. I'm just trying to cover a few famous problems that are asked in the exam. So this integration of ln x, that's often asked in CUET, so that's why I covered it. Sine root x upon root x. So now we can solve this using substitution method. So what we do there is that we can to think about it like this, ki if you differentiate sine root x, we'll get cos root x, and then for root x we'll get 1 upon 2 root x, but there is no use of cos here, and we'll not be able to take things out of it. And if you differentiate root x, we'll get 1 upon 2 root x. Okay, so this can go away if I assume this to be some other variable, like if I put root x equal to t. Now this will be useful because when I'll differentiate both sides, 1 upon 2 root x dx equal to dt. Okay, maybe you can think of it like this, differentiating with respect to t. So 1 upon 2 root x dx by dt equal to dt by dt. That gives you 1 upon 2 root x dx equal to dt. Okay, so from that we have dx upon root x will be equal to 2 dt. Dx upon root x will be equal to 2 dt. Okay, so we will get integration of, we'll get 2 outside, sine root x is t dt. Okay, and for sine we know that the integration is minus cos, so 2 minus cos t plus arbitrary constant, so minus 2 cos root x plus c. So that's the resulting function. Is it fine? Ankit, Preeti, Yusuf, Anushka, Hana, are you able to follow? Everyone else, सबको clear है? Okay, let's do one more. How about integration of x square e to the power x cube dx? This time you solve it using substitution method. There is a clear hint of substitution method. We have x cube here and x square here. We know that the derivative of x cube is x square. So just use substitution method and tell me what you are getting. Try it. Done? Let me know when you're done. Let's solve it. So we can put x cube equal to t. That will give us 3x square dx equal to dt. We'll get x square dx equal to dt by 3. Okay. So integration x square dx, that becomes dt by 3. We can keep the constant outside, e to the power t. Okay, and now it's quite simple. For e to the power t, we'll get e to the power t back by 3 plus c, and t is x cube. So e x cube by 3 plus c. That's it. किस किस का करेक्ट था? Ankit, Preeti, yeah, you were right. Okay, then try this. Try one more. Try integration of x sine 3x. And let me give you options as well so that you can just tell me which one are you getting. 1 by 3x plus 1 by 9 sine 3x plus c. Option B is, आप start कर दो solve करना. 1 by 3x cos 3x plus 1 by 9 sine 3x plus arbitrary constant. Okay. C minus 1 by 3x cos 3x plus 1 by 9 sine 3x plus c. Option D is x cos 3x minus sine 3x plus c. You should use by parts here. आया A, B, C या D? No, it's not B. करें सॉल्व करते हैं. Let's solve it. So first function as it is, integration of the second one minus whole integration of derivative of the first one integration of the second one. Okay, so that gives us x. From this we'll get minus cos 3x by 3. Then from here we'll get minus cos 3x by 3. So this becomes plus, derivative of x is 1. So integration of cos 3x by 3. Okay. And finally we have minus x cos 3x by 3 plus sin 3x by 3 into 3 will get 9 plus arbitrary constant. And this is this option C, minus x cos 3x by 3 plus sin 3x by 9. Okay. Let's do one more. Integration from, this is a definite one, we'll have limits as well. 0 to 9, x minus 1 upon 1 plus root x dx. Okay, this is actually from IIT JAM 2021. ये सॉल्व करके देखो. No, answer is not 18. Preeti, answer is not 18. Correct? Let's solve it because it is a bit tricky. So let's solve this now. So what we can do is we can use some kind of substitution here. The idea is, it is a trick which you can often use when you see -1 in the numerator. Okay, you have something -1, okay, and particularly if you have square or something here, so we can often use, like if we have a square minus b square, we get a plus b, a minus b, and if we have just a minus 1, now the idea is this can be written as root a ka square minus 1 ka square, and then you can apply this formula back. Okay, so you will get root a plus 1, root a minus 1. So whenever you see something like this -1 and some function -1 in the numerator, then you should try to connect it to this thing, that will we get any benefit out of that if we try to apply a square minus b square on that, because it is the only one is the only number whose square is it's not only 0 also, the 0 and 1, these are the numbers for which we get their number back on squaring. Okay, so we can take a benefit out of that. So notice again, when you do root a, that means when you do root x plus 1, root x minus 1, okay, so these will get cancelled out, right? So we can do this like we can write it like root x square minus 1 square upon, let's write it root x plus 1, integration 0 to 9 dx. So we will get a square minus, so a plus b, a minus b, divided by root x plus 1 dx integration 0 to 9. This will get cancelled out and we will get integration 0 to 9 of root x minus 1 dx. Okay, so where this power is basically half, so we will get x to the power half plus 1 upon half plus 1, and for 1 we'll get x, so minus x, and then we need to put the limits as well, which is from 0 to 9. So we are getting x to the power 3 by 2, 2 by 3 minus x. Yeah, 0 to 9. So we will get 2 by 3, 9 to the power 3 by 2 minus 9 minus 0. Okay, so we will get root of 9 is 3, and then its cube is 3 into 3, 9 into 3, 27. 2 upon 3 into 27 minus 9 will get 18 minus 9, that's 9. Is it fine? Okay, take a homework problem then. integration of a to the power x plus b to the power x whole squared dx. Also, after every class, I am uploading the daily practice problems. I hope you are solving them. Those problems are completely based on what we are doing in the class, so that will help you in revising the whole class. Okay, so if you just quickly go through the lecture after the class, just revise all those things and then solve, and then just start solving the practice problems. Okay, in general, for setting up the timer, you can take like 3 minutes, 2 to 3 minutes per question. Okay, so if you are taking, let's say, 30 questions, then you can take the timer to be of 60 minutes to maybe 80 minutes, so that would be fine. Okay, and you can also do like 10 to 15 problems at a time in the portal, and then after that, when you want to do the remaining questions, you can just choose not to repeat. Okay, you can choose the option that don't give you the repeated questions, and then it will give you the questions which are fresh for you. Okay, so that ways you will be able to complete the whole third set of 30 problems in maybe 2 or 3 attempts. So it's not necessary that you do all the 30 problems at once. You can do that according to like how much time you have. So you can maybe take practice sessions of 30 minutes each. Okay, so that depends upon you. But try that you take longer sessions of problem solving, because ultimately that will help you in the exam as well. Okay, because the minimum time of exams you'll have is 90 minutes, and then we have exams of 3 hours as well. So 90 minutes, 2 hours, 3 hours. So different exams have different time duration. So just make a habit of sitting with the problem for longer hours. Okay. So let's stop here. We'll continue this. So today we'll be covering more basics for integration. Okay, along with some application from economics. Okay, so suppose derivative of a function is x square. Okay, so this is same as the original function fx being 1 by 3 x cube plus arbitrary constant, because derivative of a constant is 0, so we can have any constant here, right? So C is the arbitrary constant. So an application of this thing is, from economics we have costs, right? We have total cost, which in short we write TC. Okay, and if I differentiate total cost with respect to quantity, let's say for quantity we are using the symbol x. So if I differentiate the total cost with respect to quantity, then it gives us something called marginal cost. It gives us marginal cost, in short MC. Okay, so which means this tells you cost of producing an additional unit of a commodity. Cost of producing an additional unit of a commodity. Okay, so that's marginal cost. So now let's say derivative of the total cost function, which means marginal cost, it is equal to 2x square plus 2x plus 5, and and you have to find out cost function. This is the cost function, total cost function, or just cost function. Okay, so from c dash x we need to reach cx. Okay, from c dash x we want to reach at cx. So for that we need to integrate this function, because uh, when we'll integrate, which is basically the antiderivative, so we'll get back the function. Okay, so for getting the cost function, we'll need to integrate this marginal cost function with respect to x. Okay, and that means we need to integrate 2x square plus 2x plus 5 with respect to x. Okay, so this will give us, so for 2x square we'll get 2 as it is, x square का हो जाएगा x cube by 3. Again 2 as it is, x का हो जाएगा x to the power 1 plus 1 divided by 1 plus 1, so x की power 2 by 2. And for this 5 as it is, and then integration of 1 will be x. Okay, plus arbitrary constant. Okay, is it fine? Is it fine? Okay. So the formula that we have used here is integration of x to the power a dx, which is equal to x to the power a plus 1 upon a plus 1 plus arbitrary constant. And the important thing here is that obviously this won't work अगर a की value -1 हो जाए तो. This will work only when a is not equal to -1, otherwise we'll get 0 in the denominator, which we cannot have, right? So that's why for x to the power -1 we have a different formula, that's log x, right? And similarly, using this, if we have integration of x dx, we'll get x to the power 1 plus 1 upon 1 plus 1 plus arbitrary constant, which is equal to x square by 2 plus arbitrary constant, इंटीग्रेशन ऑफ 1 अपॉन एक्स क्यूब डी एक्स. इसे आप लिख सकते हो इंटीग्रेशन ऑफ एक्स टू द पावर -3, then it will be x to the power -3 plus 1 upon -3 plus 1, which gives you x to the power -2 upon -2 plus c. So this is equal to -1 upon 2x square plus arbitrary constant. And similarly, if we want to integrate root x, then आप इसे लिख सकते हो x to the power 1 by 2, and this will be x to the power 1 by 2 plus 1, 1 by 2 plus 1 plus arbitrary constant. So we'll get x to the power 3 by 2 upon 3 by 2 plus arbitrary constant. Okay. Then another formula we have is for integration of 1 by x, which is equal to ln ln या natural log of mod x plus c. Okay. Then integration of e to the power ax, it is equal to e to the power ax divided by derivative of ax, which is a, plus arbitrary constant. Now of course this won't work if we have a equal to 0. So for applying this formula we need a to be non-zero. then integration of a to the power x dx will be equal to 1 upon ln a to the power x plus c. And for this we need a to be positive, because a to the power x जो फंक्शन है वो उसका जो डोमेन है वो होता ही a पॉजिटिव के लिए है. And another thing that we need is a should not be equal to 1. Then it's a trivial, it will be just 1. Okay, so that's of no use. And other than that, log of 1 is 0, so we cannot have that in the denominator. Okay, तो ये सब चीज़ें आपको खुद देखनी चाहिए, लाइक कि कौन सा फॉर्मूला कब एप्लीकेबल है और कब एप्लीकेबल नहीं है, और जब नहीं है तो क्यों नहीं है. ओके, दैट्स वेरी इंपॉर्टेंट दैट यू नीड टू अंडरस्टैंड why a formula is not applicable in some situation. Okay, is it fine? All right, moving on. Integration of natural log is x log x minus x plus c. Okay, verify. So ये हमने सॉल्व किया हुआ है. We did this using by parts, right? जहाँ पे one of the functions is 1 and the other one is log x. So for verification, all you can do is simply just differentiate this, and if you get ln x back, then we can say that this is true. So let's differentiate x ln x minus x plus c. So why verify? So what we are dealing with is MCQs. So mostly इंटीग्रेशन के केस में यू कैन सिंपली डिफरेंशिएट ऑल दी ऑप्शंस टू सी like which one matches with the question, okay, the function which we are integrating. So we can do that. So we'll get, for here we'll have to apply quotient rule. X as it is, for ln x we'll get 1 by x plus ln x as it is, for x we'll get 1 minus 1, for constant we'll get 0. So here we have 1 plus ln x minus 1, so which is ln x. Okay, so it's true. This is indeed the integration of ln x. Okay. Okay, moving on. So some general formulas we have of integration is related to differentiation. Like if we have a function multiplied by a constant and we are differentiating the whole thing, then we will get a dash, we'll get a out and derivative of the function, right? Also, if we have two functions and a sum of that, sum of those two functions, and we have to differentiate this whole thing, then we'll get derivative of the first function plus derivative of the second function. Okay? तो इसी का यूज़ करते हुए ए एफ एक्स का इंटीग्रेशन. So here also this constant can come out and we can just integrate the function. Okay? Similarly, if we have to integrate some of two functions fx and gx, here also we can do integration of the first function plus integration of the second function. So let's do a problem here. Integration of 3 by x minus 8 e to the power minus 4x dx. पहले आप करो इसे, solve this problem. हो गया? Oh, good. Let's do it. So 3 as it is, 1 by x का हो जाएगा ln x. Okay? And then minus 8 outside. Integration of e to the power minus 4x. So for e to the power minus 4x, we'll get e to the power minus 4x divided by derivative of minus 4x, which is minus 4. Okay? So, and plus arbitrary constant. So we'll get e ln mod x plus 2 e to the power minus 4x plus c. ठीक है, किस किस का मैच हुआ? So this was all indefinite integral because there were no limits here. Okay. Then we also have definite integral. Definite integration. So we have a situation like maybe a function looks like this, okay? And we have to find the area between a and b under this function. So if we want to find out this area, let's call it a. If I want to find out this area, then that can be simply found out using the integration. If I integrate this function over the limits a to b, then this is equal to the area under that curve between a and b. Okay. So if integration of this small fx is capital Fx, then this area is going to be f at b minus f at a. Okay. पहले fx का आपने इंटीग्रेशन किया, you get capital Fx and then you put the limits a to b. So the way it works is at first you put the upper limit and then subtract, then put the lower limit. Okay, let's see how it works. So let's say you need to calculate the area under the parabola fx equal to x square over the interval 0 to 1. Okay, that's the problem. So we have to find out this area. Okay, so it looks a bit like triangle, but it is not a triangle. Okay, we have a curve here. Okay, it is not a straight line, it is a curve. So we cannot exactly find this area using maybe area of triangle. That won't work. So to find the exact area, what we need to do is we need to integrate x square. Okay, at first let's do it. So we'll get x cube upon 3 plus arbitrary constant. But what we need is the area between 0 and 1. So we actually need to do this. So we'll get x cube by 3, 0 to 1. So we'll get 1 by 3 minus 0 by 3, which is 1 by 3. So this area is 1 by 3 units. Is it fine? Is it fine? There is a doubt in the chat box that what happened to the arbitrary constant. So let's say you keep it. Well, we use arbitrary constant mainly because we don't know what that constant was. But here, let me show you what happened. This is equal to x cube by 3 plus arbitrary constant, then the limits, right? So you will get 1 by 3 plus arbitrary constant minus this, right? So these will get cancelled out. Okay, so whenever you have limits, this arbitrary constant will always get cancelled out. So there is no point of keeping it. Okay, is it fine? तो ये हर बार ऐसे ही कैंसिल आउट हो जाएगा. Yeah, okay. So if you are clear with this, then calculate x minus x cube minus x to the power 5 dx limit from -2 to 2. ये बताओ कितना आएगा? कितना आया? Yes, answer is 0. Perfect. Let's solve it. For x, we'll have x square by 2 minus x4 by 4 minus x6 by 6. Okay. And limits are from -2 to 2. So we will get 4 by 2, 16 by 4, 64 by 6 माइनस, हाँ सेम दोबारा आपको वही चीज़ें मिल जाएंगी क्योंकि ये सब all of them have even powers, right? So we'll get the same thing again. 4 by 2 minus 16 by 4 minus 64 by 6 will get 0. Is that fine? So we have some useful properties of definite integrals. So integration of fx फ्रॉम ए टू बी इट इज़ इक्वल टू, अगर आप लिमिट्स को इंटरचेंज कर दो, यू नीड टू अप्लाई माइनस, बिकॉज एक तरीके से आप पूरा फंक्शन नीचे लेकर आ रहे हो, या नीचे है तो ऊपर, इफ यू आर फ्लिपिंग इट. ओके, so if you are flipping it, then let's say function was like this. Okay, and suppose function was like this, but आप limits कर दो अगर b to a. Okay, so suppose if initially the function had higher value at b and lower value at a, जैसे यहाँ पर है, so if you are interchanging them, then the whole thing becomes negative. So suppose it was coming out to be 2. Suppose this thing was coming out to be 2. But if you integrate instead b to a, okay, आप उल्टा कर दो यहाँ पर, then it's something like पहले 4 minus 2 हो रहा था, अब 2 minus 4 हो जाएगा, you'll get minus 2. But area cannot be negative, right? So we need to apply minus in front of that. Okay? Is that fine? Yeah, okay. If limits are same, like b is equal to a, then of course जो भी इंटीग्रेशन कर कर आएगा, you are putting the same limits. तो fa minus fa, you'll get 0. So if both the limits are same, basically you are integrating from a to a, then in that case you are simply finding out the area of the line. It is simply giving you this area, okay, and area of a line is 0. That's why you get 0. Reason being, for finding out area, you need at least 2 dimensions, like length and breadth or length or height, whatever. So you need at least 2 dimensions for finding out positive area. So, but things like unidimensional things, like a line or maybe just a dot, so for those things we don't have any area because there is a single dimension. So we cannot find area there. And just like indefinite integrals, here also if you are multiplying with any constant like alpha, here also you can take this constant outside. This alpha is a arbitrary constant or any arbitrary number. Okay. And if you are integrating a function from a to b, and suppose in between we have c, then you can integrate it. You can integrate this function from a to c. I'm missing dx everywhere. Yeah. So that you can integrate it from a to c and then from c to b. Is it fine? शैल वी मूव ऑन? यहाँ तक सब बात क्लियर है? Okay, let's discuss a application. Let's talk about consumer and producer surplus. अभी बिल्कुल रफली समझेंगे इसे, not at a deeper level. I'm assuming you don't know this concept. Okay, you might know it, but currently I'm going to assume that you don't know it. जब हम माइक्रो इकोनॉमिक्स करेंगे then we will discuss it in detail. But for now, in general, we have upward sloping supply curve. Okay, we have a upward sloping supply curve, and it is upward sloping because there is a positive relationship between price and quantity supplied. What we are trying to say is, if price increases, then a producer would like to supply more quantity. So as the price increases, maybe from P1 to P2, producer would like to sell more because he'll get more revenue, right? So he'll try to sell more. So that's why in general we have a positively sloped supply curve. And similarly, we have a downward sloping demand curve. Again, reason being that if price increases, as consumers we would like to demand less quantity. We'll demand less quantity because now price is more, we have to pay more. So since we have to pay more, so we would in general would reduce the quantity that we can have now, that we would like to have now. Okay, and the point at which these two curves intersect, that point is called equilibrium. That point is called equilibrium, where equilibrium is a situation of balance. Okay, where it is the price at which quantity demanded is equal to quantity supplied, right? Demand or supply curve. Supply curve is telling you कि अलग अलग प्राइस लेवल पर प्रोड्यूसर कितना सप्लाई करने को तैयार है. डिमांड कर्व इज टेलिंग यू लाइक अलग अलग प्राइजेस पर कंज्यूमर कितना क्वांटिटी डिमांड करने को तैयार है. एंड यू कैन सी दैट एट अ लोअर प्राइस कंज्यूमर इज विलिंग टू बाय मोर, at a higher price consumer is willing to buy less, and so on. Okay, so at this price, this is the price, let's call it P star, where quantity demanded is equal to quantity supplied, let's call it Q star. Okay, and let me just make them meet the axis. Yeah. So all these consumers who were willing to pay high like this, and they got a consumer here, he was willing to pay this much, but he got that at price P star. Another consumer was willing to pay this much, but he had to pay only this much. So this gap between the demand curve and the price line, that is the surplus that consumer is receiving. Okay, so if I find this whole area, this is called consumer surplus. This is the surplus that consumer is receiving. Similarly, supplier was willing to sell this level of quantity at this price. He was willing to do that. He was fine with that. But he actually received this price. Okay. So this is kind of a profit. Not exactly the profit. अभी बस समझने के लिए मैं इसे profit कह रहा हूँ. It is not profit. ये surplus है जो producer को मिल रहा है. Similarly, for this level of quantity, he was willing to sell at maybe at price P2, but he actually got P star. So this gap is the surplus that supplier is getting. So if I just add all that area, the area below the price line and above the supply curve. ओके अरे ये भी तो कर सकते हैं. Yeah, this. So this area below the price line and above the supply curve, that area is producer surplus. Now, of course, the next question, क्योंकि हम integration पढ़ रहे हैं, the next question is to find out consumer surplus and producer surplus, and that can easily be done using integration, and specifically integration, definite integration. Or what we can do is we will be the limits would be from 0 to Q star. Okay, तो उसका use करके हम consumer surplus और producer surplus निकाल सकते हैं. Is the idea clear? Consumer surplus, producer surplus. We'll again study this under microeconomics, but for now, roughly, is it clear? जब हम माइक्रो में होंगे तो प्रॉपर सप्लाई कर्व, डिमांड कर्व, उन सब की डेरिवेशन सब कुछ करने के बाद यहाँ तक पहुँचेंगे, तब और आपको टेक्निकली पूरा क्लियर होगा. बट फॉर नाउ रफली इंट्यूटिवली इज इट क्लियर? Okay. So let's do a question. Demand curve is P is equal to 50 minus 0.1 Q, and supply curve is P is equal to 0.2 Q plus 20. Find equilibrium price and compute CS and PS, consumer surplus and producer surplus. Okay. So one thing that you should be observing here is this, that notice for demand curve, if you find out the slope, maybe you differentiate price with respect to quantity, you will get minus 0.1. You will get minus 0.1, which means the demand curve is downward sloping. Similarly, if you differentiate price with respect to quantity in case of supply curve, you will get 0.2, which is something positive, which gives you that there is a positive relationship between price and quantity supplied. Okay, so supply curve is positively sloped. So these things should be observed. ठीक है. So at first let's find out the equilibrium, and for equilibrium what we need to do is क्योंकि equilibrium price पर quantities demanded and quantity supplied are equal, or you can say that price would be same, right? At this price both of them are intersecting, so using that, so for P star we can simply equate both of them, both the equations. Okay, so this will give us 30 equal to 0.3 q, so from that q star will be equal to 30 upon 0.3, which is 300 sorry 100, which is 100. Okay, and now we have the q star, so using that आप इस q star को either you can put it back in the demand curve equation or in the supply curve equation, you will get the same price. Okay, so you can use any of these. So I'm gonna use demand curve, so P star will be 50 minus 0.1 q star, so this will be equal to 50 minus 0.1 into 100. This will give us 50 minus 10, so which is 40. Okay, so equilibrium quantity is 100 and equilibrium price is 40. Now we need to find out consumer surplus. So for finding out consumer surplus, Q star is 100 and the lower limit is 0. We need to find out consumer surplus, this area. Okay, so we'll be integrating this curve over the interval 0 to 100. Okay, we will be integrating this curve over this interval 0 to 100. But एक issue is कि when we do that, we'll get this whole area. But we don't want area below the price line, तो वो हमें subtract करना पड़ेगा. We don't want this area. Let me show you separately. We want this, we will get this. Okay, but now to get this area we will subtract this rectangle. Okay, तो rectangle बस हमें subtract करना पड़ेगा and that's it. Okay, so for doing that, demand curve क्या है? That's 50 minus 0.1 q. Okay, and price line is 40. So if I subtract 40 here, limits हैं from 0 to 100, automatically वो 100 into 40 हो जाएगा बाद में. Okay, this आप उसे बाद में अलग से भी कर सकते हो, बट दिस बेसिकली ये 40 है, ये 100 है. ओके, so when I am subtracting 40 here, तो automatically under integration this will become 40x and after putting the limit we'll get 40 into 100. तो वो rectangle का area automatically वहाँ से subtract हो जाएगा. So we can include this minus 40 here only. Okay, या तो आप ऐसे कर सकते हो या ऐसे कर सकते हो. So you can do this subtraction separately or you can include it here only. Same thing. Okay, so this will give you consumer surplus. And सबसे पहले आप consumer surplus निकाल लो. कितना आ रहा है consumer surplus? Just solve this. What's the consumer surplus that you will get? एक बार try करो. आया? यस 500 करेक्ट आंसर है. लेट्स सॉल्व दिस. So for 50 we'll get 50q minus 0.1q square by 2 minus 40q. Limit from 0 to 100. तो 0 वाला पार्ट तो आप इग्नोर ही कर सकते हो. So you will get 50 double 0. So 5000 here minus 100 square into 0.1. 100 square into 0.1 divided by 2 minus 40 into 100. Okay, so we will get 5000 minus 4500, which is 500. So that's the consumer surplus. Consumer surplus clear है सबको? Is the consumer surplus clear? Then next thing we need to find out is producer surplus. So we need this, okay? So when we integrate this line, यानी कि 40 को अगर आप integrate करते हो, you will get this whole thing. You will get this whole thing. But we need only this part, right? So we need to now, we will integrate this function, the supply function. It will give us the area below the curve. We will subtract it and we'll be left with what's required. Okay, what we are gonna do is we'll be integrating 40, तो हमें पूरा rectangle मिल जाएगा below that 40 line, and then we'll be subtracting the supply curve. Okay, so we'll be left with just this part. So minus क्या है function? 0.2q plus 20. dq 0 to 100. That's it. निकालो कितना आएगा एंड पूछो अगर ये क्लियर नहीं है तो. एंड ऑल्सो आप ये दोनों प्रोसेस सेपरेटली भी कर सकते हो. यू कैन फाइंड आउट 40 into 100 separately and then from that you can subtract the area under the supply curve. Same thing. Okay, so you can include 40 within the integration, or you can just simply find out the area of rectangle separately and then subtract area under the supply curve from it. तो दोनों से सेम आंसर आएगा. Yes, answer is 1000. Correct. Let's do it. So 40 minus 20 will get 20 minus 0.2q. Integration 0 to 100 dq. So we will get 20q minus 0.2q square upon 2. Limits from 0 to 100. We'll get 2000 minus 100 square into 0.1, so that's 1000 minus 0. जब आप 0 वाले लिमिट डालोगे so ultimately you will get 1000. तो consumer surplus was 500 and producer surplus is 1000. So these are two main applications of econometrics of integration in microeconomics. और भी बहुत चीज़ें हैं, but like if you want to go from marginal cost to total cost, then integration is useful. Or if you want to find out some area under the curve, specifically here we have consumer surplus, producer surplus, where we have to find out areas. जहाँ पर if we don't have straight lines, then for accuracy we need to use integration. Okay, so these are some applications of integrations. Okay. Where we are integrating only 40. Are you asking ki how to do the process separately, like finding the area of rectangle separately and then from that subtracting the area under the curve? That process? Or the logic behind doing this process? What are you asking? Option 1, option 2? Are you asking method 2 or are you asking me to clarify the logic behind doing this again? लॉजिक ओके देखो जब आप इसको भी कर रहे हो ना व्हाट इज दिस इज p इक्वल टू 0.2 प्लस क्या था 20q 0.2 प्लस 20q डिड आई मिस दैट 0.2q प्लस 20 सॉरी 0.2q प्लस 20 ओके तो यहाँ पे आप क्या कर रहे हो यू आर इंटीग्रेटिंग दिस p इक्वल टू समथिंग आप इस कर्व को कर रहे हो ओके सो 0.2q प्लस 20 फ्रॉम 0 to 100 so you will get this part okay ये मिल गया what else अब ये क्या है दिस इज p इक्वल टू 40 लाइन सो व्हेन यू इंटीग्रेट दिस विद रिस्पेक्ट टू q फ्रॉम 0 to 100 ये क्या देगा आपको 40q यही तो था एरिया ऑफ रेक्टेंगल एंड 0 to 100 you will get 40 into 100 that's 4000 so which is this whole area right 40 like this is the height and the length is 100 so 40 into 100 that's 4000 उसमें से आपने सब्ट्रैक्ट कर दिया this area okay so what you got is this area is it fine now अभी clear है logic yeah okay so that's it for today and don't forget to practice problems okay so today we'll be discussing the all the topics from trigonometry which are required for MA Economics entrance. तो the thing is that जितना भी आपने ट्रिगो पढ़ा हुआ है in your school level that's much more than required okay so हमें सिर्फ उतनी चीज़ें देखनी है जो आपको क्योंकि इकोनॉमिक्स में ट्रिग्नोमेट्री का उतना यूज़ है नहीं but still multiple places पर there are applications so we'll have application in linear algebra वहाँ पर ट्रिग्नोमेट्री का यूज़ होता है कॉम्प्लेक्स नंबर के केस में होता है ओके ऑप्टिमाइजेशन में तो दैट्स ऑल अबाउट स्लोप एंड tan थीटा, राइट. सो ऑप्टिमाइजेशन में काफ़ी यूज़ होता है. हमारा लिमिट्स में ट्रिग्नोमेट्री का यूज़ होगा, डिफरेंशिएशन में होगा, इंटीग्रेशन में होगा. देयर आर सम एप्लीकेशन इन कोऑर्डिनेट ज्योमेट्री. So today's class will be focusing on all those trigo stuff जो यहाँ पर हम later on यूज़ करने वाले, ठीक है. तो आपका उसका complete idea अभी से हो जाए. ओके. सो कुछ चीज़ें will be very very simple जो आपको पहले से पता होंगी, and a few things will be new. Okay. So let's go ahead. ओके. तो एंगल से शुरू करते हैं, बिल्कुल ही बेसिक से. एंगल को मेजर करने के लिए वी हैव 2 यूनिट्स. तो एक तो वो जो डिग्री की तरह यूज़ करते हैं, लाइक 0 डिग्री और 360 डिग्री एंड दीज टाइप ऑफ थिंग्स. या फिर हम यूज़ करते हैं या एक हो गया डिग्रीज एंड द अदर थिंग इज रेडियंस. ओके. तो रेडियन इज बेसिकली अ यूनिट ऑफ रोटेशन एंड 180 डिग्री इज इक्वल टू पाई रेडियंस. So from that we have that 1 degree will be equal to pi upon 180 radians. Or you can say that 1 radian will be equal to 180 degree upon pi. Okay. So from that we need to discuss a few standard angles and radians. So we have degrees and we have radians. तो स्टैंडर्ड डिग्रीज आर 0 डिग्री पर आप ये साइन कॉट टैन कॉट सेक कोसेक इन सब की वैल्यूज निकालते हो. मतलब निकाल हम सारे एंगल्स पे सकते हैं, बट दीज आर द स्टैंडर्ड वंस. 30 डिग्री, 45 डिग्री, 60 डिग्री, 90 डिग्री, 180 डिग्री. सो दीज आर द स्टैंडर्ड वंस. ओके. सो 0 डिग्री पर रेडियंस भी 0 हो जाएंगे. फॉर 30 डिग्री आई जस्ट नीड टू सिंपली मल्टीप्लाई बाय 30 here, 30 both sides, and that will give you pi by 6. सिमिलरली यहाँ मिलेगा आपको pi by 4, pi by 3, pi by 2, pi. Okay. Since we know that 1 degree is equal to pi by 180 radians, so if I want to find out 60 degree, I just need to multiply by 60 both sides, and I will get pi by 3 radians. So that's how you get this, and other numbers as well. Is it fine? ये सबको पता है. अगर ज़्यादा बेसिक लग रहा हो आप यू कैन जस्ट क्विकली टेल मी, और वो चीज़ें हम जल्दी से कवर करते हुए आगे निकलेंगे. ओके. ये सबको पता है. या ओके. सो आफ्टर दैट लेट्स फोकस ऑन साइन एंड कॉस. द आइडिया इज, suppose we have a circle of radius 1. Okay. We have a circle, we have a unit circle. इसे कहते हैं unit circle. That is circle of radius 1. Okay, radius of 1 unit. So let's take this point. Okay, this point is x comma y. Then all the trigonometry ratios like sine, and let's say it has an angle theta with the x-axis. So we have sine theta, we have cos theta, and these are equal to perpendicular upon hypotenuse, and cos theta is equal to base upon hypotenuse. Okay. So using these, तो साइन थीटा क्या हो जाएगा यहाँ पर? वेल दिस हाइट इज इक्वल टू ऑब्वियसली वाई, जो परपेंडिकुलर डिस्टेंस है इस पॉइंट का फ्रॉम द एक्स एक्सिस, दैट्स वाई यूनिट, राइट? एंड and the distance between the origin and this point, that's x, right? So from this what we have is कि sin theta क्या आ जाएगा, और ये हो जाएगा 1, ओके, क्योंकि इट इज़ अ रेडियस और रेडियस हमने यहाँ पर 1 लिया हुआ है. तो फ्रॉम दैट, और परपेंडिकुलर इज द साइड इन फ्रंट ऑफ थीटा, एंड जो उसके साइड, जो द साइड विच इज एडजेसेंट टू थीटा, दिस वन, दैट इज बेस. दिस इज बेस in this case, and this is height, this is perpendicular. So perpendicular in this case is y, and h in this case is 1. Similarly, base in this case is x, and hypotenuse in this case is 1. So from that what we get is कि कोई भी जो point है on the कार्टेशियन प्लेन, आप उसे लिख सकते हो लाइक दिस. तो x विल बी इक्वल टू cos थीटा, एंड साइन, एंड y विल बी इक्वल टू साइन थीटा. ओके, और इसका काफ़ी सारा यूज़ हम कॉम्प्लेक्स नंबर में करने वाले हैं, एंड इवन इन लिमिट्स एज वेल. ओके, बट क्या ये वाला पॉइंट क्लियर है दैट x कॉमा y कैन बी रिटन एज cos थीटा कॉमा साइन थीटा? इज दिस पॉइंट क्लियर? xy will be equal to cos theta sin theta. Is this point clear? And we also know that tan theta is equal to P by B, perpendicular upon base. So in this case, so that's basically sin theta. अगर मैं यहाँ पर hypotenuse से divide कर दूँ in the numerator and denominator, that's basically sin, that's the ratio of sin theta and cos theta. Okay, and which is equal to P by B, which basically is giving us कि अगर आप इस पॉइंट से जीरो ओरिजिन से इफ़ यू आर मूविंग टूवर्ड्स एक्स वाई, ओके, तो दैट इज गिविंग यू कि चेंज इन वाई, इट विल टेल यू परपेंडिकुलर इज दिस, राइट? चेंज इन वाई अपॉन चेंज इन एक्स. सो tan theta is basically giving you slope of the line from the origin. It gives you slope of the line from the origin to that point. Okay, and obviously tan theta is not defined where cos theta is equal to 0, because cos theta is in the denominator. So obviously in this ratio, if cos theta is equal to 0, then tan theta will not be defined. Is it fine? Okay. Are all these things clear? Trigonometric ratios, their formulas, how are we getting these things? All fine? Okay. So now our next job is to find out the values of these trigonometric identities at various angles. So we have 0, pi by 6, pi by 4, pi by 3, pi by 2. Sine, cos, tan. 0, pi by 6, pi by 4, pi by 3, pi by 2. Yeah, works. So for theta we have 0, pi by 6, pi by 4, pi by 3, pi by 2. Okay, so this is 30 degree, 45 degree, this one is 60 degree, and this one is 90 degree. Okay, let me write that as well. 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Okay, then we have sine theta, we need the values for cos theta, and we need the values for tan theta. I know you already know these things, but let's not skip the basics. कहीं ना कहीं काम ही आएंगे. Okay, तो when the theta is 0, तो we know all the values. I know कि आपको भी सारी values पता हैं, but let's quickly see from this circle. Okay, so if theta is 0, well in that case, if theta is 0, in that case, this ये जो hypotenuse of this line to the point xy, that will be actually like this. It will be like this. तभी angle 0 होगा. It will create an angle of 0 degrees or 0 radians with the x-axis, and in that case this perpendicular distance will be 0. That is, this p will become 0. तो वहाँ पर on this at this point y is 0, so 0 by hypotenuse is still 1. So but sine theta at sine 0 is basically 0 due to this. Okay, I hope you are able to see this. P is 0, h is 1, so 0 by 1 is 0 at 0 degrees. Okay, so that's how we get this 0. Okay, and similarly we can find out cos theta. Let's see this cos theta. So at 0, when we have when this angle is 0, in that case notice कि जो base है और जो hypotenuse है, they are overlapping each other. तो base basically जो x है, that becomes 1, and hypotenuse is already 1, so that gives us cos 0 degree equal to 1. Okay, so that's why cos 0 is 1, and tan theta is basically the ratio of sine theta and cos theta, so you get 0 here. Okay, so that's how we get this, and similarly at all other angles it can be found out, but let's just complete this. 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Okay, these are the standard values जो आपको पता होनी चाहिए, and this is just reverse. So 1, then root 3 by 2, then 1 by root 2, then 1 by 2, 0. Tan theta के लिए it's just the ratio, so this will be 1 by root 3, 1, root 3, and not defined. Is it fine? Okay. Okay. Further, we have some reciprocal ratios as well. We can call it reciprocal ratios. These are called trigonometric ratios. Including these, इनको हम reciprocal ratio कह सकते हैं. I'm talking about cosec theta, secant theta, and cot theta, which are reciprocals of sine theta, cos theta, and tan theta respectively. Okay, so tan here is short for tangent. So, and cot is basically cotangent. This sec is basically secant, and cosec is cosecant. Okay. This is sine, cosine, tangent. Just for your information, इसका as in कोई use नहीं है. So another thing that you need to know is the diagrams for sine and sine, cos, and sometimes tan. We don't require these much. Almost we'll never use these mostly. Cosecant, secant, cot, ये हम पूरे entrance की preparation में मेरे ख्याल से maybe one time or maybe not any time. Okay, तो ये use नहीं होने वाले. We'll be mostly dealing with sine, cos, and tan. Tan be just mainly for slopes. Okay, but what you need to know is the diagram for sine and cos mainly. Okay, तो we know कि अच्छा यहाँ पहले radians बना लेते हैं. We have 0 and notice this. It starts from 0, then it goes to half. Slowly ये increase हो रहा है. Okay, and अभी अपने peak पर जाएगा pi by 2 पर. Okay, and then the values for these are periodic functions. So after a point they start repeating themselves. Okay, so let me give you the value. तो जो इनका diagram है, it looks like this. तो from 0 इसकी जो maximum height जाती है, that's 1, and then it comes down. Okay, then it repeats itself but in the negative section, and then so this point is pi by 2, this point is pi, ये आ जाएगा 270 degrees, that means 3 pi by 2, this is 2 pi, and then so this is one period, and then it repeats same to same again like this. So this is sin x. And very important point here is, and it does the same thing to the left of origin as well. Okay, so very important thing here is sin x always lies, so the maximum value of sin x is 1 and the minimum value is -1. ये हम बहुत use करने वाले हैं. Okay, we'll use this a lot, especially in limits. This is very useful. The maximum value of sin x is, and obviously अगर मैं यहाँ पर if I apply mode here, then the minimum value will become 0. Is it fine? Because when you apply mode, whatever is below the x-axis, that will just flip upwards. So it will be like this. It will become like this. Okay, so this one is mode of sin x. So now the minimum value is 0, and the maximum value is 1. Is this point clear? Let's quickly see the diagram for cos. So at 0 the value is 1. And at pi by 2 the value is 0. Then pi 3 pi by 2. Okay, that's all. So it's like this. Okay, so again, just like sine, it also always remains between -1 and 1. And using the same logic, if I apply mode, so obviously mode cannot be negative, so minimum value becomes 0. Is it fine? ठीक है. So from here we have a few observations. If we have sine x or sine theta, whatever the angle, whatever you want to call the angle, it can be x, it can be theta, whatever you want to call it. So if it is 0, then the angles are n theta. So at every n theta, where this n is any integer. So at pi, at 2 pi, 3 pi, 0, minus pi, minus 2 pi, minus 3 pi, at all these points sine theta is 0. At pi, 2 pi, similarly this will be 3 pi, 0, minus pi, minus 2 pi, and so on. Sine theta will be 0. Similarly, cos theta is 0, then that implies that theta is any odd pi by 2, where n belongs to the set of integers. So odd pi by 2. So यहाँ पे n 0 करोगे तो pi by 2 मिलेगा. ठीक है, so that gives you pi by 2. This also gives you, if you put 1, then 3 pi by 2, then 5 pi by 2. Because we know that 2n plus 1 is that's for odd numbers, right? 2n plus 1 is for odd numbers. So it goes like this. And if I put minus 1, then I'll get minus pi by 2. If I put minus 2, then it will give me minus 3 pi by 2, and so on. तो ये बात कर रहा है इन एंगल्स की. Similarly, if we talk about कि when is cos theta equal to 1, well, that means the corresponding angles are even pi to n pi, where n can be any integer. And yeah, that's all what we require. Is it fine? Then there are some standard formulas that you should know. We have some important standard formulas like sine square theta plus sine square theta plus cos square theta is equal to 1. And we can have a quick proof. We know कि sine is p by h, so p by h square. Cos is p by b. Oh, sorry, b by h. Cos is b by h. So this, so p square plus b square upon h square by Pythagoras theorem. Perpendicular का square plus base का square is equal to hypotenuse का square. So this gives you 1. So that's why sine square theta plus cos square theta is equal to 1. Using Pythagoras theorem. Okay. And then using this only, if I have sine x plus cos x, or maybe let's continue with theta. Sine theta plus cos theta whole square. Well, it will be sine square theta plus cos square theta plus 2 sine theta cos theta. That gives you 1 plus 2 sine theta cos theta. And then another important formula is sine 2 theta, which is 2 sine theta cos theta. So from that we have sine plus cos ka whole square will be equal to 1 plus sine 2 theta. Okay. तो these are some standard formula जो आपको पता होने चाहिए, जो हमें कभी भी काम में आ सकते हैं. Yeah. Then one point that you should be absolutely clear with is कि in general sine inverse theta is not equal to 1 upon sine theta. तो ये नॉर्मल एल्जेब्रा की तरह वर्क नहीं करता है. लाइक एक्स इनवर्स इज ऑब्वियसली 1 बाय एक्स, बट फॉर फंक्शंस इट डजेंट वर्क दैट वे, क्योंकि जो 1 बाय साइन थीटा है दैट्स बेसिकली cosec theta, right, which is not equal to sine inverse theta. That's a different thing. Okay, so and this is called sine inverse and also called, कुछ बुक्स में अगर आप अच्छी बुक्स रेफर करते हो, they call it arc sine. Okay, similarly tan inverse x is equal, this is called arctan. Okay, तो वो इन्वर्स को हम आर्क कह देते हैं. ओके, बट द पॉइंट इज कि ये इन्वर्स ट्रिग्नोमेट्रिक रेशियोज आर नॉट इक्वल टू द रेसिप्रोकल्स. ठीक है, then further a few things that we should know is कि we know about even and odd function, right? So f is even if f of minus x is equal to fx, and odd if f of minus x is equal to minus fx. तो जो साइन ऑफ माइनस थीटा होता है, दैट्स माइनस साइन थीटा. कॉस जो माइनस थीटा होता है, दैट्स कॉस थीटा. टैन माइनस थीटा इज minus tan theta. So which tells us that sine is a odd function, cos is a even function, and tan is also a odd function. Is that fine? So we talked about double angle formula for sine, this one. Let's talk about cos and tan as well. So we have sine 2 theta equal to 2 sine theta cos theta. Cos 2 theta, it is equal to cos square theta minus sine square theta. Okay, and tan 2 theta, this is equal to 2 tan theta by 1 minus tan square theta. Okay, so अगर हमारा यूज़ में आया भी तो यही आता है. दिस इज जस्ट इन केस मे बी कहीं लिमिट्स में या कहीं दिख जाए तो काम आ सकता है, अदरवाइज नॉट ऑफ मच यूज़. मेनली हमारे को काम आएगा बस इसका. ओके, इज इट फाइन? So now we can move to application part. It's time to move towards application part. तो जैसे आपने पढ़ा होगा लिमिट x टेंड्स टू 0 साइन x अपॉन x इज इक्वल टू 1. पढ़ा है आपने? एक बार मुझे बताना. आपने इफ नॉट इन कॉलेज, स्कूल में डेफिनेटली ये एक बार आता है. Have you studied this? Okay, so to understand this, we can again take the example of unit circle. Okay, let's take this point here. This is x comma y, that means this is cos theta comma this is cos theta comma sin theta. Origin this. Okay, तो sin x upon x, the thing is, और ये रहा थीटा. तो एक काम करते हैं, इसको समझने के लिए ना लेट मी मेक इट थीटा, क्योंकि ये साइन के अंदर है तो ऑब्वियसली एंगल की बात हो रही है, राइट? तो लेट्स टेक इट लाइक दिस. या तो लिमिट थीटा टेंड्स टू 0 साइन थीटा अपॉन थीटा. तो जैसे ये जो थीटा है वो 0 की तरफ जाएगा. ओके, बेसिकली व्हेन दिस गैप बिटवीन दीज this line from origin to gap between this line from origin to xy point and the x axis, इन दोनों के बीच में जो गैप है, this gap जैसे जैसे वो कम होता जाएगा. So notice that this sin theta and theta they overlap each other. Okay, जैसे जैसे ये कम होगा तो वो एक दूसरे को ओवरलैप करेंगे. ओके, सो ड्यू टू विच द रेशियो, द साइन थीटा अपॉन थीटा रेशियो एज थीटा टेंड्स टू 0, दैट बिकम्स 1. ओके, सो दैट्स वाई दिस इज इक्वल टू 1. क्या ये बात क्लियर है? Yeah, okay. And then using this only, we get some standard limits like limit x tends to 0, tan x upon x. So by the similar logic, this is also equal to 1. Like, and similarly, limit x tends to 0. And in fact, for any, if I multiply this with k, okay, किसी भी नंबर से आप अगर इस x को इस एंगल को मल्टीप्लाई कर दो डिवाइडेड बाय x, दैट विल बी इक्वल टू k. ओके, इसके बारे में हम वी कैन टॉक अ बिट मोर. So it's like, so when these two things are same and theta goes to 0, basically this thing goes to 0, then the ratio is equal to 1, right? So using that, if x goes to 0, sine 3x upon x ले लें, then what I can do is I can multiply by 3 in the numerator and denominator. What that does is कि ये दोनों चीज़ें सेम हो जाती हैं and both are going to 0 as x equals to 0. So this thing using this standard limit becomes 1, so we get 3 into 1 which is 3. So that's how you get this k. What you do is आप k से multiply करोगे in the numerator and denominator and then this thing becomes 1. So you get k into 1. You get k into 1. Is it fine? Then the other things that you need to know for entrance is the derivatives. Derivatives of these trigonometric functions. Derivatives of these trigonometric functions. शुरू करें? Okay. So derivative of sin x, derivative of cos x, sin cos, tan, cot, secant x and cosecant x. So you should be aware about, you should know the formula for each one of these. So sin का होगा cos x, for cos it's minus sin x. For tan it's secant square x. For cot it's minus cosec square x. For secant it is secant x tan x. And for cosecant x it is minus cosec x minus cosec x cot x. Okay, जिसमें से obviously the important ones are these. ये आपको definitely याद रहने चाहिए क्योंकि बाकी शायद आप अपनी एंट्रेंस जर्नी में ना देखो, बट ये दोनों आप देख सकते हो बार बार. Okay, so these two are very important and others are good to know. These are must to know and the others are good to know. Then the other thing that you should be aware about is integrals, कि इनके integrals क्या होंगे. Integrals are, and we don't, at this point we don't require the derivations. We don't need to derive these, although these can be derived. इतना मुश्किल नहीं होता है, by first principles वो करा जा सकता है, लेकिन अब वो आपके काम का नहीं रहा है. You should just know the formulas and applications. Okay. चले इंटीग्रल्स की तरफ. Shall we do the integrals? Okay. So we need integration of sin x, integration of cos x, sin, cos, tan x, cot x, ओके पहले ये कर लेते हैं. Okay, so for sin x it's minus cos x plus arbitrary constant, because here indefinite integral. For cos x it is sin x plus arbitrary constant. Then for tan x it's minus natural log of mod of cos x plus c. For cot x it is natural log of mod of sin x plus c. Okay. What else? Then integration of secant square x, integration of secant x, integration of cosecant square x, integration of cosecant x. ये कर सकते हैं. For तो secant square के लिए it is simply, if you take integration both sides, then integration of secant square x will be tan x, and integration and derivative, they will cancel out each other, so we'll get integration of secant square x as tan x. Okay, so this will be tan x plus c. Similarly for cosecant square it will be minus cot, क्योंकि ये minus है, that will just simply get, for cosecant square we'll get minus of cot x, because this minus will get transferred to the other side. Okay, so for cosecant square we'll get minus cot x, so this will be minus cot x plus arbitrary constant. For secant it is natural log of secant x plus tan x, and lastly for cosecant x it is minus natural log of cosecant x plus cot x plus arbitrary constant. Mod of cosec x plus cot x plus arbitrary constant. ठीक है. So now again the important ones are sine and cos, okay, and at max tan. और ये दोनों तो ऑब्वियस है, फ्रॉम द डेरिवेटिव ये वाला और ये वाला ऑब्वियस है. सो ये वाले अगर आपको याद नहीं भी हैं तो दैट्स फाइन, ये चलेगा, नॉट रिक्वायर्ड. दीज टू आर वेरी इंपॉर्टेंट, ये पता होने चाहिए. So these are must to know and the others are good to know. ठीक है. Okay, then other stuff is inverse trigo के derivatives. Inverse trigonometric functions के derivatives. So this can show up in some problems, but not much. Inverse trigo is ऑलमोस्ट नॉट रिक्वायर्ड. तो बस छोटी मोटी चीज़ें कभी कभी आपके सामने आ सकती हैं, लाइक डी बाई डी एक्स ऑफ साइन इनवर्स एक्स, दैट्स 1 अपॉन स्क्वायर रूट ऑफ 1 माइनस एक्स स्क्वायर, या डेरिवेटिव ऑफ कॉज इनवर्स एक्स, so that's minus 1 upon under root 1 minus 1 upon square root of 1 minus x square. Okay, and just last one, derivative of tan inverse x, that's 1 upon 1 plus x square. That's it. Is it fine? Okay. So suppose we have a sine theta plus b cos theta. तो इसका मैक्सिमम और मिनिमम पूछा जा सकता है आपसे. ओके, क्वेश्चन है फाइंड मैक्सिमम एंड मिनिमम ऑफ दिस. एंड द थिंग इज कि ये जो a साइन थीटा प्लस b कॉस थीटा है, दैट्स ऑलवेज लेस देन और इक्वल टू अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर, एंड इट्स ऑलवेज मोर देन और इक्वल टू माइनस ऑफ अंडर रूट ऑफ a स्क्वायर प्लस b स्क्वायर. ओके, लेट मी गिव यू अ क्विक एग्जाम्पल. A quick example is like आपको निकालना है ये 3 sin theta plus 4 cos theta के लिए कि what is the maximum value of this and what is the minimum value of this. Well, the maximum value will be square root of under root of 3 square plus 4 square and the minimum value will be minus of 3 square plus 4 square का square root. तो this will be 9 and plus 16 25 square root 5 हो गया. This will be minus 5. Okay. Is this application clear? So let me give you a question. Find the maximum and minimum value of mod of 5 cos theta minus 12 sin theta. ये बताओ मुझे. I got an answer minus 13 and 13. ये गलत है. Yes, 0 to 13 मोड लग चुका है. मोड लगने के बाद वैल्यू 0 से नीचे जा ही नहीं सकती. ठीक है, ये मैंने आपको साइन के टाइम पर भी बताया था दैट साइन फंक्शन लाइज बिटवीन -1 and 1 and the moment we put a mode on that then the minimum value becomes 0. तो वही वाली बात है यहाँ पर भी. So वो जो मिनिमम मैक्सिमम है दैट्स गोइंग टू बी पहले तो सिर्फ इतने की बात करते हैं 5 cos थीटा माइनस 12 sin थीटा. So this will belong to minus under root of 5 square plus minus 12 का square comma 5 square plus minus 12 का square. ओके, तो ये इसमें लाई करेगा. तो 25 144 ये हो गया 169. तो ये आ गया -13 से. या मैं एक स्टेप और लिख ही देता हूँ. तो -169 169. So this will be -13 to 13. Okay, but the moment I put mode on that, mode लगते ही वैल्यू नेगेटिव हो ही नहीं सकती. ओके, तो वो मिनिमम चला जाएगा 0 पर एंड मैक्सिमम विल बी 30. इज इट फाइन? ठीक है, क्लियर है? एनी क्वेश्चंस हियर? एक क्वेश्चन और करोगे? डू वन मोर क्वेश्चन. The same question, just this 3 sin theta plus 4 cos theta plus 1 whole square plus 2. इसकी मिनिमम और मैक्सिमम वैल्यू बताओ. हाँ हाँ, एक चीज़ मैं आपको अभी से बता दूँ, यू शुड डेफिनेटली ट्राई प्रॉब्लम्स। अगर आप लाइव अटेंड कर रहे हो या मे बी यू आर लुकिंग एट द रिकॉर्डिंग, देन डू द प्रॉब्लम एट दैट टाइम, डोंट जस्ट लुक एट द सोल्यूशन, क्योंकि अगर आप खुद प्रॉब्लम को सॉल्व नहीं करोगे देन यू विल नॉट बी एबल टू डू दैट इन द एग्ज़ाम एज वेल। ओके, सो आपको प्रैक्टिस करनी है। जब आप खुद यहाँ प्रैक्टिस करोगे तभी एग्ज़ाम में भी कर पाओगे। ओके, एंड आई हैव स्टार्टेड गेटिंग आंसर्स। 1838, 38 तो करेक्ट है। मिनिमम, yes, minimum is not 18, it's 2. Minimum is 2 and maximum is 38. चलो करते हैं, let's do it. तो what you do, what you will be doing is you should start with something you know. हमने पढ़ा था इसके बारे में कि a sin थीटा प्लस b cos थीटा का मिनिमम मैक्सिमम कैसे निकालते हैं, तो we'll start with that. Okay, so let's do. तो हम विल बी डीलिंग विद दिस एट फर्स्ट, तो इसको नीचे लेकर चलते हैं। ओके, सो तो वी नो कि जो 3 साइन थीटा प्लस 4 कॉस थीटा है, दैट विल लाई बिटवीन 3 और 4 है, तो 3 स्क्वायर 4 स्क्वायर, ये 5 माइनस 5 आ जाएगा। ये हमें पता है, अब बार बार करने की ज़रूरत नहीं है। तो वी नो कि ये -5 और 5 के बीच में होगा। आफ्टर दैट द नेक्स्ट थिंग इज यहाँ +1 किया गया है, तो वी नीड टू जस्ट ऐड 1 ऑल साइड्स। 3 साइन थीटा प्लस 4 कॉस थीटा +1 5 +1। तो जब हम 1 ऐड करेंगे सारे साइड्स में, देन इनइक्वालिटी डजंट चेंज, इट विल बी प्रिजर्व्ड। तो कुछ भी ऐड करने से अगर आप सब जगह कर रहे हो तो उससे इनइक्वालिटी चेंज नहीं होती है, तो वी कैन डू दैट। देन नेक्स्ट थिंग इज, अच्छा यहाँ पर आ गया, पहले तो इसे सॉल्व कर लेते हैं। विल गेट -4 हेयर, 3 साइन थीटा प्लस 4 कॉस थीटा प्लस 1 लेस देन इक्वल टू 6। अब है एक ट्रिकी पार्ट। ओके, यहाँ पर ध्यान देना, जहाँ मुझे लग रहा है जो गलती हुई है आप लोगों से। तो हम यहाँ पर इट्स नॉट जस्ट डायरेक्ट अलजेब्रा, थोड़ा दिमाग लगाना पड़ेगा। हम फंक्शन के साथ डील कर रहे हैं। वी हैव अ फंक्शन है जिसकी हम मिनिमम मैक्सिमम वैल्यू निकाल रहे हैं। ओके, तो द थिंग इज कि इट इज़ ऑब्वियस कि अब मुझे आगे नेक्स्ट स्टेप में स्क्वायर करना है, वो ठीक है। बट अगर मैं स्क्वायर कर रहा हूँ, ओके, स्क्वायर करने पर आप सारी वैल्यूज़ को ऊपर लेकर आ रहे हो। ओके, तो सडनली ये नेगेटिव से पॉजिटिव तो होने जाएगा। -4 का जो स्क्वायर है वो 16 होता है, राइट। तो जो चीज़, ये चीज़ पहले हमें बताया गया कि -4 से ऊपर है। ओके, स्क्वायर अगर मैं कर दूं और यहाँ इनइक्वालिटी चल रही है, बेसिकली हम ये ढूंढ रहे हैं कि इसकी मिनिमम मैक्सिमम वैल्यू क्या होगी। तो इट विल जस्ट एक्ट लाइक मोड। जैसे आप मोड लगाते हो, मैं आपको एग्जांपल देता हूँ यहाँ से, कि जैसे आपने यहाँ तक करा कि आपने किया 5 कॉस थीटा -12 साइन थीटा -13 और 13 के बीच में। नेक्स्ट स्टेप में अगर मैं आपको बोलूँ मोड लगा दो, मोड लगाया, मोड लगाया, मोड लगाया, तो क्या ये -13 का मोड 13, ये सडनली ये इसकी मिनिमम वैल्यू 13 बन जाएगी क्या? नहीं, बट इट्स वी जस्ट नीड टू यूज़ द प्रॉपर्टी ऑफ मोड, कि मोड जो है वो कभी भी नेगेटिव नहीं हो सकता। तो इस केस में इट्स नॉट जस्ट कि हम बस सारी साइड हमने मोड लगाया, हमने बस एक मोड की प्रॉपर्टी यूज़ करी कि -3 की जगह वो उसकी जो मिनिमम वैल्यू है वो उठकर 0 हो जाएगी। ठीक है, तो सेम चीज़ हमें यहाँ स्क्वायर के टाइम पर करनी है। सिमिलरली स्क्वायर की क्या प्रॉपर्टी है, मैं फिर से एक बार रिपीट करता हूँ, मैंने यहाँ पर क्या बोला कि यहाँ पर मोड लगा करके इधर 13 नहीं आएगा। ठीक है, हम मोड की प्रॉपर्टी का यूज़ कर रहे हैं। सिमिलरली जब आप यहाँ पर स्क्वायरिंग तो कर रहे हो, ओके, तो एक तो स्क्वायरिंग डायरेक्टली आप कर नहीं सकते, पहली बात तो ये समझो, अलग से समझते हैं इस बात को। डायरेक्टली स्क्वायर करना अलाउड ही नहीं है। फॉर एग्जांपल वी नो कि जो -5 है वो छोटा होता है 2 से. ओके, इफ़ आई स्क्वायर बोथ साइड्स 25 हो जाएगा, ये बन जाएगा 4. इनइक्वालिटी उल्टा बदल जाएगी. तो दैट्स वाई अगर आपको इनइक्वालिटी प्रिजर्व रखनी है, यू कैन नॉट जस्ट स्क्वायर बोथ साइड्स. ओके, इट डजंट वर्क लाइक दैट. तो अगर मुझे पता है कि कोई फंक्शन है वो -5 से बड़ा है, सो नाउ स्क्वायर ऑफ दैट फंक्शन विल बी एटलीस्ट 0, ये कह सकते हैं. ओके, दैट्स हाउ इट वर्क्स. अदरवाइज वो वाला मैं दोबारा मेंशन कर देता हूँ, ये करना अलाउड होता ही नहीं है. ठीक है, तो हम स्क्वेयरिंग जो कर रहे हैं वो मैं इस पार्ट पर कर सकता हूँ, क्योंकि अगर ये दोनों ही चीज़ें पॉजिटिव हैं तब स्क्वेयरिंग करने में कोई इशू नहीं है. ठीक है, या इफ बोथ द थिंग्स आर पॉजिटिव देन इनइक्वालिटी विल बी प्रिजर्व्ड. लाइक 1 लेस देन 2 है, यहाँ पर स्क्वेयरिंग करेंगे 1 लेस देन 4, कोई दिक्कत नहीं, अभी भी सही है. ओके, तो लेकिन अगर एक साइड नेगेटिव है जैसे यहाँ, तब आप स्क्वेयरिंग करोगे तब इनइक्वालिटी प्रिजर्व नहीं होती. सो दैट्स द इशू. यहाँ पर जो है हमारे पास हेयर दिस थिंग, सो क्योंकि इसकी कॉज और साइन की मिनिमम वैल्यू -1 होती है और ये सब चीज़ें, तो +1 यहाँ लग चुका है. सो दिस थिंग इज़ पॉजिटिव, दिस थिंग इज़ पॉजिटिव. यहाँ पर इस पार्ट में तो मैं स्क्वेयरिंग कर सकता हूँ, यहाँ नहीं कर सकता. तो सिंपली होगा क्या, -4 से ये चला जाएगा 0 की तरफ, यहाँ हो जाएगी हमारी स्क्वेयरिंग. ओके, एंड देन लास्टली वी कैन ऐड दिस 2. तो विल गेट 2 लेस देन इक्वल टू 3 sin थीटा प्लस 4 cos थीटा प्लस 1 का स्क्वायर लेस देन इक्वल टू 38. क्या पूरी बात क्लियर है या पूरा ये कॉन्सेप्ट क्लियर है? Is this concept clear? सबको क्लियर है? तो इसीलिए यहाँ पर कुछ लोगों का जो मिनिमम था वो 18 आ रहा था, उन्होंने यहाँ पर 4 का स्क्वायर करके कर दिया, -4 का स्क्वायर करके कर दिया 16, एंड देन फिर 2 ऐड करके कर दिया 18. सो दैट वाज रॉन्ग पार्ट. ओके, ये नहीं करना था, स्क्वायरिंग यहाँ कर ही नहीं सकते. तो बस आप सिंपली स्क्वायरिंग करने पर वो जो मिनिमम है उसको नेगेटिव से 0 पर ले जा सकते हो, क्योंकि किसी भी चीज़ का स्क्वायर जो है दैट कैन नॉट बी नेगेटिव. दैट्स इट. इज इट फाइन? All right then, that's it for today. So that's all trigonometry you need. इन्हीं चीज़ों की हमारी रिक्वायरमेंट है और किसी चीज़ की आपको मेरे ख्याल से ज़रूरत नहीं पड़ेगी. एंड योर आपका अब काम होगा टू सॉल्व प्रॉब्लम्स बेस्ड ऑन दीज टॉपिक्स दैट वी हैव स्टडीड टुडे. ठीक है, तो दैट विल बी अपलोड ऑन द पोर्टल, तो आप प्रैक्टिस करना स्टार्ट कर सकते हो. ओके, so today we'll be discussing propositional logic. Okay, so it's a very important topic, especially from the point of view of understanding definitions. तो बहुत सारी definitions होती हैं या properties होती हैं माइक्रो इकोनॉमिक्स में, where उनका जो proof होता है that's totally based on propositional logic. Okay, so without propositional logic you won't be able to understand कि वो property work कैसे कर रही है, फिर वो definition आपको check करनी कैसे कि whether that definition is holding or not. Okay, so from that point of view this topic is very very important. So let's start with this word कि ये proposition क्या होता है. Okay, so this proposition is basically a statement, any statement which is either true or false. Okay, ऐसा होना चाहिए, या तो मतलब उसका आपको पता लगना चाहिए कि या तो ये true हो सकता है या false हो सकता है. Okay, तो any such statement is called a proposition. Okay, so let me start with the definition of proposition. That proposition is a statement which is either true or false. So that such a statement is called a proposition. For example, 4 is less than 2, it's a proposition. Or maybe 2 into 9 is equal to 20, that's also a proposition. Or maybe x is equal to p by q, where q is not equal to 0 and p and q are integers, they belong to the set of integers. Then x is a rational number. So all these are propositions, जहाँ पर particularly this one is a false proposition. This one is also a false proposition. This one, the third one, is a true proposition. That's the correct definition of rational numbers, right? So this is a true proposition. Okay, so any statement which is either true or false, such a statement is called proposition. Proposition की definition clear है? Is the definition of proposition clear? Yeah, great. Then we can move on to logic. Okay, so next thing here is logic. So we have certain logical operations that we need to discuss. Logical operations. तो लॉजिकल ऑपरेशंस में हमारे पास मेनली 3 चीज़ें. वी हैव कंजंक्शन, we have disjunction, and we have negation. So these are 3 logical operations. Okay, conjunction, disjunction and negation. So let's start with the first one, which is conjunction. This one, इससे start करते हैं. Okay, again याद रखना, proposition is something, is a statement which is either true or false. तो ये जो conjunction है या disjunction है या negation है, that's basically you can call it कि you have 2 or more statements and then you can use these logical operations to combine them. Okay, and then the resulting statement, you have statement 1, you have statement 2, you combine them with some of the logical operations and then you get a resulting statement. Now that statement can be either true or false, and now we need to understand ki when will the resulting statement, which is a result of either conjunction or disjunction or negation, when is it true and when is it false. So we need to understand those definitions. Okay, अभी आपको समझ में आ जाएगा what I am talking about. Let me start with conjunction. Okay, so A conjunction B, where this symbol is for and, it is read as A and B. So this symbol is for and. Okay, so basically you have 2 statements and you are joining those statements using the word and. Okay, and the mathematical symbol for this is this opposite V. Okay, so now the thing is, you have combined two statements. Now when will you say, well, this a proposition, it can be either true or false. This proposition B, this can be true or false. Now after joining, when will we say that the combined statement is true or false? So that's what we are talking about now. So this A and B is true only when both A and B are true, and false otherwise. A and B, this combined statement is true only when ये भी true है, ये भी, both of them have to be true. Only then the combined statement will be taken to be true. Otherwise, it will be a false statement. Okay. So A intersection B. So ये, that's a kind of conjunction. So when does an element belong to intersection? Well, it belongs to intersection only when it belongs to A as well as to B. If a element is only in A but not in B, or it is only in B but not in A, तब वो intersection में नहीं आता, because for intersection we need that element to be in both the sets, right? So that's kind of a conjunction. So X, तो इस सेट के अंदर X तभी आएगा such that X is in A and X is in B. Okay. Something like this. This is A, this is B. So when it is in both of them, so basically X belongs to A, this is true. X belongs to A, तो ये true है. X belongs to B है, तो ये this is also true. You can see from the Venn diagram, X is in A and X is in B as well. So X belongs to A intersection B, ये true होगा. But if X belongs to A and X belongs to B, यहाँ पर this first one is true but the second one is false. That is X does not belong to B. In that case, अब क्योंकि इनमें से एक statement false है कि X does, because the X does not belong to B. So in that case, जो conjunction है, which is that X belongs to A and B, okay, this is false. Okay, so and not just this, अगर ये वाला केस होता तो भी it would be false, right? और अगर ये होता तो भी this would be false. Is it fine? Is conjunction clear? So for all of these logical operations, we have truth table. Okay, इनकी definition पर based we have truth table. Let me show you that. Okay, so A, B, A and B. We are discussing truth table for conjunction. कैसे पता conjunction? From this. This means conjunction. ये and की बात कर रहा है. Okay, so we can have 4 cases here. So A can be true and B, A and B both are true. A true, B false. A false, B is true, and both are false. These are the four cases. Every time we'll get these four cases. यही possible है. And the definition of A and B says that this combined statement will be true only when both of them are true. Both A and B are true. This is true and it is false otherwise. Okay? So that's the truth table for conjunction. Is it fine? So this is according to the definition of conjunction. Now next we need to discuss disjunction. Okay? Disjunction की बात करते हैं. We have disjunction. So this is the symbol for disjunction, which is read as A or B. This is for A or B, and such a combined statement is such a logical operation is true when either A or B is true, because ये combined इस तरीके से है. Okay, either A or B is true, that is at least one is true. And if you want to understand this, like maybe this, yeah, 5 more than or yeah. So can you tell me how do you read this part? इसे क्या पढ़ते हो आप? This part. How do you read this? How do you read this? एक बार बता दो. Yes, 5 is more than or equal to 4. Correct. So this is read as more than or equal to. Now tell me, is it true or false? Yes, more than or greater than or equal to, same thing. More than or greater than, yeah. Is it true or false? It is true, right? और ये true है. तो यहाँ पर आपको दिख रहा है दो चीज़ें. एक क्या है 5 more than 4, 5 equal to 4, right? This is made up of two things, 5 more than और equal to 4. तो और आपने मुझे खुद बताया कि ये चीज़ ट्रू है. कैसे हमने कह दिया ये ट्रू है? अगेन यहाँ पर यूज़ हो रहा है डिसजंक्शन का लॉजिकल ऑपरेशन. दिस थिंग इज ट्रू, दिस थिंग इज फॉल्स, एंड क्योंकि वन ऑफ देम इज ट्रू, सो ओवरऑल वी से दैट, क्योंकि यह और लगा हुआ है तो दोनों में से अगर एक भी ट्रू है देन वी से दैट द लॉजिकल ऑपरेशन इज ट्रू. ओके, एंड व्हाट अबाउट दिस? Is it true or false? 5 more than or equal to 5. Is it true or false? It is again true. क्यों होता है ये true? एक तरफ है आपके पास 5 more than 5 और 5 equal to 5. Okay, this thing is obviously false. 5 is not greater than 5, and this thing is true. 5 is equal to 5. That's correct. But क्योंकि one of them is true, this one is true. So since one of them is true, so overall, and because यहाँ पर or apply हो रहा है, we have a disjunction. So we say that this thing is true. Okay, so 5 more than equal to 5 is also true. ठीक है? Is this point clear? Is it clear? So that's how this logical operation disjunction works. तो इसका भी we can create a truth table. Let me get this. Okay, let's do the editing. So this time we are dealing with or. उसका symbol है ये. Just to for your like a trick, not maybe a trick. So this looks like an A, right? So this looks like a A. So this is for and. Okay, and the other one is or. So just a trick to like not to confuse these two symbols. तो अगर आपको एग्जाम में ये दिखे, then you should not get confused that whether it is for and or is it for or. So this like looks like an A, so this is for and the other one is or. Okay, that's it. Anyways, let's get back. So this disjunction is true when at least one of them is true. यहाँ तो दोनों ही true हैं, so true. And again, out of these two, this one is true, so true. Out of these two, this one is true, so again true. Now both of them are false, so this one is false. So for this we can take an example for this case. So maybe 5 is more than or equal to 6. तो यहाँ पर दो चीज़ें, क्या 5 more than 6 or 5 equal to 6? 5 more than 6, that's false. 5 equal to 6, that's false. So for this we say that this thing is false. Getting the idea? So just like in the previous case for conjunction, we had the example of A intersection B. Here what works is A union B, because A union B में क्या क्या आता है? अगर कोई एलिमेंट A में हो तो भी वो यूनियन में आता है, अगर वो B में हो तो भी वो यूनियन में आता है, अगर वो दोनों में हो तो भी वो यूनियन में आता है. कब नहीं आता है? जब वो दोनों में नहीं होता. ठीक है, ये वाला केस. तो यूनियन में when does an element does not appear in union? Only when it is neither in A nor in B. That's this case. Okay, so that's how union works here. So A union B here, ये जो X है, that's a representative of an element, कोई भी element. That तो an element, so in A union B there will be all such elements which satisfy the following property. And what's that property? That property is that कि X belongs to A, ये यूज कर सकते हो, या फिर और X belongs to B. Okay, चाहे वो A में हो या B में हो, in that case it will appear in the union. Is it fine? तो यहाँ हो चाहे यहाँ हो चाहे यहाँ हो, so for all these things we'll get X to be actually in A union B, so true for that. ओके, चलें नेगेशन की तरफ. So third logical operation is negation. So for this we have this symbol, which is read as not A, or you can call it negation of A. Okay, and this is very obvious, like when will not A be true? Yeah, I would like you to complete this. Not A is true when, क्या लगता है आपको? What do you think about this concept? This is very 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 simple. Not A कब true होगा? When? Correct. When A is false. बिल्कुल सही. When A is false. Right? कि if A is false, then obviously उसका opposite true होगा. And if A is true, then उसका opposite false होगा. Okay? For example, let's say x जो है it is 60. Okay, statement A is that x is more than 50, which is true. Then what will be not A? What will be the exact opposite of this? Well, that will be x will be less than or equal to 50. Okay, नंबर लाइन पर अगर आप हो ये 50 है, स्टेटमेंट A is more than 50, तो इसका अपोजिट क्या होगा? Equal to 60 or less. This one is strictly more than 50 है ये वाला, so it's इसका opposite होगा equal to 50 or less, right? So since A is true, x की वैल्यू 60 है, more than 50, that's correct, तो इसका opposite obviously false आएगा. Is it fine? So for conjunction, we had an example of A intersection B. For disjunction, we have A union B. Now again from set theory, can you tell me negation के लिए वहाँ पर कौन सा concept है? Which concept in set theory is for negation? कुछ याद आ रहा है? Yes, exactly. Complement. बिल्कुल सही. So for not A in set theory, we have A complement. This. Okay. Which says that x will be in A complement if x is not in A. Okay. अगर x A में नहीं है तो कहाँ होगा? वो A complement में होगा. Okay. And you can write the same thing as like this, कि x is not in A. Okay, तो x is not in A, well that means कि ये जो x है वो A complement में है, तो it's like this. ये क्या हो रहा है? So this is A. तो अगर ऑब्वियसली x a में नहीं है तो कहाँ होगा, a के बाहर होगा. एंड वी नो कि एवरीथिंग आउटसाइड a इज a कॉम्प्लीमेंट ओनली. ओके, वेयर जिसको याद नहीं है, जिसको पता नहीं है, उसके लिए x इस सिंबल का मतलब है x डज नॉट बिलोंग टू. दिस वन इज बिलोंग्स टू, और ये हो गया डज नॉट बिलोंग टू a. इज इट फाइन? तो इसका भी ट्रुथ टेबल बना लेते हैं. So here we have two things, A and not A. For A we have two cases, either it is true or it is false, because A is a proposition, तो या तो true होगा या false होगा, it cannot be both, right? तो A can either be true or A can either be false. And not A. So obviously if A is true, then not A has to be false. And if A is false, then not A has to be true. So that's the truth table for negation. Is it fine? Everyone, is it fine? चलो फिर अब आपको आंसर करना है. लेट मी सी आपको कितना समझ में आया. ए और नॉट ए. नाउ यू टेल मी, इज इट ट्रू और फॉल्स? Is it true or false? Good. This has to be always true. This will be always true. And क्यों होगा ये always true? Because suppose A is true, then obviously not A will be false, and ये और है. And a disjunction is true if at least one of them is true, right? तो क्योंकि ये disjunction है, obviously अगर A true होगा तो not A false हो जाएगा. या ऐसे कहो कि अगर not A false है तो A true हो जाएगा, और अगर A false है तो नॉट ए ट्रू हो जाएगा. तो दोनों में से एक आउट ऑफ दीज टू, एटलीस्ट आउट ऑफ दीज टू एग्जैक्टली वन विल ऑलवेज बी ट्रू. ओके, तो दैट्स वाई दिस इज गोइंग टू बी ऑलवेज ट्रू, क्योंकि ये डिसजंक्शन है और लगा हुआ है. बिकॉज एटलीस्ट वन ऑफ ए एंड नॉट ए इज ऑलवेज ट्रू. दोनों एक साथ फॉल्स हो ही नहीं सकते. इज इट फाइन? नेक्स्ट क्वेश्चन, ये भी आप बताओगे पहले. हाँ जी, ट्रू और फॉल्स, ए एंड नॉट ए. ए एंड नॉट ए, ट्रू और फॉल्स? Yes, it will be always false. Because for this to be true, ये and है, okay? For this to be true, we need both of them to be true. But we know कि A and not A ये दोनों एक साथ कभी true हो ही नहीं सकते. तो अगर वो दोनों एक साथ कभी true नहीं हो सकते, तो it will never be true. वो जो conjunction है that will never be true. Okay? तो वो हमेशा इन दोनों कैटेगरी में लाई करेगा. इधर तो या तो A ट्रू होगा और नॉट A फॉल्स हो जाएगा, या फिर A फॉल्स होगा एंड नॉट A ट्रू हो जाएगा, एंड बोथ ऑफ देम विल गिव यू अ रिजल्ट ऑफ बीइंग फॉल्स when you apply this logical operation of conjunction. Okay, so this this will be always false because A and not A can never be true at the same time. Or you can say simultaneously. Okay? Awesome. तो सेट थ्योरी में वी ऑल्सो टॉक्ड अबाउट डी मॉर्गन्स लॉ, याद है? अंडर सेट थ्योरी वी टॉक्ड अबाउट डी मॉर्गन्स लॉ. Let's just quickly revise that and then we'll get back to logic. So we have A intersection B whole complement. This will be equal to what? आप complement A पर लगाओगे you'll get A complement. Intersection पर when you'll apply complement you'll get union, and for B you'll get B complement. Okay, and the proof is basically via set Venn diagrams. Okay, that can be done. And similarly A union B whole complement, that will be equal to A complement union का हो जाएगा intersection, and for B will get B complement. Okay, so here take an homework that prove these, basically not just prove, just observe these via Venn diagrams. So just create Venn diagrams yourself and try to see at first plot A intersection B and then take the complement and see ki which area are you getting, and then plot A complement B complement and take their union. Okay, and then observe that you'll get the same thing, same area for both of these. Okay, तो ये एक बार try करना आप. Now moving on, we have what about complement of not A? ये क्या आएगा? Complement of not A, what will we get? Exactly, we'll get A. Yeah, we will get A. It's like A complement of A complement. This is equal to A. Then which is same as this. Not of not A, you'll get A back. Not of not A, you'll get A back. And basically A complement and not A, they are same things. So when you are dealing with statements, you use this symbol, not A. And when you are dealing with set, then you will use this symbol or A dash. So this is for sets and this is for propositions. Okay, let me write this as well. This one is for set and this one is for proposition. But जो उसका implication है, implication is same. Okay, and similarly the third thing is this, A complement का complement, that's again A. Is it fine? Are the symbols clear? Okay. So similarly, how about negation of P and Q? This is not a negation of proposition P, proposition Q, and this one is and, so conjunction. So not, so this is equivalent to not P. So just it's just like De Morgan's law, ये logical operations का De Morgan's law है, that when you apply this negation on and you'll get or, and when you apply negation on or you get and. So यहाँ पर you'll get or, not P. Okay. This one is for and. This one is for or. And not and will give you or and not or will give you and. Okay, तो ये चीज़ें याद रखना. Now getting back, negation of P or Q, this is equivalent to, so this is basically by definition. एक होता है equal to, that you get equal to when you like take some operations. So this is by definition. So that's how things work. This is by definition of negation. So this is basically a rule कि ये ऐसे ही होता है. Okay, कि it basically means एक होता है when there is a definition or a rule, you use this symbol, ये वाला. Okay, कि that's by definition, होता ही ऐसे है, ऐसे define ही ऐसे किया गया है. In that case, you use this symbol. Okay, so the point is कि when you apply negation, so you get negation of P. On Q, you get negation of Q. And when you apply this negation on or, you get and. So that's by definition. So that's why we use this symbol. Okay, so you can call it by definition. You call it, एक ये होता है equal to, this is equal to, and this one is by definition equal to. Or you can also call it identity. They both are identical stuff because वो define ही ऐसे किए गए हैं. Okay. Fine. So just to give you an example of, for understanding this part, so you can say that if on the left hand side you have rational numbers and on the right side you have all numbers of the form p by q, where q is not equal to 0 and both p and q belong to the set of integers. So here you will use this symbol. They both are identical things. They both are this is a definition of the left hand part. Okay. Is it fine? Okay. Let's deal with the truth table. So I need 4 cases, so it will go till this. We need P, we need Q, then we need P and Q, then we need negation of those. I need not P, I need not Q, and then I need disjunction of both. Okay. All right. So we need P, Q, P and Q, not P and Q. We need not P, not Q, not P or not Q. Okay. Okay. So again, the 4 cases that both of them can be true. True, false, false, true, both are false. Okay. Now, before I complete this, I would like you to complete this whole table. I think you can. You know how AND works, you know how OR works, you know how negation works. So just use all the rules you have just studied and try to complete this table. Okay. Once you do that, then I will complete it. Then you can check कि आपने सही करा या गलत किया है. Okay. Just try this. जैसे ही हो जाए, just tell me. Done? Okay. Let's do it. So let's begin with this. P and Q. We know कि and conjunction is true when both the propositions are true. So only this one will be true, others will be false. That's it. Okay? And then you simply need to apply negation on that. So if A is true, then negation is false. And if A is false, then obviously its negation will be true. तो opposite हो जाएगा. So true का false and false का true. That's it. Not P. So for true will get false, for true will get false, for false true, false का हो जाएगा true. Not Q. This part. Okay. So when Q is true, not Q will be false. When Q is false, not Q will be true. When Q is true, not Q will be false. And when Q is false, not Q will be true. Now, not P or not Q. We know that disjunction or is true when at least one of them is true and false otherwise. So which is this? When both are false, this will be false and true otherwise. Because yeah, in all these three cases, at least one of the propositions is true. So true for all these. Okay? So that's the complete table. किस किस का सही है? Who all got it completely correct? Just give me a yes. Oh, great. Almost everyone. Okay. So ये हमने किया क्यों है? Let me just show you one thing. See this. De Morgan's law हमने यहाँ पे we defined it that negation of P and Q is identical to not P or not, ये तो Q होना चाहिए था. 1 second. This will be Q. Not P or not Q. So now see this. Here we have negation of P and Q and here we have negation of P or negation of Q. Basically यहाँ notice करो, here we have used, we have the De Morgan's law. So this is basically a proof via truth table. So this works for propositions. तो यहाँ पर we have proved, और proof कैसे हुआ है? See this, same, false, false, true, 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 true. So for the same, for each of these cases, we are getting the same result for both of these. Okay, so which means so this is a proof via truth table, which is saying that negation of P and Q is by definition equal to not P or not Q. Okay, we have proved this. Is that fine? Okay, chalo. Next thing is that often we are asked to find out negation of statements. For example, T is a rational number or complex number. So what is the negation of this proposition? This will be so we have T is a rational number, that's the first proposition. T is a complex number, that's the second proposition, and the logical operation used here is or. Okay, so what will be the negation of this statement? So you basically, for finding out negation, you can do this is a simple one, but let me just break it down for you ki what's the process. Okay, तो let's say कि statement P है आपके पास कि T is a rational number. T is rational number and Q है आपके पास that T is complex number. Okay, so the statement here is basically P or Q, right? And what we need to find is this negation of P or Q, which is what? Negation of P or Q is not P and not Q. Okay, तो इस हिसाब से negation क्या हो जाएगा? Negation will be, या तो आप कह सकते हो T is not rational number या फिर T is irrational, या not rational भी चलेगा. T is irrational number and not Q, which is not complex and not complex. ओके तो ये तो हो गया, मतलब अब थोड़ा इंग्लिश ठीक कर लेते हैं अपनी. तो द परफेक्ट थिंग वुड बी T इज नीदर रैशनल नॉर कॉम्प्लेक्स. दैट वुड बी द परफेक्ट स्टेटमेंट. T is neither rational nor complex number. Okay, is the idea clear? तो इफ इट इज क्लियर तो अगला स्टेटमेंट आप बताओगे. you'll tell me the negation of this. X is odd number and prime number. What is the negation of this statement? क्या आ रहा है? हमारे पास आया है x is neither odd nor a prime number. परफेक्ट, बिल्कुल सही है. तो x is not a prime number or not a x is not a odd number or not a prime number. जिसे ग्रामेटिकली एंड ठीक से लिखने का तरीका क्या होगा? x is neither odd nor prime. Okay, or you can call it, you can say x is even number or not a prime number. ठीक है, इस तरीके से ये भी लिख सकते हो. Is it fine? Okay. Now a very important topic is implications, which is used for understanding definitions. Implication. So this is read as P implies Q. Okay? P implies Q. Like, for example, if today is Christmas, then current month is December. ओके ये जो इफ देन स्टेटमेंट्स होते हैं ये इम्प्लीकेशन वाले स्टेटमेंट्स होते हैं. ओके तो इफ टुडे इज क्रिसमस देन करंट मंथ इज डिसम्बर. तो such statements based on implication, when are these true and when are these false? So we need to understand that. So we have P, this part, then we have Q, then part after the implication, okay, and the whole thing. So when will you say this whole thing is true? Okay, ये तो example है. In general, when will the whole thing be true? So since this has two parts, the first part can be true and second part can also be true. First part can be true and second part can be false. First part can be false and second part can be true, or both the parts can be false. Okay. So an implication is true. So if we start with something true and we get a result, the result is also true, then the whole thing is true. If we start with something true but end up with a false result, then that implication is said to be false. False implying anything. Okay, if you start with a false result or if you start with something false, then whatever comes next, it doesn't matter. Okay, if you start with something false, then whatever comes next, it doesn't matter. The whole implication is said to be true. Okay, so I'll give you example. So these things might seem odd, but अभी आप समझ जाओगे कि ये एक तो पहली बात तो ये all these are definitions. ठीक है. So that's how things work. That's point number one. I'm basically just trying to give you the correct mindset of understanding these things. तो ये जो यहाँ पर ये सारा आपके पास truth table है, that's according to the definition of implication. That's how implication works. Now regarding this part, I'll just try to give you an example for each thing. तो इसके लिए तो जो मैंने आपको इनिशियली स्टेटमेंट दिया था, वही यूज़ कर सकते हैं. तो इफ टुडे इज क्रिसमस, लेट्स से दिस पार्ट इज ट्रू, तो ऑब्वियसली द करंट मंथ भी दिसंबर है. ओके, दैट इज ऑल्सो ट्रू. देन ऑब्वियसली दिस होल इम्प्लीकेशन इज ट्रू, राइट? इफ टुडे इज क्रिसमस then current month is December. This whole thing is definitely true. Okay. If today is Christmas. Then नहीं, ये यहाँ पर बैठेगा नहीं. Let's just avoid this example. That's not how things work. Okay, let me give you something else. If n is more than equal to 3, then n square is more than equal to 9. Okay, so what about this? Is it a true implication? In the chat box regarding that negation of prime, जहाँ पर हमने prime number use किया था, I have getting कि that x is either even or composite. Okay, तो that would be wrong actually. तो prime का जो negation है that's not composite, क्योंकि prime के negation में 1 भी आ जाता है. Okay, and 1 is neither prime nor composite. अगर आप let's say you have a set of prime numbers, तो not prime में 1 भी आ जाएगा, and that 1 is such a number which is neither prime nor composite, so you cannot say कि prime नहीं है तो composite ही होगा, क्योंकि 1 एक ऐसा number है जो ना prime है ना composite है, so you cannot say. तो आप basically not prime को composite नहीं कह सकते. Is this point clear? You cannot call not prime as composite. क्या ये बात क्लियर है सबको? Okay. Now regarding this, this thing is true. This thing is true, then the whole thing is true. Because true implying true is a true statement. if अगर n more than equal to 3 है, ये बात true है, तो n square more than 9 ही आएगा. ठीक है, so this thing is true. Similarly, if Gandhi ji is dead, then Delhi University is a central university. I'm giving an odd example. If Gandhi ji is dead, ये part obviously true है. We know कि Gandhi ji is dead. Delhi University is a central university. We know that this is also true. So what we have is true implying true. We have statement, we have P which is Gandhi ji is dead, it is true. We have Q which is DU is Central University, that is also true. So we have P implies Q where both are true. So this implies that this implication is true. Okay, so that's how things work. Implication की ये definition है. इसी truth table का use करके you decide whether something is true or false. And the last thing here is this part. ये हमें समझने की ज़रूरत है. So for this, in short, firstly, in short, you can say that false implying anything is a true implication. Is a true implication. Okay, if you start with something false, then whatever follows, the whole implication is a true implication. Let's understand that. So suppose in your class there is a student which is like a failure student. He failed his first semester, second semester, third semester, fourth semester. वो चारों सेमेस्टर में फेल होता हुआ आ रहा है. ओके, सो नाउ यू आर जस्ट श्योर कि हो ही नहीं सकता दैट ही विल पास. इट इज नॉट पॉसिबल दैट ही विल पास द फिफ्थ सेमेस्टर. Now, if this is the situation, okay, there is a failure student, he has failed throughout. He is not getting passing marks ever. Okay, so now, following this situation, there is this statement. Let's call that guy. His name is, let's say, X. So, if X passes this semester, then I'll top CUET PG. So it's something like कि if this is possible, then anything is possible. Okay, basically if something impossible is gonna happen, then anything can happen. अगर ये पास हो गया तो कल सूरज नॉर्थ से निकलेगा. ओके, अगर ये पास हो गया तो मैं CUET PG का टॉपर. अगर ये पास हो गया तो मेरी जैम में रैंक 1 आएगी. अगर ये पास हो गया तो मेरे पास कल 1 करोड़ रुपए होंगे. तो बेसिकली इफ़ यू स्टार्ट विद समथिंग इम्पॉसिबल, देन एनीथिंग कैन हैपन. तो एंड nobody will say anything कि ये false implication है. All your friends just laugh it out and they'll like कि हाँ बिल्कुल reliable चीज़ है कि अगर ये हो सकता है, if this is possible, then anything is possible. So that's what this means. If something false has happened, then anything following that whole thing, that implication is taken to be true. क्योंकि अगर ये हो गया तो कुछ भी हो सकता है. Sorry, अगर ये हो गया तो कुछ भी हो सकता है. क्या बात समझ में आ रही है? एंड अंडरस्टैंडिंग दिस पार्ट इज़ वेरी वेरी इंपॉर्टेंट बिकॉज माइक्रो इकोनॉमिक्स में बहुत सारे डेफिनेशन इसी बेसिस पर डिसाइड होंगी. ये जो लास्ट वाला पार्ट है, फॉल्स इम्प्लाइंग एनीथिंग इज ट्रू. ओके, ऑल राइट. नेक्स्ट थिंग इज so we have P implies Q. Based on this we have two things. One is contrapositive. आप किसी भी for any implication you can find out a contrapositive of that implication. Sorry, you can find a contrapositive of that, or you can find a converse of that implication. वो आपने पढ़ा होगा ना that this is true but converse is not true, or this is true and converse is also true, and those kind of things. तो वो यही है. So what is contrapositive? If you have P implies Q, then not Q implies not P. This is called the converse, or this is called the contrapositive of P implies Q, and converse is Q implies P. Okay, that's simply so. And one thing is converse and negation both are very very different things. In negation आप simply उस चीज अगर true का false बना देते हो. Okay, but in converse that this is basically used for implications जहाँ पर आप अगर कन्वर्स को समझना चाहो तो हमारे पास बड़ा अच्छा एग्जांपल मैं लिख चुका हूँ, दिस वन. तो इफ टुडे इज क्रिसमस देन करंट मंथ इज डिसम्बर विच इज़ लेट्स से दिस इज P implies Q. बट अगर और एंड दिस इज अ ट्रू इम्प्लीकेशन. अगर आज क्रिसमस है तो डेफिनेटली दिसंबर चल रहा है क्योंकि क्रिसमस दिसंबर में आता है. नाउ अगर मैं इसका कन्वर्स निकालूं विच इज Q implies P, अगर मैं बोलूं इफ करंट मंथ इज दिसंबर देन टुडे इज क्रिसमस. नाउ दिस इज नॉट नेसेसरीली ट्रू. अगर दिसंबर चल रहा है तो पक्का नहीं है क्योंकि दिसंबर में वी हैव 31 days and Christmas is on one of those days. Okay, so it might be 29th, it might be 15th, it might be 1st of December, any of those days are possible. So we cannot say that if current month is December then today is Christmas. So that's the kind of implication where we say that this implication is true but its converse might not be true. Converse is not necessarily true क्योंकि अगर आप इसका कन्वर्स लिख रहे हो तो वो पक्का नहीं है कि क्रिसमस ही होगा, राइट. सो दैट्स कन्वर्स. तो लेट मी गिव यू एन एग्जाम्पल्स ऑफ दिस. लाइक इफ एफ डैश इज स्ट्रिक्टली पॉजिटिव, अगर if the derivative of a function is strictly positive then f is strictly increasing, right? But the converse is not true. If f is strictly increasing then it is not necessarily कि derivative strictly positive आएगा. Let me first write the converse and this is a very important question also. बहुत सारे एंट्रेंस एग्जाम में सेपरेटली पूछा जाता है किसी ना किसी तरीके से. इसका कन्वर्स क्या होगा? कन्वर्स विल बी इफ f is, and I think most of you would be surprised at this कि how is it possible, but let me just tell you. If f is strictly increasing then f dash is more than 0. तो ये ज़रूरी नहीं होता है. And for this we have an example. For example, we have x cube. We have fx is equal to x cube. Notice that for this function, this is definitely a strictly increasing function. आपको इसकी शेप पता है, right? This is a strictly increasing function. This function is definitely strictly increasing. It looks like this. Okay, it is a strictly increasing function. But जब आप इसका derivative निकालोगे, that derivative is not strictly more than 0, it is more than equal to 0. We have f dash जो आएगा that will be 3x square, which is not strictly more than 0 क्योंकि x square can be 0 as well. This is more than equal to 0. So which means कि एक strictly increasing function का जो derivative है वो ज़रूरी नहीं है कि strictly positive ही हो. It can be more than or equal to 0 as well. Okay, it can be 0 as well. So the point is, अगर derivative, if the derivative is strictly positive, then definitely function is strictly increasing. But if the function is strictly increasing, then that does not necessarily mean कि derivative strictly more than 0 ही हो, वो more than equal to 0 भी हो सकता है. क्या बात समझ में आ रही है? This is a very important thing. कन्वर्स के अलावा ये अलग से भी ये कॉन्सेप्ट पूछा जाता है. Is it fine? Okay. And another thing is, A implies B is by definition equal to not A और B. ये आप ट्रुथ टेबल से देख सकते हो. ओके, let me just prove this. Like we have P implies Q. This will be equivalent to not P or Q. Okay. So proof is in truth table. आप ट्रुथ टेबल देख सकते हो, दोनों का बिल्कुल सेम आएगा. ठीक है, आप ए इम्प्लीकेशन बी का ट्रुथ टेबल देखना, नॉट ए और बी का ट्रुथ टेबल देखना, दोनों सेम मिलेंगे. नाउ इफ वी हैव पी इम्प्लाइज क्यू, तो बाय दिस यू विल गेट कि दिस इज इक्विवेलेंट टू, दिस इज बाय डेफिनेशन इक्वल टू नॉट पी और क्यू. नाउ if I replace P with not Q and if I replace Q with not P, if I do this, then what will happen? So P will get replaced by not Q, Q will get replaced by not P. Okay, so then what will you get? From this you will get Q or not P is not P, yeah, wait, that's it. So Q or not P. So simply we can interchange the positions, which is same as not P or Q. Okay, and so basically notice that this thing is implication and this thing is contrapositive, and both are giving you same things. So basically what I want to say is कि अगर if implication is true, then contrapositive is also true, क्योंकि दोनों सेम ही चीज़ें आ रही हैं. ये हमने यही चेक किया. ये implication है और इसका जब हमने कॉन्ट्रा पॉजिटिव करा, वी अगेन गॉट द सेम थिंग. तो विच मीन्स इम्प्लीकेशन अगर ट्रू होगा तो कॉन्ट्रा पॉजिटिव भी इज ऑल्सो ट्रू. इज इट फाइन? ओके, तो लास्ट एग्जाम्पल, फिर लेट्स कॉल इट अ डे. एग्जाम्पल, तो इफ n इज मोर देन इक्वल टू 3, देन n स्क्वायर विल बी मोर देन इक्वल टू 9. दैट्स माई p implies q. ओके, इसका कॉन्ट्रा पॉजिटिव क्या होगा? नॉट q implies नॉट p. इसका कॉन्ट्रा पॉजिटिव विल बी नॉट q implies नॉट p. लेट्स चेक दैट. इफ n square is not greater than 9, then not p, then n is not greater than 3. क्या दोनों बातें सेम नहीं है? अगर किसी नंबर का स्क्वायर 9 से बड़ा नहीं है तो पक्की बात है कि वो नंबर 3 से बड़ा नहीं होगा. क्या दोनों बातें सेम नहीं है? आर बोथ दी थिंग्स सेम और नॉट? Okay. Similarly, let me give you one more example. If it is a square, then it is a rectangle. You must have read this statement in class 6th or 7th or 8th. 8 से पहले पहले ये आ जाता है. तो if it is a square, then it is a rectangle. So the definition of square is that all sides are equal. And the definition of rectangle is that opposite sides are equal. Okay, बाकी वो 90 डिग्री वगैरह सब कुछ सेम है. Definition of square is all sides equal. Definition of rectangle is opposite sides equal. So obviously अगर opposite side अगर सारी sides ही equal हैं तो opposite sides तो definitely equal आ ही जाएंगी. So that's why this is a true implication कि अगर square है तो वो shape rectangle भी होगी. आप हर square को rectangle भी कह सकते हो, उसमें कोई गड़बड़ नहीं है. ठीक है, rectangle is square as well. And now let's write the contrapositive. This is contra positive. हाँ, इसका contrapositive क्या होगा? If not Q, if it is not a rectangle, यानी कि अगर अपोजिट साइड्स ही इक्वल नहीं है तो सारी साइड कहाँ से इक्वल होंगी? देन इट इज नॉट अ स्क्वायर. अगर कोई शेप रेक्टेंगल की डेफिनेशन सेटिस्फाई नहीं कर रही है तो स्क्वायर की तो कर ही नहीं सकती. दोनों बातें बिल्कुल सेम है. द इम्प्लीकेशन एंड इट्स कॉन्ट्रापॉजिटिव बोथ आर सेम. इफ इट इज अ स्क्वायर देन इट इज अ रेक्टेंगल एज वेल. अगर सारी साइड्स इक्वल हैं तो अपोजिट साइड भी इक्वल होंगी. इफ इट इज नॉट अ रेक्टेंगल, अगर इफ द अपोजिट साइड्स आर नॉट इक्वल देन ऑल साइड्स कैन नॉट बी इक्वल. बोथ आर एग्जैक्टली सेम. So that's why implication and its contrapositive. If the implication is true, then contrapositive will also be true. If the implication is false, then the contrapositive is also false. Now the whole point is sometimes we are not able to figure out whether the implication is true or not. Okay, so in that case what we do is we try to find out contrapositive, and sometimes contrapositive is relatively easier to figure out कि true है या false है. So we can use contrapositive to comment on the implication. तो इस तरीके से वो काम आता है. Is it fine? Okay. That's it for today. We'll continue this. We'll be continuing our discussion of logic. So last time we talked about implications, contrapositive, converse, negation, all those things. तो वहीं पर आगे ऐड करो existential and universal quantifier. Okay, existential and universal quantifiers. So let's begin with universal. एक होते हैं यूनिवर्सल क्वांटिफायर. यूनिवर्सल यानी सब कुछ, राइट? तो जहाँ से हमारा सिंबल निकल कर आता है ये वाला, फॉर ऑल. ओके, एंड द अदर वन इज एग्जिस्टेंशियल, वो जो देयर एग्जिस्ट वाली चीज़ है, एग्जिस्टेंशियल क्वांटिफायर. वहाँ हमारा सिंबल निकल कर आता है ये, जिसे हम वी रीड इट लाइक देयर एग्जिस्ट, राइट? तो ये दो these are called quantifiers. Okay, so universal and existential quantifier. So if you remember the definition of indifference curve, जो हमारा फर्स्ट लेक्चर हुआ था, orientation lecture, so there I gave you the definition of indifference curve. Just a quick revision कि all combinations of x and y in the commodity space x such that you get same level of utility from that point. Okay, so such a locus is a indifference curve. So the definition of IC is for all xy points in the commodity space, all xy points in the commodity space such that utility from those points, utility from those xy points is something fixed, maybe 2. For example, 2. So this is the definition of indifference curve. Okay, so here we use these things definitions में कि universal quantifier और existential quantifiers का काफ़ी use होता है definitions में. And we need to understand the De Morgan's law for quantifiers as well. De Morgan's law for quantifiers. Okay. So we can have a proposition like all students are of 20 years of age. Okay, all students are of 20 years of age. So it's like this thing holds for all x. आप इसे ऐसे लिख सकते हो, all for all x px. Okay, which means this is basically read as for all x px is true. Okay, now can you tell me कि इसका negation क्या होगा? All students are of 20 years of age. इस proposition का negation बताओ पहले आप मुझे. क्या होगा negation? लिखो, टाइप करो. All students are of 20 years of age, इसका negation. Okay, so someone is saying no student is of 20 years of age. Well, that's incorrect. All का जो negation जो उल्टा होता है, that's not. तो basically आपको ये बताना है कि when will this statement not hold? Okay, पहले मैं गलत statement जो है वो बता देता हूँ कि negation of this is told to be no student is of 20 years of age, and this is incorrect. Okay, this is the negation which is being told, so this is a wrong negation. Okay, so point is कि मान लो in a room we have 45 students and the claim is that all students are of 20 years of age. So when will this claim not hold? ये क्लेम कब होल्ड नहीं करेगा? अगर एक भी स्टूडेंट 20 ईयर्स की एज का नहीं हुआ, देन दिस स्टेटमेंट इज रॉन्ग. तो ऑटोमेटिकली दैट बिकम्स द नेगेशन. कि अगर, तो बेसिकली ऑल का जो नेगेशन होता है दैट्स सम, SOME, सम, और मे बी यू कैन कॉल इट, और यू कैन से कि एटलीस्ट वन के लिए उल्टा हो जाए, राइट? सो अगर एक भी स्टूडेंट 20 ईयर्स ऑफ एज का नहीं निकला, देन PX इज फॉल्स. So that's basically the negation. So let me write that. If we have to find out the negation of this, कि for all x PX is true, okay? So what we mean to say is कि not all students, so not all students are of 20 years of age. और यू कैन से, एंड बेसिकली इसका जो नेगेशन होता है दैट इज फॉर ऑल का हो जाएगा देयर एग्जिस्ट्स एक्स फॉर विच PX इज नॉट ट्रू. ओके, फॉर ऑल का नेगेशन हो जाएगा देयर एग्जिस्ट्स, एंड PX का नेगेशन हो जाएगा. ओके, तो बेसिकली दैट्स द डी मॉर्गन्स लॉ फॉर क्वांटिफायर्स. फॉर ऑल का बन जाता है नॉट फॉर ऑल, बेसिकली देयर एग्जिस्ट्स एक्स, जिसके लिए दैट थिंग इज नॉट ट्रू. ओके, सो यू कैन ऑल्सो से दैट, और यू कैन से दैट देयर एग्जिस्ट्स at least one student who is not of 20 years of age. Is it fine? Is the De Morgan's law for quantifiers clear? So in short, जैसे और का negation is and का negation is or. Similarly, for all का negation is there exists, and there exists का negation है for all. Okay? Is it fine? Yeah, okay. Moving on. The main topic for today is binary relations. We're going to talk about binary relations. So at first we know what a relation is, right? कि a relation between set X and Y is what? It is a subset, right? क्योंकि when you it is a subset of X cross Y. So आप जितने भी तरीके से X और Y आपस में रिलेट कर सकते हैं, तो वो सब X क्रॉस Y में आ सकता है. ऑल ऑफ दैट इज इन X क्रॉस Y. दिस इज सेट X, दिस इज सेट Y, एंड दिस इज क्रॉस. कार्टेशियन प्रोडक्ट की हम बात कर रहे हैं. कार्टेशियन प्रोडक्ट को शॉर्ट में क्रॉस भी बोल देते हैं, कार्टेशियन प्रोडक्ट. ओके, लाइक A क्रॉस B और M क्रॉस N, दैट टाइप ऑफ थिंग. ओके, सो दैट्स अ रिलेशन. फॉर एग्जाम्पल, अगर X में है ABC and y में है def. I know you know what relation is, but just for the sake of completion, let's complete this thing. So small x is a representative element of x. So x belongs to capital X and y belongs to set y. Okay, तो जहाँ पर ये जो small x और small y, that they are representative elements. So x comma y will belong to the relation. Okay, so we can have an element here from x, and we can have an element in y, maybe e, and they can be related. Okay, so all such relations will be in the subset of x cross y, right? तो जैसे अगर मैं x क्रॉस y निकालूं, तो these are, we'll get some ordered pairs, and we call it ordered pairs because the order matters here, and जो भी सेट हमने पहले लिया है उसका एलिमेंट पहले आएगा. लाइक a can be related to d, a can be related to e, a can be related to f, then BD, BE, B and then F, then similarly CD, CE, C and then F. Okay, so that's how. So here we have 9 elements in this Cartesian product set. Okay, so this is these are all the possible relations between x and y. Okay, so and a particular relation might be, so in here we have two sets x and y. In set x we have ABC. Here we have D, E, F. So maybe A is related to F, B is related to E, C is related to D. Okay. So in this particular relation R, we have AF, BE and CD. Okay, and you can clearly see that it is a subset of x cross y. Okay, so ये एक particular relation है. This is the Cartesian product, and a relation is a subset of Cartesian product. Is that fine? Yeah, okay. So this is something you already know, right? Now let's move towards what I want to tell you today. उस तरफ चलते हैं अब. So let A be a set of alternatives. I'm basically talking about goods. Okay, so we might have a bundle here which is 1,3. We have a bundle here which is 2,2. We have a bundle here which has 3 units of x and 1 units of y. Here we have, or basically good 1. Here we have good 1, and on the y-axis we have good 2, second good. Where good is a commodity from which you get positive utility. Okay, good is a commodity from which you get positive utility. अभी के लिए इतना बहुत है. So let's say that this, लेट्स से कि इस बंडल का नाम है बंडल इज़ अ कॉम्बिनेशन ऑफ गुड्स. तो इसके अंदर एक यूनिट है गुड वन की एंड द एंड देर हेयर वी हैव 2 units ऑफ गुड वन, 2 units of good 2, so it is a combination of goods. Okay, so such a combination of goods is called a bundle. Okay, similarly इसमें 3 units of good one और 1 unit of good two है. Let's call it y. This is bundle y. Let's call this one y. ये y है and let's call this one z. Okay. Now, so we can have a different kind of relations, preferences. कि someone might prefer x to y or someone might prefer z to x. Okay, all those things are possible depending upon कि किसका utility function कैसा है. Okay, so we have preference relations over these alternatives. So let's start with the definition of preference relation here. A preference relation is a binary relation. It is a binary relation defined on a set of alternatives. Goods के combination के ऊपर आप इसे define करोगे because only then we'll be able to have some preferences कि आपके पास ये different bundles हैं, whether you like x over y or y over z, all those things. Okay, but we need certain rules, we need some conditions to be satisfied, otherwise we'll not be able to compare preferences. Okay, so these need to satisfy 3 things. We need reflexivity, we need completeness, and we need transitivity. We need these 3 properties to be satisfied. Okay, a preference relation is a binary relation, and this relation has to satisfy reflexivity, completeness and transitivity. Okay, तो वो अभी हमें समझना है कि ये होता क्या है. चलें आगे. Okay, so I'm creating a new example. It's a new example not related to the diagram. So we know that A is the set of alternatives, and let's say we have 3 alternatives x, y and z. Okay, so in bundle x we have, let's say हमारे पास 2 commodities हैं, let's say pen and orange. तो suppose इस bundle x में we have 2 pens and 3 oranges. In bundle y we have maybe 1 pen and 2 chocolates. ये हो सकता है. And maybe we have in bundle z we have 3 oranges and 1 chocolate. Okay, so इस तरीके से हमारे पास 3 bundles हैं which have different combination of goods. And u is a utility function. So when utility from x is strictly greater than utility from y, then we use this symbol. We say that this means, or maybe let me write it here. This says that x is strictly preferred over y. We mean to say here that strictly x is strictly preferred over y. That's what we mean when we use this symbol. Okay, suppose utility from x is exactly equal to utility from bundle y. ओके दो बंडल्स हैं एक्स और वाई और दोनों से कंज्यूमर को सेम लेवल ऑफ यूटिलिटी मिल रही है. देन वी राइट दिस वेयर दिस सिंबल इज फॉर इनडिफरेंट टू. इनडिफरेंट, आपको फ़र्क नहीं पड़ता दोनों के बीच में, आप कोई भी कंज्यूम कर सकते हो, यू आर गेटिंग सेम यूटिलिटी. सो वी से दैट x and y are indifferent, or you can say that consumer is indifferent between x and y. Okay, then third one is you might have a situation like this where utility from x is greater than or equal to utility from y. Okay, then we use this symbol, this. So for this we have strictly preferred. For this equality we have this indifferent to. तो इन दोनों का combination this. Okay. तो by which we कहाँ गया इरा where this means कि at least as good as, इसे कहते हैं at least as good as relation, or you can call it weakly preferred to. x is weakly preferred to y. जैसे पहले था हमारे पास strictly preferred to, here we have weakly preferred to. Okay. Now, very important thing is कि this will form the basis for everything. तो जब भी हमें definitions create करनी होती हैं, we need some basis कि उसके ऊपर आप develop करोगे, because we need a foundation. बिना उसके we cannot build anything up. तो at least as good as relation हमारा basic relation है, जिसका यूज़ करके विल बी एबल टू डिफाइन अदर रिलेशंस. जो इनडिफरेंट हो गया या स्ट्रिक्टली प्रेफर हो गया, वो हम इसका यूज़ करके डिफाइन करते हैं. ओके, लेट मी शो यू हाउ. तो जैसे वी हैव दिस एक्स इज स्ट्रिक्टली प्रेफर्ड टू वाई. अब इसकी डेफिनेशन क्या होगी? हम हाउ डू वी नो दैट एक्स इज स्ट्रिक्टली प्रेफर्ड टू वाई? तो एक्स विल बी स्ट्रिक्टली प्रेफर्ड टू वाई अगर x is weakly preferred over y, x is at least as good as y, and not y is weakly preferred over x. समझ रहे हो? एक बार लिखो फिर समझना इसको. बहुत ही अच्छी डेफिनेशन है ये, which might look confusing at first, but it will make sense. 4 greater than 2 कब होता है? when can you say that 4 is strictly greater than 2? well, अगर आप कह पाओ कि 4 is more than equal to 2 और आप ये ना कह पाओ कि 2 is greater than 4, right? then you can say that 4 is strictly greater than 2. getting the idea? 4 greater than 2 आप कब कह सकते हो? अगेन मैं इस बार हम मोर देन इक्वल टू को अपना बेसिस मानकर चल रहे हैं. सो अगर 4 को आप लिख सकते हो मोर देन इक्वल टू 2, लेकिन 2 को आप ये नहीं लिख सकते कि 2 इज ग्रेटर देन इक्वल टू 4, देन दैट मीन्स कि 4 पक्का स्ट्रिक्टली ग्रेटर देन 2 होगा. सिमिलरली व्हेन कैन यू से दैट एक्स इज स्ट्रिक्टली prefer to y? well, when x is as good as y but y is not as good as x. okay, तब आप कह सकते हो कि x is strictly preferred over y. क्या definition of x is strictly preferred over y क्लियर है? इज इट क्लियर? Yeah? Okay. Good. I think now you can create the definition for x is indifferent to y as well. मुझे लगता है अगर आपको ये समझ में आ गया है तो आप ये इसकी डेफिनेशन अपने आप सोच पाओगे, राइट? एक बार अपने माइंड में सोच लो, फिर मैं लिखता हूँ इसकी डेफिनेशन अगेन यूजिंग वीकली प्रेफर टू रिलेशन. यहाँ टू आएगा, वीकली प्रेफर टू वाई. या सो अब मैं लिख रहा हूँ, आप मैच करो. इफ एक्स इज वीकली प्रेफर्ड ओवर वाई एंड वाई इज वीकली प्रेफर्ड ओवर एक्स, अगर आप दोनों कह पा रहे हो देन ऑब्वियसली फिर आप दोनों में इंडिफरेंट हो गए. ओके, सो व्हेन कैन यू से दैट, तो मतलब ये थोड़ा ऑड लगेगा बट फोर more than equal to, let me change the color like this, कि like x और y अलग अलग चीज़ें होती हैं तो उसको, तो अगर मैं कह पा रहा हूँ कि ये पहले वाला 4 मोर देन इक्वल टू दूसरे वाला 4 और दूसरे वाला 4 मोर देन इक्वल टू पहले वाला 4, मतलब है तो दोनों 4 ही बट लाइक x और y अलग चीज़ें होती हैं तो उस वे में आई हैव जस्ट चेंज द कलर, देन दैट बेसिकली मीन्स कि 4 इज इक्वल टू 4. So this seems odd, but I'm just trying to give you an example कि how this thing works. Okay? कि अगर x is at least as good as y और y भी at least as good as x है, then that means कि आप दोनों में indifferent हो, आपको फ़र्क नहीं पड़ता है. आप x को कह रहे हो कि हाँ ये it's like, तो suppose आप you go to a Chinese restaurant and they give your friend is asking you कि whether you want to eat momos or you want to eat chow mein. Okay, so if you are given this option and so at first he is asking you to rank, so you are saying yeah momos are at least as good as chow mein. Okay, and then he asks what about chow mein and you are saying yeah chow mein is also at least as good as momos. Then basically that means आप दोनों में indifferent हो. At that point you are just willing to order anything, you are indifferent. Okay, so that thing. Is it fine? Is it fine? Yeah? Okay. So now we need to move towards reflexivity, transitivity, completeness. But before that, I need to just make you revise a thing which we discussed last time. And that thing is implications. पहला केस, दूसरा केस, तीसरा केस, चौथा केस. So we have proposition P, we have proposition Q, and then we have P implies Q. And the 4 cases are both true, true, false, false, true, false, false. So true implies, true is a true implication. True implying false is a false implication. False implying anything is a true implication. Okay? ये हम डिस्कस कर चुके हैं कि हाउ डज दिस वर्क. फॉल्स इम्प्लाइंग एनीथिंग, कि अगर इफ समथिंग फॉल्स हैज़ ऑलरेडी हैपेंड नाउ एनीथिंग कैन हैपन. ओके, अगर कुछ इम्पॉसिबल हो गया है नाउ एनीथिंग कैन हैपन. तो एंड अगेन देर इज नथिंग मोर हेयर. ये अगेन आपका एक बेसिस है. दिस इज द बेसिस फॉर ऑल डेफिनेशंस इंक्लूडिंग इम्प्लीकेशन. जिस डेफिनेशन में वी हैव टू थिंग्स कि अगर ये होगा तब ये होगा तब हमारी डेफिनेशन होल्ड करेगी. जब भी इस तरीके की डेफिनेशन आती है तो ये हमारे गोल्डन रूल्स हैं So this is logic and how much illogical it may seem, but all this is very true. एंड ये ओवर टाइम आपको समझ में आता जाएगा, ठीक है. एट फर्स्ट ये हर किसी को ऑड लगता है कि ये क्या है. देन धीरे धीरे जब आप यूज़ करना शुरू करते हो, देन यू गेट यूज्ड टू, एंड व्हेन यू गेट यूज्ड टू, यू आर स्टिल, इट स्टिल सीम्स टू बी ऑड. यू गेट करेक्ट आंसर्स बट इट स्टिल सीम्स टू बी ऑड. अल्टीमेटली आफ्टर 6 months 7 months ऑफ कॉन्टिन्यूसली यूजिंग दिस, यू आर लाइक कि हाँ अब समझ में आ रहा है ये क्या है. ओके तो ये वाली जो चीज़ें हैं ये ओवर टाइम बिल्डअप होंगी, आप समझ जाओगे. जैसे जैसे कुछ बुक्स रीड करोगे, कुछ यूज़ करोगे, समझ जाओगे, ठीक है. बट ये बिल्कुल करेक्ट है, धीरे धीरे समझ जाओगे. इसको यूज़ करना है अब हमें. लेट्स स्टार्ट विद रिफ्लेक्सिविटी. रिलेशन अगर हम किसी रिलेशन को प्रेफरेंस रिलेशन तब मानेंगे जब वो सेटिस्फाई करता है 3 चीज़ें: रिफ्लेक्सिविटी, ट्रांजिटिविटी और कंप्लीटनेस. ओके तो अब हम एक एक करके, मतलब अगर हमारे सामने एक रिलेशन होगा तो वी नीड टू बी एबल टू चेक कि वो रिफ्लेक्सिविटी सेटिस्फाई कर रहा है कि नहीं कर रहा है, कंप्लीटनेस सेटिस्फाई कर रहा है कि नहीं कर रहा है. तो उसके लिए डेफिनेशन समझनी पड़ेगी. तो रिलेशन आर सेटिस्फाई reflexivity if for all x in the set of alternatives a, x comma x belongs to R. Okay, so we have a universal quantifier here. So this thing should happen for all x. Okay, तो I'll explain you this using an example. जहाँ पर मुझे आपकी इन्वॉल्वमेंट ज़्यादा चाहिए. यू नीड टू बी वेरी एक्टिव. इन्वॉल्व होगे, सोचोगे इस बारे में तो जल्दी समझ में आएगा. ओके सिर्फ मेरे बताने पर रहोगे तो आप थोड़ा स्लो रह जाओगे. तो जस्ट स्टार्ट रिमेनिंग एक्टिव फ्रॉम नाउ ऑन. तो सपोज तो दिस इज द सेट ऑफ ऑल्टरनेटिव जिसके ऊपर रिलेशन डिफाइन होता है, ये हम बात कर चुके हैं. एक बार लिख लो, मैं आपको फटाफट समराइज कर देता हूँ हमने क्या देखा है अभी तक. जस्ट नोट इट डाउन एंड लेट मी गिव यू अ क्विक समरी हम क्या क्या देख चुके हैं. ओके देखो, यहाँ से शुरू करते हैं. तो हमें पता है पहले तो रिलेशन क्या होता है. रिलेशन अगर एक सेट, 2 सेट हैं आपके पास, उनका आपने कार्टेशियन प्रोडक्ट निकाला तो रिलेशन इज अ सबसेट ऑफ दैट. बट यहाँ पर हमारे पास एक ही सेट है विच इज अ सेट ऑफ ऑल्टरनेटिव. तो बेसिकली वी आर डूइंग दिस ए क्रॉस ए, कि इसी के ऊपर रिलेशन डिफाइंड है. ठीक है, तो सपोज वी हैव जैसे ए बी सी है, दूसरा सेट में भी ए बी सी है, दोनों सेम सेट है. तो ए बी, ए सी बी, ए बी सी ए सी, तो वो सारे रिलेशन आ जाएंगे. ओके तो जस्ट रिप्लेस डी ई एफ विद ए बी सी ओनली एंड देन, तो बेसिकली यू आर फाइंडिंग आउट द कार्टेशियन प्रोडक्ट बिटवीन एक्स एंड एक्स. एंड यहाँ पे हमारे वाले केस में ए एंड ए, क्योंकि जो एक ही सेट है हमारे पास, सेट ऑफ ऑल्टरनेटिव्स, और जो रिलेशन है वो उसी के ऊपर डिफाइंड है. तो वी आर फाइंडिंग आउट ए क्रॉस ए. दैट्स पॉइंट नंबर 1. Preference relation, it is a relation which should satisfy 3 things: reflexivity, completeness, transitivity. हम start करें reflexivity से and we are seeing the definition of reflexivity, जहाँ पर हम implications का काफ़ी use करते हैं. Okay, तो implication हमें पता है. implication is false when we have the case of true implying false. Okay, where P is true and Q is false, otherwise it is true. Implication is false only when P is true and Q is false. It is true otherwise. That's what I am saying. For all other cases, it is true. Now getting back. तो मान लो, तो we have this set of alternatives जिसके अंदर 3 bundles हैं A, B, C. एंड एक कंज्यूमर है, हमें उसका रिलेशन, उसने उसका वो हमें बता रहा है एक रिलेशन लाइक दिस ए बी एंड ए सी. ओके सो क्या ये रिलेशन रिफ्लेक्सिविटी सेटिस्फाई कर रहा है? आप इस डेफिनेशन को देखो. फॉर नाउ वील जस्ट फोकस ऑन मैथ्स, जस्ट द डेफिनेशन. इसके पीछे की जो इंट्यूशन है, इसकी जो वर्किंग है, वो माइक्रो इकोनॉमिक्स का पार्ट है. फॉर नाउ जस्ट फोकस ऑन द मैथमेटिक्स एंड डेफिनेशन एंड लॉजिक, दैट्स इट. सामने आपके एक सेट है, एक रिलेशन है, और आपको बताना है कि क्या ये रिलेशन रिफ्लेक्सिविटी सेटिस्फाई कर रहा है कि नहीं कर रहा है अकॉर्डिंग टू द डेफिनेशन. क्या लगता है, क्या ये रिलेशन R1 रिफ्लेक्सिव है या नहीं है? यस और नो? यस नो? आई जस्ट वॉन्ट टू चेक कि आपको ये मैथ्स रीड करने आ रही है कि नहीं आ रही है. रिफ्लेक्सिव तब होगा इफ फॉर ऑल x इन द सेट ऑफ ऑल्टरनेटिव्स x, x बिलोंग्स टू R. पहले आप देखो, आई एम गेटिंग एन आंसर नो एंड दैट्स अ करेक्ट आंसर. आई एक्सप्लेन इन द एंड. मुझे आंसर मिला है नॉट रिफ्लेक्सिव और ये करेक्ट है. ओके, व्हाट अबाउट R2? पहले हम 3 केस डिस्कस करेंगे एंड देन आई विल टेल यू द लॉजिक. व्हाट अबाउट दिस? अभी बस मे बी जो भी आपको समझ में आ रहा है उसके अकॉर्डिंग, ये वाला यस और नो, इज इट रिफ्लेक्सिव? A, A, is this reflexive? Now this time most people are saying yes, but it is also not reflexive. जिसने यस बोला एक बार सोचना, अब मैं बताऊंगा लेकिन अभी आप सोचो बस. ओके, व्हाट अबाउट दिस? ए ए बी बी ए सी, क्या ये रिफ्लेक्सिव है? क्या लगता है? R3 यस और नो, रिफ्लेक्सिव और नॉट रिफ्लेक्सिव? Yes, this is also not reflexive. Okay, R4 की बात करते हैं और फिर आपको पूरी कहानी समझ में आ जाएगी. We have AB, AA, AC, BB, AB, C, तो ये रिलेशन है. ओके, एंड दिस वन इज रिफ्लेक्सिव. रिफ्लेक्सिव की डेफिनेशन कहती है कि इस सेट ऑफ ऑल्टरनेटिव्स में जितने भी ऑल्टरनेटिव्स हैं, ऑल एक्स, यानी कि A, B और C तीनों के लिए, फॉर ऑल एक्स. एक्स क्या है? एक रिप्रेजेंटेटिव एलिमेंट है A का, सेट A का, कैपिटल A का. ओके, तो फॉर ऑल एक्स लिखा है, यानी कि ये बात कर रहा है सारे एलिमेंट्स की. सारे एलिमेंट्स कौन कौन से हैं? ए में वी हैव A, B एंड C. इन तीनों एलिमेंट्स के लिए, इन तीनों बंडल्स के लिए रिलेशन के अंदर बिलोंग्स टू R क्या होना चाहिए? x, x, यानी कि A, B, B और C, C होना चाहिए. जब ये तीनों होंगे, when all three A, B and C are present in the relation, only then we will say that the relation is reflexive. Otherwise it is not reflexive. Okay, so हमारे वाले इस वाले में तो R1 जो है वो रिफ्लेक्सिव क्यों नहीं है? क्योंकि इसके अंदर A, B, C तीनों मिसिंग है. जिसको लगता है कि वो बाद में भूल जाएगा, देन जस्ट note it down in the bracket ki what is the logic of this not being reflexive, because A, B and C all three are missing. Why R2 is not reflexive? Because B and C are missing. Why R3 is not reflexive? Because A है, B है, लेकिन C is missing, so this one is not reflexive because C is missing. And R4 is reflexive because A, B and C all three are present. Now someone might have a doubt कि what about these? तो इससे हमारा कोई लेना देना नहीं है. हमें सिर्फ जितना डेफिनेशन में बोला है वो चेक करना है. इसने ये नहीं बोला कि कुछ और नहीं होना चाहिए, ठीक है. इसने हमें सिर्फ इतना बोला कि A, B, C चाहिए. इसे कोई लेना देना नहीं है कि ए बी है या बी सी है या सी बी है, या ये कुछ नहीं कह रहा उनके बारे में. द डेफिनेशन इज साइलेंट ऑन द प्रेजेंस ऑफ एनी अदर थिंग. ओके, तो हमें सिर्फ ए बी बी और सी सी की प्रेजेंस चेक करनी थी, वो हमने चेक करी है. दैट्स इट. क्या रिफ्लेक्सिविटी क्लियर है? इज रिफ्लेक्सिविटी क्लियर? Good. Next one is completeness. तो अभी जो मैं आपको ये डेफिनेशन बता रहा हूँ, दैट्स जस्ट फ्रॉम लॉजिक एंड मैथमेटिक्स पॉइंट ऑफ व्यू. हाउ इनका जो इकोनॉमिक सेंस है, तो वो विल अगेन डिस्कस दीज टॉपिक्स इन माइक्रो इकोनॉमिक्स, तो डोंट वरी अबाउट दैट. अभी सिर्फ मैथ्स के हिसाब से चल रहे हैं. लेटर ऑन हम मैथ्स का यूज़ करेंगे और इकोनॉमिक सेंस समझेंगे. ओके, कुछ भी हम रटेंगे नहीं, अभी सिर्फ मैथ्स यूज़ कर रहे हैं. रिलेशन आर ऑन सेट ए satisfies completeness if for all x y इन ए, कोई भी आप पेयर बनाओ जहाँ पे x और y दे आर नॉट सेम, दे हैव टू बी डिफरेंट. ईदर x शुड बी रिलेटेड टू y और y शुड बी रिलेटेड टू x. तो बाय दिस वी मीन कि x कॉमा y हो या y कॉमा x हो रिलेशन में. ठीक है, ये अगर रिलेशन में है तो हम ऐसे लिख सकते हैं कि y आर x, कि y, या यहाँ पर आप कह सकते हो कि y इज रिलेटेड टू x. ये इसके लिए x इज रिलेटेड टू y, x आर y, सेम थिंग. ओके, समझ जाओगे. हाँ, तो इधर x इज रिलेटेड टू y और y इज रिलेटेड टू x, और बोथ कुछ ना कुछ होना चाहिए ऐसा, तो उसे हम कहते हैं कंप्लीटनेस. कि इट्स, तो थोड़ा सा सेंस में आपको लेट मी गिव यू सम सेंस अबाउट दिस. कि आपके पास ऑल्टरनेटिव्स में 3 है, एक्स वाई जेड. तो कंप्लीटनेस जो प्रॉपर्टी है प्रेफरेंस रिलेशन की, वो ये कह रही है कि कुछ तो बोलो कि एक्स और वाई के बीच में क्या पसंद है. एक्स पसंद है या वाई पसंद है, या चाहे ये बोल दो कि दोनों पसंद है. यू कैन नॉट बी साइलेंट. ओके, यू हैव टू टेल समथिंग. यू बेसिकली कंप्लीटनेस मीन्स कि यू कैन नॉट से आई डोंट नो. आई डोंट नो नहीं चलना चाहिए, अदरवाइज फिर वो रिलेशन कंप्लीट नहीं है. अगर आप बोल रहे हो कि नहीं मुझे पता नहीं है, तो नहीं बनेगी बात. वी नीड दैट रिलेशन टू बी कंप्लीट, अगर उसे आप प्रेफरेंस रिलेशन कहना चाहते हो तो. एंड दैट नीड्स टू बी फॉर ऑल पेयर्स. कि ये नहीं कि सिर्फ एक्स और वाई के बीच में बता दिया कि मुझे वाई पसंद है. जो आपको ये भी बताना पड़ेगा कि एक्स और जेड के बीच में क्या पसंद है. आपको ये भी बताना पड़ेगा कि वाई और जेड को आप कैसे देखते हो. यू कैन नॉट से आई डोंट नो फॉर एनी पेयर्स जो विच यू कैन फॉर्म अमंग द ऑल्टरनेटिव्स प्रेजेंट. ओके, तो दैट्स द इकोनॉमिक सेंस. यू शुड बी एबल टू टेल कि आपको क्या पसंद है, क्या पसंद नहीं है, या दोनों पसंद है. कुछ ना कुछ बताना पड़ेगा. ओके, तो लेट मी राइट दिस एज वेल कि व्हाट दिस मीन्स इज कि आई डोंट नो जो ये है, आई डोंट नो इज नॉट अ पॉसिबिलिटी. ये नहीं होना चाहिए. कुछ ना कुछ तो आपको बताना पड़ेगा, चाहे एक्स प्रेफर टू वाई, चाहे वाई प्रेफर टू एक्स, या फिर इनडिफरेंट, लेकिन कुछ तो बताओगे. ओके, सो अगेन वी हैव ए बी सी, 3 ऑल्टरनेटिव्स का सेट है ए, एंड द रिलेशन इज ए इज रिलेटेड टू बी एंड बी इज रिलेटेड टू सी. ओके, तो ए बी और सी तीनों आ गए हैं यहाँ पर. हाँ जी, तो इज दिस रिलेशन R1 कंप्लीट और नॉट? व्हाट डू यू थिंक? रिलेशन R1 कंप्लीट और नॉट? Yes. So I'm getting mixed answers, no and yes both, but this one is not complete. It is not complete. मैंने बहुत डिटेल में बताया था आपको दैट वाई इट इज़, तो कंप्लीटनेस के लिए क्या चाहिए हमें. तो लेट मी जस्ट टेल यू अगेन कि आपके पास यहाँ पर देर इज़ अ रिलेशन बिटवीन ए एंड बी. आपने ए और बी के लिए बता दिया कि इन दोनों में आपको ए पसंद है, बी और सी में आपको बी पसंद है, बट जो मिसिंग है वो है ए और सी के बीच में रिलेशन, वो मिसिंग है. ओके तो या तो अगर यहाँ पर ए सी या सी ए होता तब कंप्लीट हो जाता. तो आई टोल्ड यू कि दिस शुड हैपन फॉर ऑल पेयर्स, सारे एक्स वाई पेयर्स के लिए होना चाहिए वेयर एक्स इज नॉट इक्वल टू वाई. ओके यानी कि ए और बी के बीच में, बी और सी के बीच में, और ए और सी तीनों पेयर्स के बीच में कुछ मतलब तीनों पेयर का कुछ ना कुछ यहाँ पर रिलेशन में होना चाहिए था. तो एंड दैट तो नॉट कंप्लीट बिकॉज ईदर ए सी और सी ए or both should be there in R1 for completeness. ये रीज़न है. ठीक है, इस वजह से ये रिलेशन कंप्लीट नहीं है. ए और सी के बीच में बताया ही नहीं कि क्या है आपका प्रेफरेंस. ओके हाउ अबाउट ए बी, ए सी, सी ए, बी सी, सी बी, ए, बी बी. What about this? Is this relation complete? Is this relation complete? Everyone is saying yes. Okay, one is saying no. तो मैं आपको बताता हूँ. हमें चाहिए एक रिलेशन ए और बी के बीच में. क्या है? बिल्कुल है, ए बी है. ओके हमें चाहिए बी और सी के बीच में कुछ रिलेशन. क्या यहाँ पर है? हाँ जी, बी और सी है और सी बी भी है. ओके तो बेसिकली ये जो कंज्यूमर है वो इनडिफरेंट है बी और सी के बीच में, क्योंकि वो बी सी और सी बी दोनों लिख रहा है. ऑल राइट व्हाट्स लेफ्ट? क्या यहाँ हमारे रिलेशन में वो ए और सी के बीच में कुछ है? वो भी है, ए सी सी ये दोनों हैं. ऑल राइट हो गया कंप्लीट. नाउ आई थिंक जो जिसको लग रहा है कि कंप्लीट नहीं है, जिसने बोला नो, so he or she might be confused because of this. Okay अगेन फिर से समझो. डेफिनेशन कह रही है कि आप सारे x नॉट इक्वल टू y वाले पेयर देखो. वो कुछ नहीं कह रहा है कि अगर x इक्वल टू y वाले जो पेयर्स हैं वो हैं नहीं है. उसने कुछ नहीं कहा आपको. ठीक है, डेफिनेशन इज साइलेंट ऑन द प्रेजेंस ऑफ ए बी बी सी सी. इसे कोई लेना देना नहीं है. इसे बस इसका बस इतना लेना देना है कि जो भी डिफरेंट बंडल्स अवेलेबल हैं उन सब के बीच में कुछ ना कुछ रिलेशन एस्टेब्लिश करना पड़ेगा. दैट्स व्हाट कंप्लीटनेस इज सेइंग. ए बी बी सी सी से इसे कोई फर्क नहीं पड़ता. इसे ए बी सी और ए सी से फर्क पड़ता है. ये जो पेयर्स हैं जहाँ पे एक्स और वाई अलग अलग है उससे फ़र्क पड़ता है. ओके वो हमने देख लिया कि वो कुछ ना कुछ रिलेशन ए बी के बीच में है, कुछ ना कुछ रिलेशन ए और सी के बीच में है, कुछ ना कुछ रिलेशन बी और सी के बीच में है. दैट्स इट. हमें बस इतना चेक करना था. क्या ये बात क्लियर है अब? इज इट फाइन? Yeah? Okay. Just for your information, चाहे मैं लिखूं A R B, A is related to B. It is same as A is at least as good as B. It is same as A comma B in the relation. ये तीनों बातें बिल्कुल सेम है. ओके इस क्वेश्चन से हटके ये तीनों चीजें सेम होती हैं. ठीक है. A is related to B. A क्योंकि जो हमारा बेसिक जो रिलेशन है दैट्स एटलीस्ट एज गुड एज रिलेशन. इसका यूज करके आप रिफ्लेक्सिव का भी आप सेंस बना सकते हो. रिफ्लेक्सिव इज बेसिकली अबाउट कि हर बंडल अपने आप जितना तो अच्छा होगा ही. ओके एवरी बंडल इज एटलीस्ट एज गुड एज इट सेल्फ. दैट्स व्हाट रिफ्लेक्सिविटी प्रॉपर्टी सेज एंड दैट मेक्स सेंस. हर कोई या हर चीज अपने आप जितनी तो अच्छी होती है. लाइक 4 इज ग्रेटर देन इक्वल टू 4, 10 इज ग्रेटर देन इक्वल टू 10. ये चीज हर नंबर पे सेटिस्फाई करेगी. Any number x is greater than equal to x. Similarly, for any bundle A, it has to be at least as good as itself. So that's what reflexivity says. So that's the intuition behind reflexivity. इसीलिए it says कि A, B, B, C, C तीनों होने चाहिए because every bundle is at least as good as itself. लिख सकते हो आप reflexivity में. वैसे हम ये माइक्रो में लिखेंगे. अगर आपको अभी लिखना है यू कैन राइट इट. एवरी बंडल इज एटलीस्ट एज गुड एज इट सेल्फ. नाउ वी आर एट ट्रांजिटिविटी. और यही वो चीज़ है जहाँ पर हम बहुत डिटेल में इम्प्लीकेशंस का यूज़ करने वाले हैं. आई एम गिविंग एन हेड्स अप. बी रेडी फॉर यूजिंग इम्प्लीकेशंस. डेफिनेशन देखो. रिलेशन आर on the set of alternatives satisfy transitivity. If for all x, y, z in A, it is dealing with triplets. ये डाउट अभी भी क्लियर नहीं हुआ. हमने यहाँ लिखा है x नॉट इक्वल टू वाई. हाँ मैं भी यही कह रहा हूँ. हमने लिखा है x नॉट इक्वल टू वाई यानी कि वो बात कर रहा है ए बी, बी सी और ए सी के बीच में रिलेशन की. अगर रिलेशन के अंदर दोनों इक्वल वाले हैं बेसिकली यू कैन सिंपली इग्नोर दिस. कंप्लीटनेस की डेफिनेशन के लिए यू जस्ट नीड टू इग्नोर दिस. इनका कोई लेना देना नहीं है कंप्लीटनेस की डेफिनेशन से. ओके लेना देना है ए बी, ए सी, बी सी. जो ऐसे पेयर, ऐसे एक्स वाई पेयर जहाँ पर एक्स और वाई इक्वल नहीं है आपको उनको जाके चेक करना है कि उनके बीच में रिलेशन है या नहीं है. इनकी प्रेजेंस आपको मैटर नहीं करनी चाहिए वाइल चेकिंग द डेफिनेशन ऑफ कंप्लीटनेस. ओके दैट्स व्हाट दिस मीन्स. इज इट फाइन? अभी क्लियर है? ओके ट्रांजिटिविटी. रिलेशन आर ऑन ए सेटिस्फाई ट्रांजिटिविटी इफ फॉर ऑल एक्स वाई जेड. अगर सारे एक्स वाई जेड के लिए x comma y is in the relation and y comma z is also in the relation, which means x is at least as good as y is at least as good as z, then this implies that x z should also be in the relation. Okay, it's like अगर 10 जो है वो 5 से बड़ा है और 5 जो है वो 2 से बड़ा है तो ऑब्वियसली 10 should be greater than 2. Okay, that's what transitivity is. It's not a perfect example, it's a crude, it's a raw, it's a rough example to understand this thing. Okay? क्योंकि हमें माइक्रो इकोनॉमिक्स के हिसाब से इसको देखना है अल्टीमेटली. तो दिस वन इज अ मैथमेटिकल एग्जाम्पल. एनीवेज, ट्रांजिटिविटी की हम बात कर रहे हैं तो ये है. और अगेन पहले मैं आपसे चेक करवाऊंगा, फिर मैं देखता हूँ आपको डेफिनेशन पढ़ना कितना और समझना कितना आ गया. सो अगेन वी हैव अ सेट ऑफ ऑल्टरनेटिव्स ए बी सी एंड रिलेशन इज a comma b. A is at least as good as b. Is this relation transitive? I need everyone's answer. Try करो. It's nice to see some progress. I wasn't expecting anyone to say yes, but 50% of the students are saying yes, which is a good progress. कि आपको समझ में आ रहा है. It is transitive. This is transitive. Okay. अगेन मैं लास्ट में एक्सप्लेन करूंगा. एक बार मैं चेक कर लूं कि आपको कितनी बात समझ में आई है. ए बी बी ए, हाँ जी. इज इट ट्रांजिटिव? इज दिस रिलेशन ट्रांजिटिव? Yes, no. तो कुछ लोग जो पहले सही थे अब गलत हैं, तो विच मीन्स कि उनको परफेक्टली नहीं समझ में आई है डेफिनेशन. दिस वन इज नॉट ट्रांजिटिव. ओके, चलो. आई थिंक एट दिस पॉइंट आई कैन एक्सप्लेन. ओके, चलो समझते. मैंने आपको कहा था कि यहाँ पर यूज़ होगी इम्प्लीकेशंस की डेफिनेशन. या देखो, इम्प्लीकेशंस की ट्रुथ टेबल का यूज़ होगा. एक बार देख लो इसे. डेफिनेशंस के लिए इफ़ देन डेफिनेशंस को आप यहीं से चेक करते हो. ट्रू आएगा तो डेफिनेशन होल्ड करेगी, फॉल्स आएगा तो डेफिनेशन होल्ड नहीं करेगी. ओके, तो अगर जो डेफिनेशन का इनिशियल पार्ट है, इफ़ वाला पार्ट है, कि अगर ए बी है, बी ए है, बी सी है, देन ए सी होना चाहिए. ये डेफिनेशन है. तो यहाँ पर ये वाला जो पार्ट है ना, दैट्स पी. अगर ये होगा तो पी ट्रू होगा, अगर ये होगा तो क्यू ट्रू होगा. इसके अलावा अगर ये नहीं होगा, और ये नहीं होगा का मतलब सिर्फ इतना है, तो भी ये पूरी चीज़ ट्रू नहीं है, फॉल्स हो जाएगी. सिर्फ इतना है तो भी ट्रू हो जाएगी. दोनों नहीं है तो भी तो भी ये फॉल्स हो जाएगा. इफ ए बी इज मिसिंग देन पी इज फॉल्स. इफ बी सी इज मिसिंग पी इज फॉल्स. बोथ आर मिसिंग पी इज फॉल्स. जब तक दोनों प्रेजेंट नहीं होंगे तब तक पी ट्रू नहीं होगा. ठीक है ना. नाउ दैट मीन्स कि अगर सिर्फ ए बी प्रेजेंट है तो पी फॉल्स है, ओके और अगर पी फॉल्स है उसके बाद क्या हो रहा है डजेंट मैटर, द डेफिनेशन इज ट्रू। वही है हमारा R1। देखो R1 ए बी है, ए इज प्रेफर्ड टू बी, वो कह ही नहीं रहा कि इसके आगे जा ही नहीं रही बात। इट्स लाइक कि इसने बोला बस 10 इज ग्रेटर देन 5, क्या दिक्कत है हमें इस बात से? हाँ है, कोई लूप बना ही नहीं ना, देर इज नो। मैं पहले आपको थोड़ा और बात समझाता हूँ कि ट्रांजिटिविटी की ज़रूरत क्या है, फिर वापस आएंगे थोड़ा आपको और अच्छे से समझ में आएगा। प्रॉब्लम ये आती है हमें माइक्रो इकोनॉमिक्स में और प्रेफरेंसेस में, हमें प्रॉब्लम क्या आती है? प्रॉब्लम ये कि मान लो हमने बोला कि ए इज़ प्रेफर टू बी, बी इज़ प्रेफर टू सी एंड देन सी इज़ प्रेफर टू ए। तो ये कंपैरिजन ख़राब कर देता है। कैसे? ये देखो, ये एक लूप बन गया। कैसा? हमने बोला ए इज़ प्रेफर टू बी, फिर हमने बोला बी इज़ प्रेफर टू सी एंड देन फिर हमने बोला सी इज़ प्रेफर टू ए। हालांकि इन दोनों का अगर आप यूज़ करो, वो जो बिग वाली बात थी कि 5 ग्रेटर देन 10 ग्रेटर देन 5, 5 ग्रेटर देन 2, तो 10 बड़ा होना चाहिए 2 से, कि हमने बोला कि मुझे मोमोज ज़्यादा अच्छे लगते हैं चाउमीन से, फिर हमने बोला कि मुझे चाउमीन ज़्यादा अच्छी लगती है मंचूरियन से, एंड देन लास्ट में मैं कह रहा हूँ कि मंचूरियन ज़्यादा अच्छे लगते हैं मोमो से। तो ये लूप क्रिएट कर रहा है, क्योंकि इन दोनों के बेसिस पर देखा जाए तो मोमोज प्रेफर होने चाहिए थे मंचूरियन पर, बट लास्ट में एकदम से आपने देयर इज सडन चेंज ऑफ प्रेफरेंसेस कि अचानक से मंचूरियन कहाँ से ऊपर आ गया मोमोज से, क्योंकि आप तो नीचे की तरफ जा रहे थे कि मोमोज बेटर देन चाउमीन, चाउमीन बेटर देन मंचूरियन। देन सडनली जब बात हुई इन दोनों के कंपैरिजन की तो ये उल्टा हो कैसे गया? ओके, एक्चुअल में ऐसा हो सकता है कि आपको इन दोनों में मंचूरियन पसंद हो लेकिन मोमोज और मंचूरियन में मंचूरियन पसंद आ जाए, ऐसा पॉसिबल है। बट पॉसिबल होना और ट्रांजिटिविटी फॉलो करना अलग अलग बात है। पॉसिबल है मान लिया, अलग बात है। वापस आते हैं ट्रांजिटिविटी पर। प्रॉब्लम यह है कि एक लूप क्रिएट कर देगा और हम कंपैरिजन नहीं कर पाएंगे और फिर वो पूरा का पूरा मॉडल तोड़ देगा। तो दिस इज अ प्रॉपर्टी वी रिक्वायर टू बिल्ड अप द होल मॉडल। ओके, अगर इस तरीके से लूप बन जाएगा देन वील नॉट बी एबल टू कंपेयर बंडल्स परफेक्टली। ओके, तो ये प्रॉब्लम आती है। नाउ गेटिंग बैक, लूप, तो अल्टीमेटली हमारी पॉइंट ये है कि लूप नहीं बनना चाहिए इस तरीके का, ताकि हम कंपेयर कर पाएँ। तो अगर हमारे पास सिर्फ इतनी सी बात है कि ए इज़ प्रेफर टू बी, बात खत्म, लूप नहीं बन रहा है। ठीक है, लूप नहीं बन रहा है, तो इंट्यूशन वाइज लूप नहीं बन रहा है, ट्रांजिटिविटी होल्ड कर रही है। एंड मैथमेटिक्स वाइज पी इज फॉल्स, क्योंकि ए बी है बी सी नहीं है। ठीक है, ए बी है बी सी नहीं है। बेसिकली हमारे पास दो पेयर होने चाहिए थे, जिसमें पहले पेयर का ये दूसरा नंबर और दूसरे पेयर का पहला नंबर जब सेम होता है तब ये P वाली जो बात होती है वो ट्रू होती है, तो P ही फॉल्स है। ओके, तो ये जो ट्रांजिटिविटी हमें यहाँ पर सेटिस्फाइड मिल रही है, दैट्स बिकॉज फॉल्स इम्प्लाइंग एनीथिंग इज ट्रू, ये उसकी वजह से मैथमेटिकली दैट्स द रीजन। एंड इकोनॉमिक्स वाइज, माइक्रो इकोनॉमिक्स वाइज लूप क्रिएट नहीं हो रहा है। ठीक है, बिफोर आई मूव फॉरवर्ड, क्या ये बात क्लियर है? मैथमेटिक्स वाइज फॉल्स इम्प्लाइंग एनीथिंग इज ट्रू, इसलिए ट्रांजिटिविटी है। इकोनॉमिक्स वाइज लूप नहीं क्रिएट हो रहा है, सिर्फ ए बी है, दैट्स इट, ए इज प्रेफर टू बी, इसलिए ट्रांजिटिविटी सेटिस्फाइड है। क्या ये बात सबको क्लियर है? आई नीड अ यस और नो। यस, ओके। नाउ अब इस वाले को समझो, नोटिस करो, और आपको पता होगा कि सेट के अंदर ये 1 2 हो या 2 1 हो, सेम बात है, राइट? तो ज़रूरी नहीं है कि जिस ऑर्डर में ये लिखे हुए हैं, मतलब ये वाला ऑर्डर मैटर करता है कि इस ब्रैकेट के अंदर कौन सा पहले लिखा है, दैट्स अ ऑर्डर्ड पेयर। बट सेट के अंदर जो एलिमेंट्स हैं वो कैसे लिखे हुए हैं उसका ऑर्डर मैटर नहीं करता है। ये दोनों सेट जो है वो सेम है, चाहे 1 2 लिखो या 2 1 लिखो, दैट सेम थिंग। सो ऑन द बेसिस ऑफ दैट नोटिस करो अगेन, पहले बंडल का दूसरा एलिमेंट और दूसरे बंडल का पहला, ये दोनों सेम है। ओके तो P तो ट्रू हो चुका है, P ट्रू हो गया है, जो मैंने आपको थोड़ी देर पहले कहा था। P कब ट्रू होगा? आपको दो पेयर चाहिए सेट रिलेशन के अंदर जहाँ पर पहले बंडल का दूसरा एलिमेंट, दूसरे बंडल का पहला एलिमेंट ये सेम हो जाए। तो इस हमारे वाले केस में दिस थिंग इज ट्रू, P ट्रू हो गया है, आगे जाना पड़ेगा। अगर P ट्रू हो गया है, अगर P ट्रू हो गया है, डेफिनेशन तब होल्ड करेगी जब Q भी ट्रू निकले, तभी मैं कह सकता हूँ डेफिनेशन होल्ड कर रही है। तो दैट मीन्स अब क्या चाहिए मुझे, देयर शुड बी द प्रेजेंस ऑफ एक्स जेड होना चाहिए। हमारे पास ए बी है, हमारे पास बी ए है, डेफिनेशन के अकॉर्डिंग एक्स जेड, एक्स की जगह है ए, जेड की जगह है ए, तो विच मीन्स रिलेशन के अंदर ए ए होना चाहिए था। सिर्फ इतनी बात बताओ, समझ में आई? डेफिनेशन के अंदर ए ए होना चाहिए था। क्या ये बात क्लियर है? देयर इज अ डाउट रिगार्डिंग लूप, मैं उस पर दोबारा आ जाऊंगा, बट अभी मैथ्स पर रहते हैं। क्या ये बात क्लियर है? ओके तो ए ए होना चाहिए था। इसके अलावा नोटिस कि मैं इसे यहाँ बी ए पहले लिख सकता था और ए बी बाद में। नाउ अगेन सेम थिंग, यहाँ का ए और यहाँ ये सेम है, तो अब नॉट जस्ट ए ए, बी बी भी होना चाहिए था। ठीक है, तो दिस इज नॉट ट्रांजिटिव बिकॉज ए ए एंड बी बी आर मिसिंग। नॉट जस्ट ए ए, बी बी भी चाहिए, क्योंकि ये जो P वाली बात है, P जो ट्रू है वो दो तरीके से ट्रू है। चाहे आप ऐसे लिखो तो भी P ट्रू है, ऐसे लिखो तो भी P ट्रू है। इस वाले केस में ए ए मिलना चाहिए, इस वाले केस में बी बी मिलना चाहिए, तो ए ए और बी बी आर मिसिंग। अगर ये होते तो ट्रांजिटिव होता, अगर सिर्फ ए ए होता बी बी नहीं होता तो भी ट्रांजिटिव नहीं है, अगर सिर्फ बी बी होता ए ए नहीं होता तो भी ट्रांजिटिव नहीं है। ए ए और बी बी दोनों चाहिए। अब क्या ये वाली बात क्लियर है? सबको क्लियर है? ऑल राइट, एक और देखो, ए ए बी बी एंड सी सी। व्हाट अबाउट दिस, ट्रांजिटिव और नॉट ट्रांजिटिव? ट्रांजिटिव और नॉट ट्रांजिटिव? यस, नो, बहुत देर लगा रहे हो। ट्रांजिटिव, some are saying yes, some are saying no। कैसे करोगे इस जालिम दुनिया का सामना? ए है, बी बी है, सी सी है, क्या ये दोनों इक्वल हैं? नहीं। क्या ये दोनों इक्वल हैं? नहीं। क्या ये दोनों इक्वल हैं? नहीं। तो पी तो ट्रू हुआ ही नहीं ना। पी ट्रू कब है? दो बंडल्स हैं, वो आर में हैं, और इस तरीके से हैं कि मैं इनके बेसिस पर कुछ आगे कंक्लूड कर पाऊँ। कैसे? समथिंग लाइक दिस, कि 10 बड़ा है 5 से, 5 बड़ा है 2 से, ये कॉमन आया, इसके बेसिस पर मैं कह पाता हूँ कि 10 बड़ा है 2 से। ओके, क्लियरली दिख रहा है ना? इट्स काइंड ऑफ इक्वेशन 1, इक्वेशन 2, फ्रॉम 1 एंड 2 क्लियरली दिख रहा है कि ये दोनों में कॉमन है। तो फ्रॉम 1 एंड 2 आप बोल सकते हो कि फिर 10 बड़ा हो गया 2 से। ये है हमारी ट्रांजिटिविटी। ठीक है। सो सिमिलरली, बट अगर लिखा हुआ है कि 10 बड़ा है 5 से, 6 बड़ा है 4 से, तो मैं क्या करूं? तो क्या करें? है तो है कुछ, क्या है यहाँ से? क्या कंक्लूजन निकाल लोगे आप? कॉमन नहीं है ना। देर इज नथिंग कॉमन हेयर कि मैं इन दोनों का यूज करके कंक्लूजन निकाल पाऊँ। कॉमन ही नहीं है। दे डोंट हैव एनीथिंग इन कॉमन। सो या थोड़ा और ये देखो कि मे बी 12 बड़ा है 11 से। ठीक है, ये देखो 10 बड़ा है 5 से, 12 बड़ा है 11 से। ना क्या मैं बोल सकता हूँ कि 10 बड़ा होना चाहिए 11 से? कोई लेना देना ही नहीं है। आई कैन नॉट कंपेयर दीज थिंग्स। देर इज नथिंग टू कंपेयर बिकॉज देर इज नथिंग इन कॉमन। दैट्स द पॉइंट। नाउ गेटिंग बैक, यहाँ पे ए है तो है, यहाँ बी है, सी है। क्या कंपेयर करूँ? सब कुछ अलग अलग है ना। वी डोंट हैव दीज टू कॉमन। वी डोंट हैव बी एंड सी, ये यहाँ पर कॉमन नहीं है, दोनों अलग अलग है। वी डोंट हैव कॉमन। ओके, कॉमन ही नहीं है, सो कोई प्रॉब्लम ही नहीं है। बेसिकली पी इज नॉट ट्रू। पी वाली बात ट्रू हुई नहीं। तो दिस वन इज अगेन यूजिंग दिस लॉजिक R1 वाला कि फॉल्स इम्प्लाइंग एनीथिंग इज ट्रू। बाय एंड बाय फॉल्स व्हाट वी मीन इज कि ये वाला पार्ट है ही नहीं। ओके, तो P इज फॉल्स एंड फॉल्स इम्प्लाइंग एनीथिंग इज ट्रू। एंड द अदर थिंग इज लूप क्रिएट नहीं हो रहा है। ओके, मैं वापस लूप पे आऊँगा। जिसको समझ में आ गया उसके लिए बोल रहा हूँ, लूप नहीं बन रहा है यहाँ पे, कोई प्रॉब्लम नहीं आ रही कंपैरिजन में। एंड लूप क्या है? चलो मैं लूप पर वापस आ ही जाता हूँ। बाय लूप व्हाट वी मीन इज, पहले ट्रांजिटिविटी की बात करते हैं। इफ ए इज प्रेफर्ड ओवर मोमोज, प्रेफर्ड ओवर चाउमिन, चाउमिन प्रेफर्ड ओवर समोसा। ओके, ये हो गया कॉमन। देन कंक्लूजन क्या निकलना चाहिए कि मोमोज आर बेटर देन समोसा। यहाँ लूप नहीं क्रिएट हो रहा है। तो लूप नहीं क्रिएट होना क्या होता है, पहले वो देख लेते हैं कि ये मोमोज, ये चाउमिन, ये समोसा। मोमोज बेटर है चाउमिन से, चाउमिन बेटर है समोसे से। ओके, सो नाउ अगर समोसा बेटर हो गया मोमोज से तो लूप क्रिएट हो रहा है। यू जस्ट कीप ऑन रोटेटिंग। ओके, सी दिस, देयर इज अ रोटेशन हियर। इसे मैं कह रहा हूँ लूप। और वो लूप क्या है? मोमोज मोर देन समोसा, मोर देन चाउमिन, मोर देन मोमोज, मोर देन। तो ये ना आपस में पूरा कंपैरिजन खराब हो रहा है। लेट मी टेल यू वाई। पहले मैं एक बार लिख दूँ क्या वो लूप क्या बनता है। मोमोज बेटर देन चाउमिन, बेटर देन समोसा, मोर देन M, मोर देन C, मोर देन S। तो पूरा लूप क्रिएट हो जाएगा। वो कैसे क्रिएट होगा देखो। हमने बोला मोमोज अच्छा लगता है चाउमिन से, C लिख देते हैं। चाउमिन बेटर लगती है समोसे से। यहाँ से सिर्फ इतनी बात पर क्लियर दिखना चाहिए हमें कि फिर इस हिसाब से तो, क्योंकि ये कॉमन है तो इस हिसाब से तो मोमोज बेटर होना चाहिए समोसे से। ये हो गई ट्रांजिटिविटी। लेकिन अगर हमने बोला मोमोज बेटर है चाउमिन से, चाउमिन बेटर है समोसे से, एंड फाइनली हमने बोल दिया कि समोसा बेटर है मोमोज से, तो ये कंपैरिजन खराब कर रहा है। ठीक है, क्योंकि इनका यूज करके कंक्लूजन आना चाहिए था, ये पूरा कंपैरिजन खराब हो गया। अब ये बात कहाँ से अचानक आ गई कि तुमको पहले ये अच्छा लग रहा था, मोमोज बढ़िया लग रहे थे चाउमिन से, चाउमिन ज़्यादा अच्छी लग रही थी समोसे से, तो समोसा शुड हैव बीन योर लीस्ट प्रेफर्ड ऑल्टरनेटिव। बट अचानक से यू आर सेइंग कि योर लीस्ट प्रेफर्ड ऑल्टरनेटिव इज बेटर देन योर बेस्ट ऑल्टरनेटिव, ये कैसे हो गया? दैट्स द इशू, ठीक है। तो अब इससे उल्टे फुल्टे कंक्लूजन, एक लूप क्रिएट हो जाता है, और वो लूप देखो क्या बन गया, m मोर देन c मोर देन s, फिर s बेटर आ गया m से, फिर m वापस आ गया ये c से, फिर ये c बेटर आ गया s से, फिर s बेटर आ गया m से, ये बन रहा है एक लूप। क्या अब लूप क्लियर है क्या है? दिस इज द लूप आई एम टॉकिंग अबाउट। ऐसा होने से एक लूप क्रिएट हो जाता है एंड वी आर नॉट एबल टू टेल एग्जैक्टली कि कौन किससे बेटर है। यहाँ तो पूरा लूप बन गया। लूप क्या है ये देखो, प्रॉब्लम क्या आ रही है कि यहाँ हम कह रहे थे मोमोज बेटर है चाउमिन से, ओके, लेकिन सडनली लूप के अंदर चाउमिन बेटर देन मोमोज भी आ गया, तो ये एक लूप बन गया जिसकी वजह से पूरा कंपैरिजन खराब हो रहा है। क्या अब लूप वाली बात क्लियर है? एवरीवन, लूप क्लियर है? ग्रेट। तो यही वाली बात, इसीलिए हमें ट्रांजिटिविटी चाहिए। दैट्स द रीज़न वी नीड ट्रांजिटिविटी इन प्रेफरेंस रिलेशन, नहीं तो हम ऑल्टरनेटिव्स को ठीक से कंपेयर नहीं कर पाएंगे। ओके, सो नाउ गेटिंग बैक, ए बी बी सी सी, ये सिर्फ इतना कह रहा है कि हाँ समोसा इज एटलीस्ट एज गुड एज समोसा, चाउमिन इज एटलीस्ट एज गुड एज चाउमिन, एंड तीसरा क्या था, मोमोज इज एज गुड एज मोमोज एज इट इटसेल्फ। ओके, तो कोई प्रॉब्लम ही नहीं है, देयर इज नो लूप। एंड मैथमेटिकली जो हमारी पी वाला पार्ट है कि इफ़ यू हैव टू पेयर्स जहाँ पे आप उन्हें बीच में कुछ कॉमन में, तो पी इज नॉट ट्रू वाली बात है। तो दिस इम्प्लाइज ट्रांजिटिव, ठीक है। क्या अब R3 ट्रांजिटिव है? उसका लॉजिक क्लियर है? इज द लॉजिक फॉर ट्रांजिटिविटी ऑफ R3 क्लियर? R4 AB AA BC AC CC. What about this? Is it transitive? Is it transitive? Everyone is saying yes, और मुझे इस बार पता नहीं है, चेक करते हैं, इतना डायरेक्ट भी नहीं है ये। तो सबसे पहले ए बी बी सी ए सी, परफेक्ट। बी कॉमन आया था, ये दोनों बना रहे हैं पी वाला पार्ट, पी इज देयर, पी इज ट्रू, और कंक्लूजन में ए सी मिलना चाहिए था, दैट ए शुड बी एज गुड एज सी, तो वो चीज़ मिल गई। तो ये वाली बात तो ठीक है, यहाँ हमें चलेगा। व्हाट एल्स? कोई और भी पेयर बन रहे हैं क्या? ये है एक, ये देखो ए सी है सी सी है, ए सी है सी सी है, एंड दैट जस्ट शुड से दैट ए सी होना चाहिए जो कि पहले से है। वो ट्रिवियल हो गया, ट्रिवियल मतलब ऑब्वियस, तो ऑब्वियस है ये वाला पार्ट। तो व्हाट एल्स? और भी कोई पेयर बन रहा है क्या? यहाँ बन रहा है एक, ए बी है बी सी है, तो ये तो हो गया, ये तो सबसे पहले चेक कर लिया था। और क्या है? ए बी सी सी, हाँ, अगर मैं ए पहले लिख दूँ और ए बी बाद में लिख दूँ, ये भी एक पेयर है, ये ए कॉमन आ गया, विच विल से दैट ए बी होना चाहिए जो कि पहले से है। हाँ, तो ये भी ट्रिवियल ही है, यस। तो मैंने सारे जितने पेयर बन सकते थे पी के अंदर, वो इस वाले पी के अंदर वो बन रहे, देख लिया हमने, 3 बन रहे थे और सारे केस में Q इज ऑल्सो ट्रू, सो विच मीन्स दिस इज ट्रांजिटिव, नो इशू हेयर। ठीक है, नाउ आई गेस सबको क्लियर हो गया कि ट्रांजिटिविटी कैसे चेक करनी है। ठीक है, सो दैट्स हाउ वी चेक फॉर रिफ्लेक्सिविटी, ट्रांजिटिविटी एंड कंप्लीटनेस। इज इट फाइन? तो इसके बाद आपका काम होगा लॉजिक और बाइनरी रिलेशन के ऊपर क्विज के क्वेश्चन सॉल्व करना। ओके, ट्राई दोस एंड देन फॉर ऑल द फाउंडेशन लेक्चर्स वी हैव अ टेस्ट। ओके।